Professor Reddy, I think we may start now.
Yeah, I think, yeah.
Yeah, it's almost, it's 9:30.
Okay. Yeah, I will start. Okay. Shall I start?
Yeah, sure.
Yes, go ahead.
Yeah. I think Matai sir is ready.
Yeah, Matai sir is ready. Yeah. Good morning to everybody. It's my immense pleasure to say a few words and to introduce Professor A.M. Matai. Professor A.M. Matai is the Emeritus Professor of Mathematics and Statistics, McGill University, Canada. And he is an Indian mathematician who has worked in statistics, applied analysis, application of special functions, and astrophysics. And he got his MSc statistics first class and first rank and gold medal in the year 1959.
I don't see him.
University of Kerala. And he has published more than 25 books with highly reputed publishers, more than 300 research publications. And Professor Matai sir was the former president of Indian Mathematical Society, former chairman of the Kerala Statistical Commission, member of Lok Kerala Sabha, president of the Society for Special Functions and their Applications. And in 1998, he received the Founder Recognition Award from the Statistical Society of Canada. He is a fellow of the National Academy of Sciences, India, and a fellow of the Institute of Mathematical Statistics. He has also received the fellow of Indian Society for Probability and Statistics, and he was the recipient of first Professor C.R. Rao Lifetime Achievement Award from ISPS. So I am very happy, sir, to introduce yourself. There are only, we can say that Professor Matai sir, among few, he has contributed so much for the nation development in statistics in India. So I am very happy to introduce you, sir. Sir, yeah, please, sir. Please go ahead.
Thank you. Thank you very much.
Thank you. Sir is going to speak on Eigen value problem in the real and complex domains, sir. So now I request you, sir.
Eigen value problem. Okay.
Grant permission to share, please. I'm asking the people in Hyderabad.
It's already, this thing, it's already kept. You can share.
Nice, okay.
Permission is already given, sir.
Okay.
So on bottom of the screen, you'll see share screen, sir. Mataya, sir. Share screen.
Yes, sir, please see that upward
PPT.
arrow mark with the green color. Please click that.
Yes.
Yeah. Then there should, something is coming there, right? Like screen. Then click that screen and then full
Screen
screen.
coming here says host disabled participants screen sharing.
Oh.
My screen is not coming.
Sir, check once again.
Maybe-
Close the window and then check once again. Close that window, sharing window, and then open it again.
No.
Yeah, we can see
Yeah.
your screen, sir.
Yeah. Now the screen is coming, sir.
Yeah.
Now it's coming.
Yes,
Okay.
sir. Yes, sir. Now
this
it's
fine,
my
sir.
screen is already.
yeah, now
Can
it's
you hear?
okay.
Can you hear me?
Yes,
Yeah,
sir.
yeah, yeah.
Yes, sir.
You can hear as well as you can see the screen also.
Yeah, now screen also.
Sir, we can hear you as well as your screen is also visible, sir.
Okay. So I'm going to talk about eigenvalue problems in the real and complex domain. In the early 1960s and 70s, there were a lot of activities on this particular problem. That is a distributions of either largest eigenvalue or the smallest eigenvalue of gamma distributed or matrix variate gamma distributed or matrix variate type 1 beta distributed or matrix variate type 2 beta distributed cases. So I have looked into that problem, and I find that all the representations available are very complicated type of representations are there in the literature. So I found that it's very simple and one can give explicit solutions, explicit forms where everybody can compute. And I'm going to give something about those lines for all the three cases. That is general matrix variate gamma eigenvalue problem. That is distribution of smallest eigenvalue or largest eigenvalue, or joint distributions of a number of eigenvalues, whatever you want, as well as distributions of eigenvalues of matrix variate type 1 beta distributed case and type 2 beta distributed cases. Now, these eigenvalues are actually used when we talk about the central Vishal distribution or eigenvalue problems in test hypothesis in multivariate statistical analysis, or eigenvalue problems also come in analysis of variance and related areas. So I have also given the corresponding distributions in the complex domain, because it is not very difficult to extend the theory for the real variables to the complex domain. So now, in multivariate analysis in general, usually the subject matter becomes complicated because of too many symbols appearing and too many subscripts, superscripts, and all that you needed to represent the various items. So I have found a way of simplifying all those things. I treat mathematical variables and random variables alike. No double notation is used for random variables. All the variables, scalar variables, will be denoted by small letters, and vector matrix variables will be denoted by capital letters. So, and variables in the complex domain will be denoted by with a tilde like this. Scalar variables as well as matrix variables. Therefore, in that way, the notational problem is simplified. Now, I need some ideas about any of the determinant will be denoted like this or like that. In the complex case, absolute value of the determinant or modulus of the determinant will be denoted like this. Then the standard notations like Wedge product or differentials, that is the standard notation. I use dx. And if it's a symmetric matrix, then a real symmetric matrix, then dx will be like that. And in the complex case, it's a complex matrix random variable. The complex case, the wedge product here will be defined as wedge product in the real part and the wedge product in the complex part. And integrals of this type means fx tilde is a real valued scalar function of with matrix argument x. Whether x is real or complex, f is real valued, only integrals of that type will be used, considered here. For a density, of course, we need a real valued function, scalar function, so that it is non-negative and total integral is 1, whether x is real or in the complex domain. Now, a star will be used like this for Hermitian matrices. This means that x is Hermitian. And for positive definiteness, I use a standard notation, that is this type of a notation. This means the matrix A is positive definite. This quadratic form is positive definite. Other notations will be standard ones. Now, there will be a book of around 1,000 pages coming soon. It's multivariate analysis in the real and complex domain, and authored by me and my co-authors. And it should appear between April and June of 2022. And an enlarged version of this paper is available there with examples and illustrations. And I have already sent the paper to the organizers. Those who would like to get copies, you can get the copies from the organizers. The slides are also fully sent there, and you can get those things. Now, here is our matrix variate gamma distribution, gamma density. So I denoted it by F1. These are the conditions. In statistical problems, the parameters are usually real, but all the theory will go through for complex parameters also. And hence I am giving the conditions for the complex parameters. When it is real, remove R and say alpha greater than P minus 1 by 2. Gamma P alpha, that is, I call it, it is known by different names in the literature. I call it the real matrix variate gamma because it is associated with a matrix variate gamma integral of this type. Therefore, I call it a matrix variate gamma. This is the real case, and its expression will be like this, and that we can easily derive. It's a standard result. In the complex case, the matrix variate the gamma distribution with scale shape parameter alpha and scale parameter matrix B, positive definite B, is of this type. This is the absolute value determinant. This is absolute value determinant. Those slight changes are there. This is, I call it complex matrix variate gamma because it is associated with a complex gamma integral of this type. Now, this is type 1 beta, the standard type 1 beta, real matrix variate type 1 beta. It is of this form, determinant of x raised to alpha minus this one, determinant of I minus x, the range is support is like that. And in the complex domain, the corresponding type 1 beta densities of this form. Slight changes are there. These are the corresponding matrix variate gammas. And here absolute values are there. Here also absolute values are there. Otherwise, it is very parallel to the real case. And the real type 2 beta, the function will be of this form. This is the ordinary determinant. This is determinant of I plus x. And these are the real matrix variate gammas. And the corresponding case for the complex, this is type 2 beta distribution in the complex domain. Similar to this, instead of determinant here, I have the absolute value determinant, and in the exponent there is slight change here, and here also here the exponent is the same in the real case as well as it is absolute value determinant. Those are the slight changes so that one can look into the parallel results. Now what I will do, I will need is when you have a real positive definite or a Hermitian positive definite P by P matrix, I would like to convert that into the eigenvalues. So the conversion formula is the following. That is, this is in the real case. U is my real positive definite matrix. Here U is Hermitian positive definite matrix in the complex domain. So when you convert it, this is the wedge product of the lambdas. Lambdas are the eigenvalues of U, and this part will be coming, that is coming from integrating out the differential elements of the orthonormal matrix. Here this is the corresponding differential integral of the differential element corresponding to the unitary matrix. And the difference between the two is, here I have this type of a factor, pi I less than j lambda I minus lambda j, and here it is in the complex case it will be the square of this, and this part is also slightly different. Otherwise they are very similar. Now once you convert from a type, say for example, if you look into the matrix variate gamma distribution density, I had already given the density, the corresponding density, joint density of the eigenvalues will be like this. This part will be there coming from your determinant of e raised to something. This part is coming from the e raised to trace something, and this part is coming from that differential element. And in the complex domain, for the matrix variate type, the matrix variate gamma in the complex domain, the joint distribution of the eigenvalues will be like this. This is the structure of it, and this part is slightly different from this. Now, similarly for the type 1 beta, type 2 beta, I have given the various. This is the real case, this is the complex case, this is the real type 2, this is complex. That is the joint distribution of the eigenvalues coming from those densities. Coefficients are given here. Now, when you look into the structure of it, any of those, if you take, for example, here, type 1 beta, the complicated part is this. Otherwise, this part is not a problematic part, because when you are integrating and all that, this part is not problematic, but this part is. So therefore, the success of the method is in rewriting this part here. So I have rewritten, because you know that this can be written as a Vandermon's determinant. That is a standard result. So here, it's available in many books, or if you want to look into my book, it is already there. This is that factor here, and that factor is this Vandermonde determinant, this part here. Now, the ijth element here will be lambda j raised to p minus j. Now, this determinant can be expanded in different ways. If you say, for example, expand it in terms of the first row and the cofactors, one advantage is the coefficients will be only functions of lambda 1, and the cofactors will be free of lambda 1. But on the surface, it may look like that is an ideal type of expansion for looking into the distribution problem. But I found that the cofactors are not symmetric with respect to the lambdas, and therefore that is not the form that I am going to use. So I will use the general expansion. General expansion of a determinant will be of this form. That means the terms are of this type where one and only one element comes from each row and each column. So therefore, this part, if I write in terms of that van der Waals determinant, then I have this particular format. So you can see that here I have lambda j raised to p minus kj. That is the format coming there. Now, of course, this part is coming from the number of transpositions needed to bring the second set of subscripts k1, k2 to kp into the natural order 1, 2 to p. So if the number of transpositions needed is odd, then the corresponding coefficient will be -1. And if the number of transpositions is even, then the corresponding factor is +1. And I have given some examples here. Some simple examples. In the complex case, the problem is slightly more complicated because you have this part squared. 2 times it is coming. So it is equivalent to the real determinant squared. Real determinant square, I can also write it as a prime. Actually, here a prime is a itself. No, here it's a prime is different. So here I can write it as a prime. But the determinant, of course, will be equal to determinant of a prime a. So I'm going to use this representation here. Now a prime will be of this format. So you can see that now my lambda, say lambda 1 is only in the first column, lambda j is only in the jth column. So a matrix of the form, some matrix times its transpose. And that I can always write it in the form like this. Here, bj will be this times its transpose. So this I can write it as b1 to bj, the columns. And when you take a prime a, then I can write a format like this. b1, b1 prime, etc., bp, bp prime. Note that in my bj, only lambda j is coming. So I have the advantage that here only lambda 1 will be coming, here only lambda p will be coming. So therefore, b1, b1 prime, here it will be of this form. So I have simplified the exponent. So finally, I can rewrite in terms of in this format, and I will come to the actual form. So these are the individual elements there. And if I convert that in terms of lambdas, I will get a form like this where these are already predetermined. The exponents R1 to Rp are already predetermined. So my determinant is of this form now, that which I can handle. Now, say for example, if I look into the gamma density, then this is the joint density of the eigenvalues. And this is the part containing that van der Waals determinant. That part is now converted into this. So the whole thing becomes a sum of lambda 1 raised to m1, lambda 2 p raised to mp, where mj is this explicit form, where everything is recognized. So now it's only a matter of integrating out this, and I can consider 2 cases where one case is mj is a positive integer and the other case is mj general. But in the complex domain, you will see that the general case as well as the particular case are one and the same. Or in other words, in the complex case, one has the advantage that my mj will always be a positive integer, because in the complex case, mj will be of this form, and this will always be a positive integer provided this part is a positive integer. But in the Wishart distribution, in the complex domain, this is always a positive integer. It is m, the degrees of freedom. In the real case, it is m by 2. So in the Wishart case, all these things will become very simple. When they are not positive integers, in the Wishart case, they are half integers. I have considered the general matrix variant gamma distribution with a general parameter alpha. So my distributions are derived for general parameter alpha. But in the case of statistical applications, here alpha will be either m by 2 or m. When it is m, it will be a positive integer in the complex case. Otherwise, it will be a half integer. So in the Wishart case, you have either a positive integer or a half integer. Those are the only thing coming. So now I continue with, I have given a connection of my alpha here. When alpha is m by 2, we have the Wishart in the real case, and b should be 1 by 2 sigma minus 1. I have a general b. So these are the particular cases of Wishart. These are some of the old-time work. Quite a lot of number of papers are there, but in all these papers, you will see that the excited distributions are either represented in terms of multiple series involving incomplete gamma functions or incomplete beta functions or things like that, or Pfaffians of skew-symmetric matrices, determinants. Those are determinants. So either representations in terms of determinants or representations in terms of multiple series or multiple series involving either incomplete gamma functions or incomplete beta functions. So even the recent papers, you still have those type of representations. These are all the old type papers. I have given a recent one. Here there is one 2014 paper and there is another one 2021 paper. In all these, the representations are still complicated. Come into the structure of it. First, let us take the case alpha plus b minus b2 being a positive integer, so that these mj's will be positive integers in the real case. I am considering matrix variant gamma case first. In the matrix variant gamma case, you will see that if you are looking at the eigenvalues, the smallest eigenvalues, smallest eigenvalue I denoted by lambda p, largest eigenvalue lambda 1. So we will integrate out lambda 1 lambda p minus 1 to get the density of lambda p. Similarly, to get the density of lambda 1, we will integrate out lambda p all the way to lambda 2. Now, if you want to get a joint density of a few of them in the beginning, then you integrate out from lambda p up to there. And if you want a joint density of a few in the end, you integrate lambda 1 to lambda j. You can do that. But if you want a few of them in the middle, you can integrate from both ends so that you will get a joint density in the middle. So lambda j for a particular j, if you want to get the density, my procedure is integrate from lambda 1 to lambda j minus 1, lambda j plus 1 all the way to lambda p. And both the techniques are given here. Now, when it is an integer, it is simply an integration by parts. So this will be the form. I integrate lambda 1. Lambda 1 will go from lambda 2 to infinity, so I get this form. Now, I continue the integration, then you will get, this is the final form. Note that this is programmable and you can compute it explicitly also. These are finite sums of explicit expressions for the density. I'm considering the density of the smallest eigenvalue. So for a general integration, I integrate up to lambda j minus 1, I will get a form like this, explicit form. Now, I give the general density of the smallest eigenvalue lambda p. So that is simple as this. The explicit form is this. Now, we come to the constant part is sitting there. That's already explicitly available. Now, in the corresponding complex domain, my mj is like this. Now, the corresponding expression will be like this. This is the explicit expression. As I mentioned earlier, in the statistical application case, in the Wishart distribution in the complex domain, this will be m, so that it is positive integer itself. That is the general case as well as the particular case coincide in the case of complex domain. So the whole thing is, this is the final expression in the complex domain. So I have mentioned it here. Now, integration. Now, if you are looking at the density of the largest eigenvalue lambda 1, we will start integrating out from lambda p onwards. So lambda p, when we integrate, so it is something of this form is coming. Okay. Now, that is a incomplete gamma integral is coming. So in that incomplete gamma integral, I can also write it like this. So it is this form. Now, that form, when you multiply, now multiply each term and integrate. Okay, so you have this. This is the step 2 integral. Step 2 integral means second integral, that is lambda p and lambda p minus 1 are integrated out. So you will get something of this form. Even though there are lots of terms there, all the quantities are finite sums, and therefore they are explicitly available and explicitly integrated. Now, for the general case, I have seen that I can create a pattern by looking at representations like this. So for example, for the step 4, this is the step 1. Step 1, I consider two columns, either 0 as one column filled with zeros and ones. All are filled with zeros and ones. So here in step 2 integral, I have these possibilities. These are the corresponding term also. I have only these terms. 4 terms will be there. And the terms I have denoted by this structure, 0, 0, 0, 1, 1, 0, 1, 1. Looking at the number of ones in each structure, this number of ones is odd, then the corresponding sign will be negative. If the number of ones is even, then the corresponding sign will be positive for the corresponding term. So this is the pattern. So by looking at this pattern, I can just write down all the elements explicitly. That means these are all the elements available. These many elements are there. This is one element. And this is another element. This is another element. Like that, these many elements are there. And all elements along with their signs can explicitly be written down by looking at these patterns. Now, here is how the terms can be evaluated. So if the first entry in a sequence is 0, then the corresponding factor will be this, MP factorial, like that. If the first entry is 1 and the corresponding is this, if that is the last entry, then the multiplicative factor is there. Otherwise, it is this. Now, 4 situations. All these 4 situations will cover all possible cases. And therefore, I have now the explicit evaluation of 6 cases, 6 situations. I have the explicit evaluation of all the terms available. Now, for example, by looking at the pattern, if you are looking at a step 3 integral, step the integral, the pattern will be like this. These many terms are there. 1, 2, 3, 4, 4 here, 1, 2, 3, 4 here. Okay. By looking at those and by using the rule, I write it down. So these are the actual terms. Or you can also obtain it, verify it by look at the step 2 integral and multiply it by the corresponding lambdas and integrate out. Lambda raised to m2 and m3 and e raised to minus lambda. And so and integrate out. You will get this. And here is the general case. So P3. So the general case will be like this. So BP lambda minus Q, P minus Q is here. This is the case. The jth step I denote it by Bj of lambda P minus J. Then the density for the largest eigenvalue is this form. This is the constant part coming, this part, and this is the general jth one multiplied by lambda raised to m e raised to minus lambda 1 d lambda 1. This is the last one. This is the explicit form of the exact density of lambda 1 in lambda 1 means the largest eigenvalue. So I have given the exact density of the largest eigenvalue as well as the exact density of the smallest eigenvalue in the case of real matrix variate gamma. Now, the general case for the corresponding complex situation is this. In the complex domain, constant part will be this, and the BP minus lambda is exactly the same as before, and this is also the same. So only this part will be different, and the MJ will be different. Structure of BP minus 1 lambda 1 is the same, but MJ is different for real as well as complex case. In the complex case, MJ is like this, and the real case I mentioned earlier. So that's the only part which is different. Otherwise, the structure remains the same in terms of MJ. I have given explanations of how to get joint densities as well as the density of a particular lambda j here for a particular j. Integrate out, I can get joint densities of many. And here, general case, if mj is not a positive integer and in a matrix variate gamma case, and if it is not a positive integer, I take general alpha. As I mentioned earlier, if you are considering the Wishart distribution, then this alpha is m by 2. So in the general case, if this whole thing is, that is this part, if this part is not a positive integer, then it will be a half integer in the Wishart case. In the general matrix variate gamma, alpha is general. Alpha is simply bigger than p minus 1 by 2. That's only condition. P is the order of the matrix. Here, alpha is greater than p minus 1 by 2. So when it's a half integer, we can also handle it much better. But here I have given it for the general case. Whatever be your alpha. General case, it will be like this. It is an infinite series in the general case. In the general case, at the jth stage, the integral will be like this, and this is the form. The only difference is here in this case is a infinite series, but not a product of infinite series, but sums of infinite series. So that is one advantage with other representations available in the literature. Here it is sums of infinite series in the general case. As I mentioned earlier, if it's a Wishart case, then it is a simple to handle. It's a half integer. In most of the cases, you can, by using duplication formula for gamma functions, you can combine them. And if P is even, then all can be converted back into the integer case. And if P is odd, then it will be something like, and I don't want to go in those details. I can handle those things also. Here is the general representation. Here is the general density for the largest eigenvalue in general case. When mj is not a positive integer, it will be like this. And this I have already given. The jth stage at this p minus 1 lambda j is already there. Here, it's already given there. And this is the last one. And the corresponding complex case, the expression will be, this will be different. This expression is the same. This form is the same, but mj will be different. Mj is this. As I mentioned earlier, in the Wishart case, there is no such thing as non-integer case. This is still an integer case. In the Wishart case, in the complex domain, this will be the degrees of freedom m. In the case, it is m by 2. But in the complex case, it is, this whole thing is a positive integer. So therefore, in the Wishart case, the explicit form given earlier for the integer case is the final case. Here, when alpha is general, you have this form here. Again, it is can be handled easily. Patterns given and details. Illustration for the case of 3. This is the density for the smallest eigenvalue, real case. Density for the smallest eigenvalue, complex case. Now, when I come to type 1 beta and type 2 beta, type 1 beta and type 2 beta is actually all the results are available from type 1 beta. So for type 1 beta, I have also given explicitly I have in the area for explicit forms in the for the type 1 beta as well as type 2 beta. They are available. I think most probably they are in the paper that I sent, or if it is not there, it is there in the forthcoming book on multivariate statistical analysis in the real and complex domain, which should be out soon between April and June of 2022. So there you have a detailed description along with examples and exercises. Explicit forms as well as examples are given there. Included the type 1 beta and type 2 beta case in the current presentation. For the type 1 beta and type 2, I haven't included in this particular talk, but they are available. Explicit forms are available. For type 2 also, I have explicitly given from first principles as well as derived from type 1 beta. So both the type of procedures are shown there, so that if someone already has type 1 beta representations and would like to get type 2 beta from there, that is available, and vice versa. If somebody has the type 2 beta representation or worked out in detail and would like to get the type 1 beta from there instead of going through the same steps, you can get one can get the explicit forms of type 1 from type 2 as well as type 2 from type 1. In the book, I have given both general independent derivations as well as I have shown how to get one from the other. So those are already there. So that will completely cover what I call the pathway family of distributions. The pathway family that I defined consists of the gamma family, the type 1 beta family, type 2 beta family. Gamma family also contains our Gaussian also. Gaussian model also comes into that gamma family. It's a particular case. So all those are connected through a pathway parameter, and all these families are we can reach one. All the families can be reached from either from one of those forms, type 1 beta form, and we can get to type 2 as well as the gamma forms. Similarly, gamma form, if you have it, from there you can go into type 1 and type 2 beta forms through a pathway principle through pathway parameter. So I have completely covered the real and complex matrix variate gamma family of distributions, type 1 family of distributions, type 2 family of distributions, and the explicit evaluations of the distributions of eigenvalues connected with all these matrix variate random variables. Eigenvalue problems, the smallest distribution of the smallest eigenvalue, largest eigenvalue, or the jth largest eigenvalue, or joint distributions of some of the eigenvalues. Okay? Thank you very much.
Thank you, sir. Any questions from the audience?
I just wanted to ask, actually, like the procedures for the multivariate normal were developed earlier, this kind of result. So the difference, or you can say the points where the results are somewhat different, are the technique part, basically, as we have seen here.
I have looked into the literature. I could not find explicit forms, the ones I have given, explicit forms like that. Eigenvalues, distributions of eigenvalues, either in the gamma case or in the type 1 beta or type 2 beta case. That's why I worked out those in detail. Okay. For the, you are talking about what? In the Gaussian case, what?
Yes.
This type of form is available. That's a particular, when you look at the gamma, the parameter alpha, when it is alpha equal to p plus 1 by 2 in the real case, you have the exponential form. So in a particular case, exponential density will come. There the question of alpha does not appear. Alpha is the one creating problems whether you have an integer case or a non-integer case. So when alpha is not there, it is an integer case, it's a symbol. So that means a very particular case of this, whatever I have worked out. Because the exponential form is actually coming from a from a gamma distribution with alpha equal to p plus 1 by 2 in the real case and alpha equal to p in the complex case. So then the density will become the exponential density. The exponential density can also be the Gaussian type density, depending upon, because we are taking the exponent as a positive definite trace of a positive definite matrix or a Hermitian positive definite matrix. So exponential form as well as the Gaussian form, they are all covered. And in fact, they can also be extended to the rectangular matrix variant case.
Thank you, Professor.
Thank you, Somesh Kumar. Any questions?
Yes, sir.
Any questions? If no questions, then thank you, sir. Thank you for your nice presentation, and it will be very useful for the youngsters. So thank you once again for participating and giving your talk, sir. So thank you very much, sir.
Yeah, it was a pleasure. As I mentioned earlier, the full paper and the full slides are there. Anybody can use them. It is up to you. And I send the whole thing to the organizers. So the students can get hold of those. And once the book is published, and it is available also in the book. In detail. Okay. Okay. Thank you very much.
Thank you.
I take this privilege to thank the speaker as well as the chair, and I take a special privilege to Professor Rajshekar Reddy sir, former professor of statistics in the Sri Venkateswara University, Tirupati, and sir also held the positions, as all of us know, as head department of statistics, as vice principal of Sri Venkateswara College, and as former coordinator for MSc Statistics and Computer Applications, and former registrar of Dravidian University, Kuppam. And sir also was elected president of ISPS and elected president of Operations Research Society of India.
Jayashree,
And,
not
Vice
necessary. Oh, okay, thank you.
Thank you very much, sir, for readily accepting our invitation. Thank you, Matai sir. Thank you, everyone. Thank you.
Okay, thank you, everybody.
Loganathan sir.
Yeah.
Good morning. Good morning.
Good morning to all the delegates and speakers present over here. This is Manasa Bala. It's a great privilege for me to introduce Professor S.E. Malik sir, the chair of this session. He's currently working as a professor in Department of Statistics, MD University, Haryana. Sir, I would request you to occupy the chair and introduce the speaker.
Okay, good. So very good morning to all. And now we start this session with a very eminent speaker, Professor Dr. Sudhis. I have few words about him, although he's a very good researcher in the field of statistics. But I have few words to say about him. He's a good researcher, there is no doubt, because it can be seen from his publications. He has published more than 45 research papers and he wrote 2 books and completed 1 research project. He is the recipient of various awards, and he has also done work on a project, matrix project, very important and prestigious project on the part of the Department of Science and Technology. And he has also the recipient of other awards, and he has also been granted international transport by DST in 2017 to present research paper outside country. So he is also fellowship of Indo-US Research and BHM postdoctoral fellowship he has achieved. And there are some other contributions in his life which can be seen and can be guaranteed that he is a good researcher, good teacher, and his research interest are mathematical statistics, reliability, survival analysis, empirical likelihood, inference on income inequality measures. So now I request Dr. Sudhis Kumar to kindly deliver the talk. And we welcome you, Dr. Sudhis. Please continue. Yeah, and unmute. Dr. Sudhis, unmute.
Yeah, sorry.
Yeah, please.
Thank you, Professor Malik, for nice introduction, and organizer for giving me an opportunity to talk about this recent work. So let me share these things, or they have to give permission for me. Yeah, now it's. Can you see the slide?
Yes, no problem.
Yeah, okay, fine, thank you. So, as we know, U statistics is a class of estimator, has several nice properties, and hence I have an attempt to develop a U statistics for left truncated and right censored data. This is very common in survival analysis. So this is the motivation of the talk. We have, the organization of the talk, motivation. Then I will discuss use statistics for complete case. Then use statistics for left truncated right sensor data. Then application and some open problems. The analysis of left truncated and right sensor data is very common in survival and reliability analysis. We consider two examples, one from survival analysis and one from reliability analysis. Consider the example of bone marrow transplant studies based on International Bone Marrow Transplant Registry. In this registry, the patient who died while waiting for the transplant will not be reported to this registry. Hence, we don't have any information about the patients who died while waiting for the transplant. Now consider the lifetime of a high voltage power transformers from an energy company in the US. This data is actually reported in Hong et al. 2009. There were approximately 15,000 transformers, and the company started recording the information about the transformers in 1980. The data contained the information of transformers but failed after 1980. So there are information is missing. So we have the left truncated data also. If you consider these both examples, we have this failure due to several causes. Hence, it is interest to test the independence between cause and failure, cause of failure and lifetime. So this is one particular example which we can consider as the application of the use statistics for left truncated and right sensor data. So now let us look at the definition of the use statistics. First, I will try to make this talk as much as simple. Let x1, x, etc., xn be a sample from a distribution f which belongs to a class, and a parameter theta is said to be estimable of degree m for the family of distribution f if m is the smallest sample size for which there exists a function such that expectation of h star equal to theta. First task is to find an estimable function. Then using that, we can define a use statistics for estimable function theta is defined in this way. You can see that this is a 1 over n choose m. Then we have the sum of this h of x beta 1 etc. x beta m, where beta is beta 1, beta 2, beta n is a combination of m integers from 1 to n. To look at this sum, you must feel that it's complicated, but it's a very nice, simple. You can see some examples, simple examples. If you consider theta as the mean, you can write this as expectation of x1. So what is the kernel here? So you have h of x1 is equal to x1. So if you see here, you can see that here m is equal to 1. So this 1 by n choose 1. So that will become 1 by n. And here we have only one sum. So that is actually 1 over n summation I equal to 1 to n xi. This is the sample mean. If you consider the mu square, again, you can write this mu square as expectation of x1 into x2. So we have the degree 2, m equal to 2, and the kernel is x1 into x2. So we have the use statistics. We have two summation. So 1 over n choose 2. That means 2 by n into n minus 1. So we have this. So if you consider the variance, you can write sigma square as expectation of x1 square minus expectation of x1 into x2. And the kernel is actually x1 square minus x1 into x2. One can make a symmetry, kernel, this is not symmetry. So you adding this x2 square minus x1 by x2, then divided by 2. Or you can make a kernel symmetric always. So this turns out to be x1 minus x2 whole square by. Hence, the U statistics is actually 1 over n into n minus 1 xi summation, double summation xi minus xj whole square. And after some simplification, one can write this as 1 over n minus 1 summation I equal to 1 to n xi minus x bar whole square, which is the sample variance. And this has very nice properties. Two important properties are it has consistency and it has asymptotically normally distributed. So as n goes to infinity, one can see that you can convert this to theta or surely. This result is from Lemma 1951, and we have this theorem as this talk about the distribution of asymptotic distribution of the U statistics. As n goes to infinity, root n into u minus theta converges in distribution to Gaussian random variable with mean theta, there is a small theta, and variance m square sigma square, where sigma square is given by this formula. Sigma square is equal to variance of h of x1, x2, etc. xm given x1. So because of these two properties, it has a lot of application in inference, especially in estimation and testing problems. Because in estimation, if you want to find a confidence interval, one has to find the exact distribution of the estimator or asymptotic distribution of estimator. If you want to find a critical region for a particular test, one has to find the exact null distribution or asymptotic distributions. If you can find a U statistics based estimator or test, then you don't need to prove this theorem. This is ready-made. This is really available to us. So in only thing is to find this variance, asymptotic variance. That's also very simple in most of the cases. So that is the advantage of using U statistics. And also, you know that U statistics is an unbiased estimate. That's also very nice properties. So I just give an application in goodness of test. Suppose you are interested to develop a test for normal distribution. So how to develop a test? There are several ways. One way to develop a test is use the characterization result. Here I consider normal distribution. So one can use a characterization result for normal distribution. So find a characterization result for a normal distribution. Then using the characterization result, develop a measure of departure. I just denoted it as delta F from the null hypothesis towards the alternative hypothesis. So once we develop a departure measure, then you can find the estimator, which is the test statistics. Find an estimator delta hat of delta F. Here one can use U statistics. So our task is actually to represent our delta F in terms of expectation of random variable functions of random variables. Once you can do that, then every other things are very easy to do because we have all the ready-made results. So if you cannot find an exact critical region, one can find a critical region based on asymptotic null distribution of the test statistics. That is readily available to us. This is the use of this U statistics. So if you are working in reliability and survival analysis, one has to work with censored and truncated data. Always we work with censored and truncated data. So that prompted to me to develop a use statistics for left truncated and right censored data. So, and this concept is actually a confusing concept, especially for the beginners. So I will just describe what is the difference between censoring and truncation through one example. Censoring implies partial information about the lifetime. Truncation means no information about lifetime. I will give an example. Consider an experiment where 100 bulbs put on test at time 0. We started monitoring the experiment after 100 hours and noticed that 10 bulbs are already after 100 hours. Before that, we are not monitoring at all. So we start monitoring the experiment after 100 hours and notice that 10 bulbs are already failed. If we use all 100 bulbs in our study, we call it as censoring. Why? Yeah, we have partial information about 10 bulbs. We know 10 bulbs are already failed before 100 hours. But you can also do the analysis with 90 bulbs. In that case, we call truncation. You are not including that 10 bulb in your study. So you have no information. You are not incorporating any information to your analysis. So this is actually a left truncate. So there are several examples one can construct like this, or you can, yeah, we have seen 2 examples already in the beginning, real life example in the. Now we develop this test for left truncated and right censored data. I give some notation. We have 3 variables here, X, C, and L, which denote the failure time, censoring time, and truncation time. And you can take the distribution as this way, and then we assume the independence between C and L. Then under left truncation and right censoring, observed sample consists of n independent and identically distributed observation, Ti epsilon I delta I, where T is actually minimum of X and C, which is something similar to the right censored case, how we define. And then delta is the censoring indicator and epsilon is the indicator for truncation. Here delta, yeah. So if you look at these things, we have these observations, and one can see that if delta I equal to 1, then we have censored observation. If uncensored observation, sorry. If delta I equal to 0, then we have ith observation is censored from right. And if epsilon I equal to 0, then we have ith observation is truncated at left. In that case, we cannot include ith observation in our study. This is the scenario in the left truncated, right censored case. This is what we have. Sorry, what is the? Yeah. So we use the technique called inverse probability censoring weighted technique to define the use statistics. So we make use of this identity. If you see that, if you find the expectation of this quantity is a type of, this bracket is not needed actually after T. So one can see that we have this expectation of X. So we use the, hence we use the weight delta epsilon by probability of L less than P less than C for finding the use statistics using inverse probability censoring weighted technique. What we do here in this case, there are two nice paper one can see. this technique is actually introduced by Professor Paul in 1981 in the context of regression analysis. And Datta et al. 2010 also used this inverse probability censoring weighted technique to define a U statistics for right sensor technique. What we do in this inverse probability censoring weighted technique is actually we only consider the uncensored case for defining the U statistics, and we give the weight to all the uncensored observations. We gave this weight here. Delta is known by probability of L less than P less than C. This is what we do. So this is the U statistics for that. We can see that we actually giving this right. So this is something similar to the U statistics case, except we have this weight delta protected delta L epsilon I divided by product probability of LL less than PL less than CL. This is what we have. And you can see that we have here the notations is used to indicate that I is one of the integers I1, I2, IM chosen from 1 to n. When m equal to 2, UC can be written as this way. You can see that it's a very simple form. See, we have 1 over n choose 2, and then the summation. You can see that it's a very simple form. So this is why most of the cases you can see that our test statistics or estimator is of a degree 2 or 3. So it's not difficult to write these summations or the quantities involved in these things. Yeah, using this identity earlier, which we see that one can see that this is an unbiased estimate. But one can see that if you look at this definition, sorry, here this probability is not known to us, so one has to estimate that. So this we use the Kaplan-Meier estimator under left truncated for estimating this probabilities. So that how one can define the U statistics for left truncated right sensitive data. So this is why we can define this way now. Hence, we define inverse probability censoring weighted U statistics under left truncation and right censoring as this way. Okay, and here also one can prove nice properties. We have consistency as n goes to infinity, usually converges in probability of data. In the general case, we have almost sure convergence. In the general case means in the uncensored case, I don't know whether it is almost sure convergence, but I could prove the convergence in probability. Maybe one can try. I have put this paper in archive. If somebody is interested, they can read and they can prove the almost sure convergence. So asymptotic distribution, where we consider some of these notations, and yeah, these are the notations we used. We have this MICT is the martingale associated with the censoring counting process, and then S is the subdistribution function, and we define WT like this, and then we have this here. Under some conditions, and these conditions actually the existence of this variance, you can see that existence of the integral in 8. So under some condition, as n goes to infinity, root n into UC hat minus theta converges in distribution to Gaussian random variable with mean 0 and variance sigma c square, where sigma c square is given this way. We have sigma c square, m square into sigma 1 square plus sigma 2 square, and this sigma 1 square and sigma 2 square are given this way. Yeah. one can find the estimator for this asymptotic variance also. This is given here. Here in this sigma 1 square, you have this 1 over n minus 1 summation I equal to 1 to n vi minus v bar whole square, where vi is defined this way. And for W2, we have this estimator. This is actually, you can see that we have a plug-in estimator. You can see that this is integral is with respect to a step function, so that you can write it as a sum. So this is why we have the estimator. So one can find an estimator for the asymptotic variance. So it is so in this case, actually, you don't need to find even the asymptotic variance. You can estimate using this particular formula. So your life become very simple actually once you can construct a U statistics based estimator or test. As an application, I talk about this competing risk cases. Professor Malik, could you please tell me how much time I have?
Yes, 5 minutes, Dr. Sudhis. 5 minutes.
Okay. Yeah, 5 minutes. So yeah, I will give an explanation with 5 minutes. We have competing risk, two more cases competing for the event to happen, and the ultimate failure happened due to one process. So there are several approaches dealing with the competing risk, mainly two approaches: latent failure approaches, and then the joint distribution, using joint distribution of T and J. T is the failure time and J is the cause. In this approach, if T and J, it is always important to test the hypothesis T and J are independent, and so that one can carry out all the analysis using the marginal distribution of T and J, and it also answer to the question like whether one risk progress faster than the other. So it is very important, and for some recent development, one can see this papers. Professor Ishadivan has a series of papers. Actually, if you look at all these papers, she is one of them. So here you can see that we have this data. Apart from XCL, we have J also, the causes. And then, yeah, using this, we are interested in this testing property. T and J are independent and T and J are not independent. And we consider this particular measure for developing the test. And one can see that this is a kernel, and this is not a symmetric kernel. One can make it symmetric. And then we have this test. You can see that it's not complicated. And what is the advantage? As I mentioned, we have the consistency, we have the asymptotic normality, and we can also estimate the asymptotic null variance. So it is easy to find the critical region for the test. So we have this test. Sorry, this is the distribution, asymptotic distribution. So this is the asymptotic test, and actually we did some simulation study. This is the setup for the simulation study. We use this family of sub-distribution introduced by Diwan and Kulatilal to develop the to generate the competing risk. So we have A equal to 1, we have T and J are independent. So if you put A equal to 1, so you get a type 1 error. In other case, you can find the power. So this is the situation here. We have exponential. C is also generated from exponential. L is also generated from exponential, but you can see that with this constraint. So this is the table for type 1 error. You can see that it's almost, there are some over coverage in the small sample size, but that can be expected because we have left return gate right sensitive cases. So this is the empirical power with the two causes. You can see that the power is very good. So this is what, and we actually did an analysis, data analysis, This is the example which I mentioned, the transformers data. You can see that we have the transformers. Those transformers are installed before, after 9080, but failed after 9080. So we have some loss of information. And I will just to show the data. This is the data. We have year of installation, year of exit, V and K. What is V and K? K is the cost, and you can see that here. V represent the truncation indicator. Here V equal to 1 specify that the transformers was installed after 9080, and V equal to 0 specify that a transformation was installed before 9080. Yeah, K equal to 1 indicate the failure is due to cos 1, K equal to 2, and other things. You can see that. Yeah, this is the cumulative incidence function. One can see that this incident function is actually higher in one case. This is the, from top plot, it is evident that the chance of failure due to cos 2 is more compared to cos 1 as the lifetime increases. This is why. So if you look at in this case, it is actually clear, but some cases it may not that much clear to you. So one has to perform some testing. So we calculate the value of delta at, and is obtained as 88.16, which indicates that the lifetime and cause of failure are dependent. So this is all about my talk. If I have time, I can give you one or two open problems. Thank you.
Yes, thank you, Dr. Sudhis, for delivering nice lecture and talk and informing the audience and participants about the use statistics for left truncated and right censored data. Is there any question from the audience? Audience are free to discuss with Dr. Sudhis Kumar. Dr. Sudhis Kumar, is there any other statistics other than the use statistics to determine such type of things in censored data?
Yeah, one can use it. One can use normally this plugin method, usual plugin method.
Okay, plugin method.
Yes.
So sometimes we have some missing observations in the data. In that situation, what is required to determine the use statistics?
Which type of missing observation? Because here also we have one kind of missing observation. Left sensor.
Right. Left, exposing the left.
Yeah, we are missing that. So
yeah,
and one can think about extending to different cases. For example, just left censoring,
okay,
or maybe double truncation. In that case, you have missing in both cases.
okay.
So one can think about developing a use statistics for that also.
Okay, good. So thank you, Dr. Sudhis.
Yeah, if anybody is interested, you can write to me. We can have a
yes, definitely, definitely.
Work on this type of problems.
Right.
Thank you.
Thank you, Dr. Sudhis, for delivering nice lecture. So I hand over the session to the organizers.
Okay, thank you.
I take the privilege to thank Professor S.E. Malik sir for chairing the session, and the speaker, Professor Sudhis Kumar sir, for sharing your expertise with all of us.
Thank you.
Thank you.
Hello, Professor. Professor Ilangavan is here.
Yes, yes. Yeah, yeah. Good morning, Satish. Good morning.
Good morning. Good morning. Now let us start this session because without wasting our time. In fact, the present session.
Often.
This session, to chair this session, we have Professor Ilangavan. Is working as the professor of the Department of Statistics, Annamalai University, Tamil Nadu. And he has more than 30 years of teaching experience at postgraduate level. And also he has produced more than 100 research publications and more than 20, more than several PhDs he has produced. And is a very active researcher. And, I would like to, on behalf of the Indian Society of Probability and Statistics, I would like to invite Professor Ilangavan to chair this session.
Thank you.
Professor, thank you so much.
Thank you. Yeah. Hello. Professor Logan. Yeah, Professor Loganathan.
Yes, sir.
Yes.
Good morning.
Good morning. Professor Loganathan is here. There is no introduction because he is known to me for all the researchers as well as professors all over India and abroad. He is my colleague. He is putting more than nearly 30 years of service in Manoramani Sundaranath University, Tirunelveli. He completed more than 8 PhD and published more than 40 research paper and several projects also handling. And currently 4 people are doing PhD and risk guidance. And he is a best teacher as well as a best researcher. He is the old alumni of the department, Annamalai University. He is the student of Dr. M. Professor M. Rajagabalan. He is a well-known stalwart and giant. Did his doctorate in Wakalkama State University. He is as chairman for more than years in our department. And also Dr. A. Loganathan attended several international conferences and he visited several countries in India and abroad. And he is also closely associated with our department of statistics at Annamalai University for more than 3 decades. And he is a best teacher as well as best researcher I come across. On behalf of our department organizing committee and on my own behalf, on behalf of my Professor M. Rajagabalan, the head of the department, former head of the department, is guide to Dr. A. Loganathan. I welcome Dr. A. Loganathan to deliver his speech. And welcome you, sir. On behalf of the organizing committee IAPS, I welcome Professor A. Loganathan to deliver his talk, sir. Please, sir.
Thank you, Professor Ilangavan, for your good words. I do not know how am I going to justify your words. You are repeatedly telling me a good teacher, good researcher. I do not know how good I am. Anyway, many thanks to you for your good words and for your affinity and love. And good morning, Professor Satish Kumar, Professor Malik, and Professor Sandamarakannan. Good morning to all. And it's my pleasure to
Good morning, Professor Loganathan. Good morning.
Good morning, Professor Malik.
Welcome.
Professor Malik, good morning.
Good morning, sir. Good morning.
I thank the organizers, particularly Professor Bhattacharyalu and Professor Jayasri for inviting me to deliver this lecture. And my special thanks go to Professor Satish Kumar too. The title of my talk is Behavioral Analysis of Sampling Plans for Exponentiated Lifetime Distributions. I have some slides to share with you. Is the screen visible?
Yes, Professor, it is visible. Can make it full screen if needed.
Is it in the full screen mode?
Yeah.
Thank you. This time, this time I achieved it because many times I got troubled. I got technical difficulties in bringing this full screen mode. Thank you, This is a collaborative attempt with one of our previous research scholar, Dr. Gunasekaran. Now he is a guest faculty in Gandhigram Rural Institute. The purpose, the motivation and the purpose of this talk, I want to tell you first of all that we have been attempting this designing of sampling plans and evaluation of sampling plans for more than 2 decades in our department at Manonmaniam Sundarnar University, Tirunelveli. And we have also had experience of reviewing the research papers sent by the journals of international repute, of course, good journals. And quite often I used to feel that the researchers, they concentrated more on designing the sampling plans and comparing the efficiency of their sampling plans with other existing plans and so on. And the problem, I mean, the fact which came to our mind, of course, we have been doing, we means myself and Dr. Vijayaraman started at Manon Sundarani. Of course, Dr. Vijayaraman had been working a lot, many more years back itself in acceptance sampling plan. I joined him 20 years back for carrying out research works in sampling plans as a collaborative work. And we have been doing this as a compulsory exercise to study the properties of the operating characteristic function. And operating characteristic function, as you all know from our graduation study in quality control, that it is one of the important measure, it is one of the important tool for studying the discrimination property of discriminating power of the sampling plans. And also the properties of the operating characteristic function explore the behavior of the sampling plans. So in that way, before designing the sampling plans, we can have some good idea about the sampling plans which we are going to generate later based on given requirements. The given requirements means what is the level of acceptable quality level to the producer and for the consumer, and the risk level of the producer and risk level of the consumer. Given those constraints, given those conditions, what is the sampling plan? Designing, that is what designing. Before designing it, I feel that it is worth and it is important also to study the behavior of the sampling plans based on the operating characteristic function. So this is the purpose. Based on this only, I want to, even when we deliver lectures and when we presented papers, we also touched upon these facts, but since the number of pages are limited, we could not put more on more details on the behavioral analysis of the sampling plans. Of course, we published 2 papers in American Journal of Mathematical and Management Sciences during 2007. 2 papers, both of them exclusively discuss about the Bayesian, the analysis of operating characteristic curves of Bayesian sampling plans. But this time we want to take up the topic as reliability sampling plans. That is why I have chosen this exponentiated lifetime distributions. Means for every lifetime distribution which were discussed earlier. Now we have some additional parameter. The introduction of a new parameter makes this brings the exponentiated lifetime distribution. More the number of parameters, more the clarity about the system. So that's the reason why I have chosen the topic exponentiated lifetime distributions. Due to time constraint, I may not be able to show all the details about other exponentiated distributions other than exponential, because whomsoever they are concerned, when they put their first step into the reliability sampling plans, they will look into the exponential lifetime distribution. And exponentiated case also, exponential distribution is the primary one with which we can begin with the designing of reliability sampling plans. And of course, this some of the things I have spoken earlier, the important behaviors of the sampling plan. By that, what I mean is the purpose of sampling plan. Of course, a sampling plan is a tool which tells us that how many products have to be sampled and how many products, how many defectives we can admit, number of defectives or number of defects based on the quality characteristic. with reference to the acceptance number and count the number of defectives and take the decision rule. So every acceptance sampling plan, this is about single sampling plan initially. Every acceptance sampling plan gives these details, that is sample size, acceptance number, and decision rule. Of course, I have not forgotten the lot size, but primarily because now when the lots are of large in size, we do not consider the lot size. We have the introduction of this, we have the consideration of the lot size only when we deal with smaller lots. Right. The purpose of acceptance sampling plan is to conduct the application of the acceptance sampling plan is to conduct the inspection for taking decision about the lots. So the decisions definitely will be any of the two, either acceptance of the lots or rejection of the lots. However, it will affect two parties. One is the producer and the consumer. Since we deal with the sampling situation, unless otherwise we do 100% inspection, we cannot give guarantee for the producer's risk or the consumer's risk, but they are subjective because we do only with the samples. So we can expect some sort of risk to be faced by the producer as well as the consumer. And some of the sampling plans may give more protection to the producer by means of accepting the good quality lot, by means of accepting the lots. We may call them as producer-oriented plans. And there are some plans which give more protection to consumer by rejecting the poor quality lots, which we may call them as consumer-oriented plans. So we must be able to distinguish whatever the sampling plans we are going to generate. We must be able to classify them as whether they are producer-oriented plans or consumer-oriented plans. For classifying such kind of plans, many tools are available. Among them, the important one is the operating characteristic function. Shortly, we can call it as OC function. The behavior of the operating, of course, we have the graphical display of operating characteristic function. Quite often, we have been doing in our postgraduate class also. There, it is called operating OC curve. So the behavior of the OC curve will help us to draw, to understand the behavior of the sampling plans. When the quality characteristic is the lifetime is the quality characteristic of the product under investigation, definitely the life test will be the source for carrying out the sampling inspection. So sampling inspection will be carried out by conducting the life test. We may understand very well that the conduct of life test will incur more cost and it will take more time unless otherwise we have some censoring schemes. There are several censoring schemes which are available in the literature: time censoring, product censoring, and hybrid censoring. Hybrid censoring means both time and cost, giving more priority to time. Type 2 censoring scheme, both it is a mixture of both time and cost, giving more priority to the number of defectives, and several progressive censoring schemes are also available. And of course, we are not going to discuss much about them. We are going to take only the third one, that is type 1 hybrid censoring, for our discussion. So we put our concentration towards studying the behavior of the reliability sampling plans when the life test is conducted under type 1 hybrid censoring scheme. So this is this slide helps you to understand. Of course, it is not an uncommon censoring scheme. It is a very common one. However, if there are any youngsters who are about to introduce to this topic, I hope that this display will be useful to them. We put the sampled items in the inspection, the life test, and we observe the number of failed items. Of course, the number of failed items are displayed in this diagram, and the X suffix 1 represents the lifetime of the failure time of the first failure, and the second failure, third failure, it prolongs. And when C is fixed, of course, in type 1 hybrid censoring scheme, there are two facts prescribed. One is the admissible number of failures and the test termination time. Test termination time is T, and admissible number of failures is, say, C. If C number of failures is occurred before test time termination time T is arrived at, we can stop. We can terminate the life test, or we can continue till termination time T is reached with the C-1 failures. And we can make a note of the details about the number of failures, and we can take decision. That's it. Of course, these are some of the references we want to bring it to the knowledge of the audience regarding the earlier attempts made on reliability single sampling plans under various censoring schemes. These are the details about type 2 censoring, and these are the works carried out under type 2 censoring scheme for various lifetime distributions. Begin with exponential and log normal variable, but type 2 distribution and type 1 hybrid censoring scheme till Binbaum-Sanders, and it continues then. These are the interval censoring scheme and the progressive type 2 censoring scheme. All these about the single sampling plans, the generation of designing of reliability single sampling plans. And there are some works which have been done for other type of sampling plans. And we also want to discuss about multiple dependent state repetitive group sampling plans in this lecture, provided the time permits. And these are some of the literatures carried out on multiple dependent state repetitive group sampling plans. I told you we have been attempting on reliability sampling plans, designing of the reliability sampling plans for the past 20 years. And these are some of our efforts. These are some of our results published in journals, carried out by the faculty members and the research scholars of our department on reliability sampling plan. Apart from reliability sampling plans, there are other works also. Since this lecture is about reliability sampling plans, I display this one. Gunasekaran did his doctoral degree in exponentiated Rayleigh and exponentiated exponential distribution. Of course, this talk is prepared. This talk is prepared from the excerpts of his doctoral work and from his publications. This is the theoretical details about exponentiated exponential distribution, the probability density function, cumulative distribution function. Of course, the exponential distributions are defined from the cumulative distribution functions, exponentiating the cumulative distribution function with a parameter. As you all know very well, that this is actually e power minus t by lambda, this one. 1 minus e power minus t by lambda is the cumulative distribution function of exponential distribution with the mean lifetime, say, lambda. When we raise the power of this cumulative distribution function to the theta, that is exponentiation, that brings the new distribution that is called exponentiated exponential distribution. So there are two parameters in exponentiated exponential. One is lambda, another one is theta. Until when theta is equal to 1, of course, this is the usual exponential distribution, and lambda will be the mean lifetime of the distribution. And when we discuss about exponentiated characteristics of exponentiated exponential, we found that median lifetime gives median of the distribution gives more details than the median, than the mean. So we will put our discussion with reference to this M. So with reference to this M, we rewrite the cumulative distribution function in terms of T and M in this fashion, because this is the function which we have used for calculating the log fraction failure of exponentiated exponential distribution. So these are some graphs displaying, they display the behavior of the probability density function of the exponentiated exponential distribution. You can understand that when theta is equal to 1, it is that this gray dots. This is the probability density function of exponential distribution with the mean lifetime lambda is equal to 0.5. See, when lambda is fixed and theta is varying, of course, theta 0.5 reaching theta is equal to 10. These are various graphs. You can see that whenever there is a change in the value of the parameter, you can observe that there is a significant change in the behavior of the probability density function. The structure is also changing very nicely. So it plays a vital role. That also motivated us to choose this topic, to understand the significance of this theta in designing the reliability sampling plans under exponentiated exponential distribution. Right. So this is basic definition about the operating characteristic function. Usually people used to write the operating characteristic function as P of P, right? But there is an subordinate there should be subordinate information that P of P is not only a function of the log fraction failure, but it is also a function of several other things that includes the model parameters. What is the probability distribution based on which you develop the plan that we call it as model parameter. In the case of exponential, there are two parameters, lambda and theta. And then the plan parameters, sampling plan parameters. So in the case of a single sampling plan, we have three parameters, lot size, sample size, and C. So for given model parameters, plan parameters, then we study the acceptance probability of the lot acceptance probability with reference to the lot quality. The lot quality is represented by this P. The P is nothing but lot fraction failure. And to evaluate the acceptance operating characteristic function in the case of other sampling plans, we have direct applications of the probability distribution functions under consideration. But in the case of reliability single sampling plan under type 1 hybrid censoring, we will have only the details about the number of defectives and the number of failures, isn't it? So for drawing the for studying the behavior of the reliability sampling plans, the operating characteristic function is calculated based on any one of these three probabilities: hypergeometric, binomial, and Poisson probabilities. Here in our discussion, we have displays about the behavior of operating characteristic function with reference to hypergeometric probabilities. Of course, similar kind of exercise can also be done for binomial and Poisson distributions. Of course, this is little thing about the designing of the reliability single sampling plans. Because our interest is not of this one. This is the operating procedure of the reliability single sampling plan for exclusively for exponential distribution. That the thing is, we prescribe the test termination time and the exponentiation parameter theta, M1, M2. M1 is the median lifetime to the expectation of producer. M2 is the consumers, the median lifetime of consumers quality level. Usually in the case of other sampling plans, we will take the P1 AQL, the producer's quality level, LQL, consumers quality level. But in the case of reliability sampling plans, we take the median lifetime and median lifetime to the producer's quality level and consumers quality level. M1 is definitely greater than M2 because producer's quality level is more. In the case of usual single sampling plans, P1 is less than P2, but in the case of reliability sampling plans, when we talk about median lifetime, M1 is bigger than the producer's quality level is more than the consumer's quality level. Alpha, producer's risk, beta, consumer's risk. So based on these things, we calculate the AQL. We calculate in the case of reliability sampling plans, we calculate P1 and P2, right? Because from T and M1, we calculate P1, with the T and M2, we calculate P2. So based on this P1, P2 and alpha, beta, then it is a routine matter using the previous operating characteristic function based on either our hypergeometric or Poisson or binomial probabilities. We can find the plan parameters N and C by applying the usual search procedure or unity values approach in the case of Poisson distribution. So from the given sampling plan N and C, plan parameters N and C, we choose N items from the lot consisting of capital N number of items, and we conduct the life test and we observe the number of failures. And we terminate the life test either at time T when C plus number of failures are observed before time T, whichever, or on observation of X. If the number of failures is less than or equal to C at time T, we accept the lot, or otherwise we reject the lot. So this is the operating procedure of the reliability sampling plan. So the plan parameters N and C are determined based on T, theta, M1, M2, alpha, and beta. Of course, N and C also plays a vital role in taking the decision. So here we have some intuition about what are the factors which can influence the behavior of which can change the sampling plan's behavior. Right. So these are some of the general behaviors of the single sampling plans, not only with reliability sampling plan, but in general. So lot fraction failure, that is P, when P is small, then lot fraction failure is small. The proportion lot fraction defective is small. It means that the lot is of good quality. There will be definitely such kind of lot will have larger probability for acceptance. On the contrary, when P is large, then the lot will be of poor quality and it will have smaller acceptance probability. So accordingly, the P of P, the lot acceptance probability will decline when the lot fraction failure increases, because when lot fraction failure increases, the lot will become poorer and poorer. Accordingly, it will have lesser chance for acceptance. So it is a preferred behavior. So we want all our sampling plans to have this kind of a preferred behavior. That is what I put it as preferred behavior. Similarly, sample size, the plan parameters n and c. When n is small, the less number of items will be sampled from the lot. So there will be lesser chance for inclusion of the failures in that lot, in that sample. So there will be a large chance for accepting the lot. Such kind of plans can be called as producer-oriented plans. And when sample size is large, there is a larger chance for including more number of defectives in the sample. So that will reduce the chance for accepting the lot. So such kind of plans can be called as consumer-oriented plans. So when the sample size is increasing, the acceptance probability should decrease. Should decrease. This is a preferred behavior. We expect our sampling plans to possess this kind of a behavior. Similarly, acceptance number. When we have a lesser number of small value for C, it means that we can admit one lesser number of failures for accepting the lot. When C is small, then lot acceptance probability is small. And because we'll have very lesser chance for accepting such kind of a lot. It is consumer-oriented plan. And when the acceptance number is more, then it means that we will accept more number of failures. It means there is a large chance for I'm sorry, this is a typographical error. This is large. This not small, it is large. It is a producer-oriented plan. In other way, we can say that when the lot acceptance number increases, then the acceptance probability should also increase. So of course, you are going to see that it can be observed from the mathematical property of a cumulative distribution function. So in the case of reliability single sampling plan for exponential distribution, so this is the lot fraction failure. We define this P from the value of the cumulative distribution function. So this is the expression, displays it. So when we differentiate this P with respect to T by M, what T is termination time, test termination time, M is the median lifetime. So T over M is kept as a characteristic to study the behavior of the sampling plan. So when we differentiate this P, of course, this is differentiable with respect to T by M. So we can see that this first order derivative is greater than 0. It means that when T by M increases, P also increases. If P increases, then lot fraction defective lot acceptance probability will decrease. So T by M, when it decreases, that will minimize the lot acceptance probability. So these are some of the interpretations for good quality lots and poor quality lots in terms of the values of T by M. So these are some of the graphs displaying the behavior of the operating characteristic function. That means the lot acceptance probability with reference to the changes in the values of T by M. In the previous slide, we have seen that T by M, when it increases, P also increases. We know that when P increases, P of P should decrease. Yes, here when T by M increases, definitely P of P decreases. So such kind of a behavior is there, irrespective of the plan parameters. For all plan parameters, for different sets of values of capital N, N, and C, we can see that for exponential distribution, this behavior is applicable, right? So our exponential reliability single sampling plan possesses the first preferred behavior. And when M increases, this is with reference to the median lifetime. When median lifetime is large, then the lot will be of good quality. And when lot is of good quality, then the acceptance probability will also be large. So the shape of the curve will have an increasing tendency. Yes, irrespective of all other parameters, all the parameters of model as well as the sampling plans, the operating characteristic function display an increasing tendency. Of course, all these graphs have been drawn based on the calculated values of P of P. I do not show those values, numerical values here, but I want to show you, I want to show that the behavior can be understood with reference to the display of the operating characteristic curves, because when we look at this curve, you can see that the upper portion of curve, whenever there is a bulge on the upper portion of curve, that indicates that the acceptance probability is more. At the beginning level of this x-axis, we can see that there is a good bulge at the purple graph, that is 1000 lot size, 85 sample size, and acceptance number 2, theta is equal to 2. It gives a very good protection to the consumer, to the producer, by accepting the good quality lots. And at the same time, when the lot quality deteriorates, it shows that there is a declining tendency. Of course, with reference to this blue line, blue line, you can see that it has a sudden decline tendency in the curve. That shows that that such kind of a plan provides a very good protection to the consumer. So in this way, we must be able to classify the producer-oriented plan and consumer-oriented plan. So this is the curve which represents the influence of the other two plan parameters. Of course, N does not have, as far as the reliability sampling plan for exponential distribution calculated based on hypergeometric properties, lot size does not have any influence. Of course, we have taken larger size also. When N is small, there will be a significant difference, right? When the sample size is large, lot acceptance probability declines. So how can we understand this behavior? Means take a point at the x-axis, that is t by m. Correspondingly, you draw a perpendicular line from the x-axis to the curve, and that will intersect all this curve. That means they are the point of intersection tells the lot acceptance probability corresponding to t by m. Right. So the different curves show the value of n. So this blue line is drawn for n is equal to 25. This line, brown line is drawn for a sample size n is equal to 50. Green mentions 75 and purple mentions 100. When we see that for when t by m is fixed, when the sample size is increasing, the lot acceptance probability declines. That behavior we can observe. And at the same time, here also we can see that the purple line refers to n is equal to 100. When the sample size is large, it is a consumer-oriented plan. And n is equal to 25, small sample, and that gives more protection to the producer, even against the acceptance of the poor quality lots. Right. So this is the effect of the acceptance number. This is very, very obvious display that shows the influence of the acceptance, increase in the influence of the acceptance number, that gives a very big increase in the acceptance probability. So small c values are small c values correspond to the consumer-oriented plans. Large c sample plans with the large c values are producer-oriented sampling plans. So this is what I want to tell you, that I want to make it as a point that what is the influence of the exponentiation parameter in theta. This is a this function is differentiable with respect to theta, and we differentiated, we see that it is less than 0. It means that the lot fraction failure is a decreasing function of with respect to theta. When theta increases, t decreases naturally, because theta is an exponentiation parameter, and this 1 minus e power minus t by lambda is a fraction because it is a probability. And we raise the power of this to the we increase the power of this one, means the value will decline. So lot fraction failure will decline. So when lot fraction failure declines, lot acceptance probability will increase. So lot acceptance probability will be an increasing function of the exponentiation parameter theta that is displayed in this curve. You can understand this one. There's a very good difference in the position of the curves. This blue line represents the consumer-oriented plan. The purple line represents the producer-oriented plan. There is very good difference among the position of the plans depicting the behavior of the sampling plan, whether it is producer-oriented and consumer-oriented. Right. So these are the just consolidation of the properties of the operating characteristic function. Of course, these are the effects of the test determination time and median lifetime of the producer's quality level, and median lifetime of the consumer's quality level upon the sample size. Irrespective of the probabilities we used for computing the operating characteristic function, when the test determination time increases, then the value of n is small. When n decreases, means the n becomes small. Whereas when the consumer-oriented median lifetime increases, correspondingly, the sample size is also increasing. It is natural, and that is what we have been discussing in one of our earlier slides also. So these are the facts I want to discuss about studying the behavior of the reliability single sampling plans developed under the conditions of exponential distribution. And we can also introduce the prior distributions for the plan parameters like lambda and theta, and we can use the predictive distribution of the quality characters, number of defectives or number of defects. Accordingly, we can develop Bayesian reliability sampling plans, and we can study the behavior of such Bayesian reliability sampling plans. Professor Ilangovan, can I have 5 more minutes, or shall I conclude with this? Because with this, one topic is over. I want only a few more minutes to show that the multiple dependent state repetitive group sampling plans behavior with reference to these plan parameters.
Go ahead, sir.
Right, sir. So this is the operating procedure of multiple dependent state repetitive group sampling plans under the conditions of exponential distribution. Sir, you can see that we have 3 more additional parameters. Instead of n and c, here we have n, c1, c2, and k. We have 2 additional parameters. Here, c1 and c2 can be called as acceptance numbers. Of course, we cannot call them deliberately as acceptance numbers. However, they play a role of the acceptance number in the single sampling plan in the case of MD-SRGS. So the first 3 steps are same, and the 4th is also same. And when we come to the 6th step, the 6th step tells that when can we accept the current lot. This is about the reliability sampling plan, but MD-SRGS, multiple dependent state repetitive group sampling plan. So we can accept the lot provided the number of failures observed from the live test is less than or equal to the first C, that is C1, before time t or at time t. If exceeds C2, not C1, if it exceeds C2, definitely we will reject the current lot. And the relationship between C1 and C1 is smaller than C2. When x is less than or equal to C1, we can accept the current lot. When x is greater than C2, we can reject the current lot. These two cannot occur together because C1 is strictly less than C2. Rather, if the number of failures is more than C1 and less than or equal to C2, then we have to take a decision based on the previous case history, that if the k preceding lots are accepted under the shape of the current lot, accept the current lot or not the current lot, the preceding k preceding lots, then based on that we can accept it. If all the k preceding lots are accepted under these conditions, then we can accept the current lot also. If any one of the k preceding lots is rejected, then we have to reject the current lot also. Right. So this is the multiple state repetitive group sampling plan operating procedure. You can see that n, c1, c2, k also play a vital role in changing the behavior of the sampling plan, because that changes the c1, c2, c1, c2, k, they lie in the decision making step of the sampling plan. So these are the multiple operating characteristic function expression, P of t. This is the expression for the operating characteristic function of MD-SRGS. And of course, this probability of x less than or equal to C1, all these cumulative probabilities can be calculated using any one of these 3 descriptive distributions: hypergeometric, binomial, Poisson, as like earlier. So we can all discuss that behavior of the sampling plans using any one of these probabilities: hypergeometric, binomial, and Poisson. Of course, we have the role of the average sample number, because we have the number sample size, right? Average sample number with respect to P1, that is acceptable quality level, acceptance average sample number with respect to limiting quality level. Take the average of that, that is your ASM. So this is the this is an optimization problem which helps us to arrive at the average sample number, sample size that can be obtained on minimizing this ASM expression subject to these constraints. I do not go much about theoretical details about these conditions. Of course, the first condition refers to the P of P1 greater than or equal to 1 minus alpha, P of P2 less than or equal to beta. Of course, usual 2 points lying on the operating characteristic curve. those 2 points are put in these 2 constraints, and the C1 is less than or equal to C2. Right. So this is an algorithm to determine the plan parameters N, C1, C2, and K. Of course, our interest is not lying on this. So the effect of the characteristic P, it is as like the single sampling plan, the same. And for the influence of N, it is also same. The behavior of the operating characteristic function is as like the reliability single sampling plan, because these are all the preferred behaviors. And we can see here that in the case of reliability single sampling, there was only one acceptance number. Here we have 2 such criteria, C1 and C2. And when the acceptance probability is an increasing function of both C1 and C2, when you look into the influence of C2, we keep fixed the C1. When we look at the influence of C1, we fix the C2. However, individually, both C1 and C2 influences P of P significantly. Both of them are very, very important to discriminate the behavior of the sampling plan, the multiple dependent state repetitive group sampling plan. Of course, both of them do not have the contradictory behavior. Both of them have the same behavior. They influence the same behavior on the operating characteristic function. Right. So this is the theta, the role of theta in the case of MDSRGS. Yes, this also when theta is this is increasing. When theta is increasing here, mistakenly I have typed it in this way. The second line is theta increases. So it means lot acceptance probability is an increasing function of theta. It is same as that of the previous reliability single sampling plan. And the new parameter K, it also has an influence upon the values of the lot acceptance probability. Not too much of influence it has. But when K is greater than or equal to 3, empirically we observe that when K greater than or equal to 3, it has a little impact in changing the values of the lot acceptance probability. When K is less than or equal to 3, it does not have much influence upon the values of the lot acceptance probability. Right. So these are the consolidated details about the properties of the operating characteristic function with reference to all the characteristics: lot fraction failure, lot size, sample size, 2 numbers, integer parameter C1, C2 acceptance number for understanding point of view, test termination time, and the number of previously accepted lots, and the median lifetime, and the exponentiation parameter. And you can see that these are C1 and C2. K are the new one compared to reliability single sampling plan. All other things are the same behavior as like a reliability single sampling plan. So these are the proper influence of the test termination time and the median lifetime of producer's quality level and the consumer's quality level upon the sample size for when only one sample is taken, or the average sample number when we take more samples. That's all. So with this, I conclude my talk, and thank you for your patience for listening. And if there are any questions, I'm ready to, I will try my level best to respond, to answer, to clear your doubts. Thank you, Professor Ilangovan.
Thank you, Professor Loganathan, for a wonderful lecture. We really very much interested in your lecture. Now, the time is any one question from the participant, please. Any question, any clarification, any suggestion, let me know.
I welcome comments.
Comments also, please.
Because questions also.
Questions also.
Because this is a kind of approach any researcher in sampling plan should also think about it.
Okay. If it is no question, let us thank the Professor A. Loganathan for his wonderful lecture. On behalf of the organizing committee, I express
thank you, Professor Langon. Thank you, organizers.
Thank you very much. Thank you very much for your wonderful lecture, sir. Thank you very much.
Loganathan sir.
Yes, madam.
Thank you, sir, for a nice talk.
Thank you, madam. Thank you.
Thank you, sir. And thank you, Sudhis sir, for chairing the session.
Dr. Elangovan chaired the session.
Sorry. Thank you, Elangovan sir, for chairing the session. So many halls I am going through now, sir. There is
Definitely.
Thank you, sir, for accepting our invitation. Loganathan sir, as well as Elangovan sir. Thank you.
Thank you, madam. Thank you for giving me this opportunity and for chairing the session, the first one. Thank you.
Thank you, Justice. Thank you.
Thank you, sir. Thank you. Now, in this session, we have a set of contributory papers to be presented. Serial number 139 paper. Serial number 139. The title of the paper is Assessing the Effect of Several Socio-Economic Determinants on Different Levels of Education and Ordinal Regression Approach by Jayanta Deb. Is Jayanta Deb present here? Jayanta Deb.
Please continue.
Cross-perspective. Since Jayanta Deb is not yet in the hall, let me move on to the second paper, a regression method of estimation for generalized extreme value distribution by Anand and Chandran.
Hello.
Hello.
Am I audible?
Anand.
Yes, I am Anand.
Okay. Please start your presentation, Anand, and try to complete it off in 8 minutes, and 2 minutes is for question answers. Okay?
Okay.
Thank you.
Thank you. Hello, am I audible?
You are audible and your slide is also visible.
Okay, thank you.
You can start.
Okay. Good afternoon all. I am Anand, Research Scholar, Department of Statistics, University of Calicut. And this is a joint work with my guide, Professor Dr. Chandran, Department of Statistics, University of Calicut. The topic is a regression method of estimation for generalized extreme value distribution. This is the outline of the presentation. The generalized extreme value distribution, GEVD, introduced in Jenkinson 1955, is widely used for modeling extremes, especially in the case of maxima of independently and identically distributed random variables. The cumulative distribution function is given in equation 1. The basic properties of extremes have been rigorously studied in Embridge et al. 1997 and also in Ledbetter et al. 1983. The proof of the famous extremal types theorem has been also discussed in Ledbetter et al. 1983. A more practical oriented approach can be seen in Coles 2001, and also a point process approach to extremes is seen in Resnick 1987. From the extremal types theorem, there are 3 types of extreme value distributions whose generalized version is given in equation 1. And 3 types are given in equation 2, where the type 1 is the Gumbel distribution, type 2 is the Frechet distribution, and type 3 is the Weibull distribution. Now we consider the estimation of parameters of generalized extreme value distribution. Parameters of GEVD has been estimated throughout the years using the usual techniques available in literature. Stedinger et al. 1983 derived the method of moment estimates. Also in 1980, the initial maximal likelihood estimates of GEVD were derived, and it was later developed by Hosking in 1985. Since the cumulative distribution function of GEVD has a closed form, Hosking et al. 1985 gave a detailed note on how to calculate the probability weighted moments and also derive the probability weighted moments for generalized extreme value distribution. The L moment estimates, which are equivalent to the probability weighted moments estimates, were also calculated by Hosking in 1990. Moreover, in Hosking 1985, it is shown that for samples from 15 to 100, the probability weighted moments or the equivalent L moments perform better in terms of bias and also the variance than the MLE estimates. In 1997, Madsen et al. Showed that the method of moments estimates performs better than maximum likelihood moment estimates and also the L moment estimates in terms of MSE for the parameter values of the shape parameter K minus 2.5 to minus 0.25 to 0.3. In 1985, Smith showed that the regularity conditions for ML estimates holds only for the shape parameter values from 0 to half, and also the Fisher information matrix is finite only in this interval. Also, Martin's 2000 points out that the absurd results are obtained while calculating the ML estimates for small samples. These are the properties of the estimates that are available in the literature. Estimation techniques such as method of moments, maximum likelihood estimates, L moments, and probability weighted moments estimates, when used for small samples, gave inaccurate estimates. A regression method considered in Van Zyl 2012 is applied here for the generalized extreme value distribution. The method provided better estimates for scale and shape parameter of GPD than the currently available methods in the estimates in the literature when the sample size is small. The present study aims to derive regression estimates of GEVD and trying to interpret the estimates for small samples. Now, the method is carried out in the following manner. First, we consider the cumulative distribution function, and it is inverted to reach a regression equation as given in equation number 3. In equation 3, the regression model, equation 3 is a regression model with independent variable x and the dependent variable log of x. Consider the sample of size n from generalized extreme value distribution, and equation 3 can be transformed to equation 4 by replacing the cumulative distribution function by its corresponding empirical distribution empirical distribution function f cap. The left-hand side of equation 4 is the variance stabilizing box-Cox transformation, which solves the problem of heteroscedasticity, since for each fxr, since for each r, the fxr is distributed as beta distribution with parameters r and n minus r plus 1. Similarly, with the problem of heteroscedasticity, the regularity conditions of regression model is violated, and so the errors are assumed to follow a Laplace distribution with mean 0 for each r. The shape parameter K is estimated using shape parameter of GEVD. K is estimated using a profile likelihood method, and an iterative weighted least square technique is used for estimating the scale parameter sigma. Now we consider the vector form of the regression equation given in equation 5. The scale parameter of sigma of GEVD is a function of regression coefficient beta, that is beta equal to 1 by sigma. The Box-Cox method used in Zellner 1986 is applied here for different values of K, and also for each K the regression is performed using equation number 4. The Jacobian involved in the Box-Cox transformation is given in the following equation. Also, the probability density function of Laplace distribution with mean 0 is also given in the equation, and using all this we construct the profile log likelihood of the regression model. The where phi is the parameter of Laplace distribution. The MLE of phi for a given value of K is given in the following equation, and beta cap is the estimate of beta calculated by the method of iterative weighted least squares for a given value of K. The procedure is an initial value of beta is assumed and applied to the given iteration formula so as to obtain the iterative reweighted least square estimates of the regression coefficient beta, which is equivalent to the scale parameter sigma. And we obtain these estimates for sigma, and it is substituted so as to find the value of phi cap. And for each K, from the following equation, log likelihood is calculated, and the value of k for which the log likelihood is maximum is taken, and that k is taken as the estimate of the shape parameter k. Thus, we have obtained the estimates of k as well as sigma. That is the estimates of scale parameter as well as shape parameter. Now we have see a rigorous simulation study. Random samples were simulated from generalized extreme value distribution, and estimation procedures were carried out in order to make comparisons between regression method, method of moment estimation, probability weighted moment estimation, maximal likelihood estimation, and also the L moment estimation. Sample sizes of 10, 20, 50, 100, and 500 are considered. And for small samples, it can be evidently seen that the new regression method performs better than all the other methods in terms of bias and MSE. Here, the value of shape parameter k is restricted to 0 to 0.5 for comparison purposes. Estimates are calculated for 4 different values of k, that is 0.1, 0.2, 0.3, and 0.4. Each sample is iterated 1000 times for illustration purpose. The MSEs and as well as bias are of the estimates k and sigma are tabulated and given. This is the table for MSE, and from this table we can see different sample sizes and the different methods for scale estimation of scale parameter as well as shape parameter. For different values of k, the experiment is repeated, and also estimation is done, and also it is evidently seen that the mean square error of regression estimates are much lower for small samples when compared to all the other methods. Similarly, in the case of bias also, we can see that the efficiency of regression estimates are higher when compared to all the other methods. These are the inferences from the simulation study. While estimating both the parameters sigma and k, the regression method is found to have least absolute bias and also the MSE when compared to all the other methods in the iteration. For both the parameters, the absolute biases and MSEs are found to have an increasing trend for large samples in almost all combinations considered. The method of moment estimates are closest to regression estimates in terms of the MSE and absolute bias. That is, the method of moment estimates even performs better than the ML estimates and also the probability weighted moments estimates in the case of small samples. Moreover, for large samples, the L moment estimates is found to be more efficient in terms of absolute bias and also the MSE. The regression technique, unlike the maximal likelihood estimation technique, exists throughout the parameter space, because in the case of MLE, it is not. It is not the case in the case of MLE. These are some of the references. Thank you.
Any questions or suggestions?
Yes, suggestions.
If no, then let us move on to the next speaker, next paper presenter. Yes, sir.
Thank you.
Thank you. Let us move on to the next presenter. Prediction of outcome of 2020 T20 cricket using classification techniques by Ashwini Rajendran, Malolan, and Prajesh. Ashwini no. None of these presenters are there in the participants list. Okay, then we will end the session as the other two paper presenters are not there. Thank you for joining us. Thank you, professors, for joining us. Thank you. Thank you all.
The vector of unknown observations. The same way, partitioned decision points, known and unknown responses. The derivation of normal equations can be using the likelihood function, can be getting in the form of this. The normal equations to be estimate the parameter beta as well as sigma square and missing responses yu. So those are m, can be obtained using maximum likelihood method by solving these three. And mainly in EM algorithm, there are two steps are there. One is the expectation step. Second one is maximization step. In the expectation step, we can expect the log likelihood and the conditional expectations of missing observations obtained as these two equations. And after getting up the values, we can maximize the parameter by substituting whatever expected values. So minimizing the residual sum of square at each step using the normal equations obtained through the each step and MLE by the considering initial guess or missing values using the following the recurrentive normal equations. That is, so here we are looking these equations. So let us quickly remind what is incomplete block design. If in a block, let us the arrangements of V treatment in B blocks, each of plot sizes K1, K2 up to 7 KB, and treatments are replicated R1, R2, R3 up to 7 RV blocks, and N1 pairs of treatment of first associate occurs in lambda 1 block, N2 pairs of treatments of second associate occur in lambda 2 blocks, and NM pairs of treatments of M associate occur in lambda M blocks. Then the resulting design is said to be a general incomplete block design. And suppose V treatments have to be compared and B blocks are available. Let Ki denote the number of plots in the ith block and Rj the number of plots receiving the jth treatment. If n is total number of plots, then we can write as summation over I is equal to 1 to B, Ri equal to summation J is equal to B, Kj. The statistical linear model for BIBD can be expressed in the form of y is equal to x beta plus epsilon. This can be written in the form of matrix. This is a matrix form we can write. The response value Yij is existing if the ith treatment occurs in the jth block only. Parameter value as well as maximize the parameter values. So this is another example for the first order response design model. So here there are two missing values. So these two missing values can be estimated. So these are the matrix we can estimate by initially we can substitute to 0 or whatever arbitrary values randomly we can take. So these are the estimated values. So if we consider the least square method, then the least square method is slightly different from EM algorithm. So these are the references.
Thank you, Srinivasa sir. The participants, if you have any questions for the speaker. Do we have any questions? Thank you, Srinivasa sir.
Thank you,
Now,
madam.
declare this session as closed. Thank you, presenters and participants, for joining the session. Over to you, organizers.
Thank you, madam. It is a great pleasure to me to introduce actually the Professor Ranjita Pandey. She is from the Department of Statistics, University of Delhi, and she is worked as a senior grade assistant professor in the University of Delhi from 2005 to 10 and associate 2010 to 13 and professor from since 2016 onwards. And her major area of the research is theoretical and applied Bayesian inference and lifetime distributions, time series models, demography and imputation methods, ecological modeling. And she is a member in various statistical societies like Indian Society for Probability and Statistics, Indian Bayesian Society, and Indian Science Congress, and Human Ethics Committee, and also she is Associate Executive Committee member of ICSDS. And she is a committee for the courses of post-graduation in BSc Honors Studies and other various other committees. And also she has published many of the papers and books in various the other journals also. I'm thankful to you for accepting our invitation and chairing the session, madam. Thank you very much, madam.
Thank you, sir, for giving me this opportunity. Thank you.
Now, all the participants are requested to stay in the same hall here for the next actually award ceremony is there in the same hall. So all members will comes to either hall B, hall C, and hall D will comes to hall A. I request all members who are in hall B, hall C, and hall D also join in a hall A.
So are the sessions going on in other halls or
no? Because at 12 o'clock it is a common session actually.
Okay. Okay. That means are we ready to start the award ceremony now?
Yeah, we are ceremony at here, but other sessions the closed or not, that we have to check it once and then I will confirm, sir.
Yeah, please confirm after that. Yeah.
Because B, C, D, they have to close it, the contributory papers, if any are there. If there is one or paper are there, then we'll post to the evening and we will continue this one such that, because it is a complete session.
Yeah, please confirm.
Okay, sir.
Call number 1.
Namaste, namaste, namaste.
Namaste, namaste.
Namaste, madam. Namaste.
Namaste, yeah. So.
Namaskar, sir. Namaskar.
I was looking for you. Okay, you are there.
Yeah, I am here. Yeah.
Yes. Hello.
I request all the members to join in hall A.
Reddy sir is there, Neha is there, and all the, I think all the awardees are there. I don't see the name of Professor Rupus.
Sir, this is Jayasri, sir.
Yeah.
Sir, we don't have sir's contact number. We contact sir over mails.
I don't know. I hope he is informed about this. I don't know that he forgot.
From Harvard.
Namaskar, Anagal. David Anagal.
Professor Reddy, I think you have informed Arup Bose, right, that today he has to join for the award ceremony.
That I think, yes, sir, we have already, because we have sent Neha Garg, she has sent a mail.
Excuse me, sir. Sir, I have sent only the citation readers.
Citation, okay.
No, I have sent mail only the citation readers only.
Okay, anyway, once everybody is ready, we will start the program. In between, let us see whether he joins.
So Bala, meanwhile, if you have any contact number, just to contact Arup.
No, I don't have his phone number.
Maybe the mail ID. I think Jayashree is having the mail contact number.
No, she doesn't have. That is what she told us.
No, sir, I don't have contact number, sir.
Anyway, I think once we start, I think again I'll try through some other source. I don't know. Professor Prakash Rao has his contact number, sir.
Well, let me see. I don't think I have.
Okay.
But a quick email can be sent. So if he is there on some system, he may still see that.
I don't have his
number.
number.
Is available. His LAN number, I don't know whether office or house. LAN number is available. 033.
1 second.
257.
Wait. 033.
2575. 3409.
3409. Let me see.
Office or home, I don't know. Office, then it won't be working.
Yeah, today is Sunday.
Okay.
I think it must be office number. It's ringing, but no response.
I request all the dignitaries to please be on mute, sir. Whenever your turn is there, you please unmute. There will be a disturbance.
Sir, we have some number. Let me try with that number, sir. 1 minute, sir.
Yeah. Anyway, we will, if all others also are free, we will start the program. In between also, there may be, if he joins, we will.
Yes, Balakrishna, I think I can give you his number. Just 1 minute.
Okay.
9830-496
is 98304.
Yes, sir. I am calling to the same number, sir.
96250. Oh, I see. Okay.
Calling to the same number, sir.
Okay, please call.
Yes, sir.
Because he's a member of this society, so I have this directory.
Okay, that's a good thing. I don't know, somehow there is some communication slip, I think. Let us see. Hopefully we'll get him. Professor Bhadracharya, did you check about the other two halls? I mean, B, C.
Sir is joining, sir.
Okay, good, very good. Okay. Now about the other halls, B, C, D, are they free now?
They are closed.
All sessions are closed?
Yeah, all hall B, all C, all D, they came to hall A.
Okay, very good. So about Professor, let me wait for Professor Jayasree's response.
Jay Sri madam, if you say yes, we'll start.
Yeah. He has joined. Good. He has joined. Neha madam, you are ready now?
Yes, sir.
Yeah. Reddies are also ready. Okay. So shall we start the program?
Yeah, please.
Okay. So good afternoon, everybody. So welcome you all to this award ceremony. This is an important event as far as ISPS is concerned, where you honor the award winners as well as the ISPS fellows for the year 2021. Now I invite Professor Rashekar Reddy to chair the session and conduct the proceedings.
Thank you, Balakrishna. Good afternoon to everyone present here. I welcome all to this award ceremony of ISPS. It is my honor to warm welcome to all the awardees, Professor BLS Prakash Rao Garu, Professor Arup Bose, Professor K. Srinivas Rao, Professor K.K. Jose, Professor David Anagal, Professor Somesh Kumar, Professor Sudhis Patanvalli, CR Gold Medalist, and Executive President of ISPS, Executive Members, citation readers, participants, and invitees, and senior professors, Professor J.V. Deshpande, Professor Velaswamy, Vasudeva, Professor Tangaraj, and other members of this award ceremony function. So an idea illuminates and will pave the way for great inventions and wisdom. The efforts of our pioneers in ISPS never goes waste. What enjoying the facilities today are due to the efforts of our seniors. As a part of ISPS annual convention, the seniors introduced to honor Fellow Award of ISPS in 2004 in recognition of his outstanding contribution towards the promotion and advancement of probability and statistics. The first recipient, Professor B.R. Bhatt and Professor C. Hari, has received the Fellow Award. From that onwards, later with the help of the donors, so we initiated Distinguished Statistics Award in 2011. 2014 we started. First we have to give the award has given to Professor Debashish Kundu, and later we also introduced Professor C.R. Rao Lifetime Achievement Award in 2016, the first one which we have given to Professor A.M. Mathai. So there are still now there are 7 more awards like Professor K. Srinivas Rao Researcher Award last year he has initiated, and likely this year also we have received Professor M.N. Deshpande Memorial Prize. This will come from next year onwards. So I am grateful to all the donors who are coming forward and giving their money. Apart from that, we are also conducting some best research papers. For that, Professor A. Mathai has donated 5 lakh rupees for one endowment lecture and one cash prize award for a best research paper. Similarly, Sethuraman has donated 1 gold medal for young statistician. B.K. Kale has donated this prize money for every year 1,500 rupees. Professor M.N. Gopalan has donated every year 2,500 rupees for the prize money for the best research paper. Like that, so that the MSc student project competitions are also we are conducting every year as incentive. So now we are happy to conducting the part of ISPS competition events in ISPS. So now with this, now I request our Dr. Neha Garg, because of she is now the program coordinator and she is now working in associate executive member of ISPS and presently working in IGNO at Delhi. So now I request Dr. Neha Garg as to anchor the events. So thank you. Over to Neha.
Yeah, thank you so much, sir. Namaskar and a very warm good afternoon to everyone. The Honorable President and the Executive Committee members of ISPS, conference organizers, Department of Statistics, Osmania University, Hyderabad, distinguished dignitaries and dear participants. I, Dr. Neha Garg, on the behalf of the Executive Committee of ISPS and on my personal behalf, wholeheartedly welcome you all. It is my privilege to welcome everyone to this 41st award ceremony of ISPS. Today is a day of honor, a day of appreciation, a day of encouragement, a day of motivation, and a day of felicitation of our ISPS awards winners. Today, I feel very delighted and honored to be with you all to recognize the accomplishment of our awardees. For ISPS, rewarding its fellow is extremely important. Now let's acknowledge and celebrate their moment of glory, as has been the custom of Indian Society of Probability and Statistics for many years. So without further delay, let's start the ceremony. Now it's given me immense pleasure to announce the name of Professor C.R. Rao Lifetime Achievement Award, which goes to Professor V.L.S. Prakash Rao, INSA Senior Scientist, C.R. Rao, Advanced Institute of Mathematics, Statistics and Computer Science, Hyderabad. Many congratulations to you, sir. Now, I would like to request Professor Sarda Bhatt from the Department of Statistics, Karnataka University, to share some of the Professor Prakash Rao's achievement from his long list of credentials. Over to you, ma'am.
Namaste, everyone. Thank you, organizers, for giving me this opportunity to read the citation of Professor B.L.S. Prakash Rao. Thank you, Neha. I am very happy to read the citation of Professor B.L.S. Prakash Rao, recipient of Professor C.R. Rao Life Achievement Award. Bhagavatula Lakshmi Surya Prakash Rao, aka B.L.S. Prakash Rao, is an Indian statistician. He was born on October 6, 1942 in Korumamila, Kadapa district, Andhra Pradesh. He completed his BA honors degree equivalent to MA in mathematics from Andhra University in 1960 with a record-breaking performance and moved to the Indian Statistical Institute, Kolkata, where he completed his MStat degree in statistics in 1962. He graduated with a PhD in statistics from the Michigan State University, USA, in 1966 under the supervision of Professor Herman Rubin. Hope I am clear. Professor Prakash Rao's major research interests are in the areas of stochastic processes, stochastic inequalities, characterizations of distributions and limit theorems in probability, and in the areas of parametric and non-parametric inference and inference for stochastic processes in statistics. Professor Prakash Rao has published more than 300 articles in national and international journals and had authored and edited 18 books in the areas of statistics and probability. He has reviewed more than 70 books and delivered more than 100 invited lectures in national and international conferences. He has visited several universities all over the world during more than 30 academic visits abroad. His works were cited in more than 25 books, and he had more than 5,000 citations of his articles till now. Professor Prakash Rao was the editor-in-chief of Sankhya Series A and Sankhya Series B during the years 2012 to 2015 and was a member of the editorial boards of several national and international journals over the years. Professor Prakash Rao worked at the Indian Institute of Technology, Kanpur, during 1968 to 76 and later moved to Indian Statistical Institute, New Delhi. He was a professor and later distinguished scientist at the Indian Statistical Institute during the period 1976 to 2004 and was the director of Indian Statistical Institute during 1992 to 95. He has also held visiting professorships at the University of California, Berkeley, University of Illinois, University of Wisconsin, Purdue University, University of California and Davis, and University of Iowa in USA. He was Jawaharlal Nehru Chair Professor during 2006 to 8 and Dr. Homi Bhabha Chair Professor 2008 to 12 at the University of Hyderabad and Ramanujan Chair Professor during 2012 to 2017 at the C.R. Rao Advanced Institute of Mathematics, Statistics and Computer Science, Hyderabad. He is presently an emeritus professor of the Indian Statistical Institute and an INSA senior scientist at C.R. Rao Advanced Institute of Mathematics, Statistics and Computer Science, Hyderabad. Professor Prakash Rao received the Shanti Swarup Bhatnagar Prize for Science and Technology in Mathematical Sciences in 1982 from the Government of India, Outstanding Alumni Award from the Michigan State University in 1996, and the National Award for Outstanding and Meritorious Work in Statistics in the memory of P.V. Sukhatme in 2008 from the Ministry of Statistics and Program Implementation, Government of India. Professor Prakash Rao was selected for the Distinguished Service Award by the Mathematical Association of India in 1999 and was awarded Lifetime Achievement Award by the Indian Association for Reliability and Statistics in 2015. He is an elected member of the International Statistical Institute 1982 and elected fellow of the Institute of Mathematical Statistics, USA 1983, Indian National Science Academy 1984, Indian Academy of Sciences 1992, National Academy of Sciences 1992, and the Andhra Pradesh Academy of Sciences 2012. The ISPS is privileged to honor and confer the Professor C.R. Rao Life Achievement Award to Dr. B.L.S. Prakash Rao as a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India on Sunday, the 13th March 2022. Indian Society for Probability and Statistics, ISPS, 13th March 2020.
Thank you so much, madam, for taking time to read the citation. Now I request sir to bless us with few words of encouragement. Now I request to Professor Prakash Rai sir to share his thought with us.
So I would like to thank at the outset Professor N. Balakrishna, President of ISPS, Professor Rajsekhar Reddy Garu, Honorary President of ISPS, Professor Malik, Secretary of ISPS, and Professor Srinivas Rao and other members of the Executive Committee, and Professor Jayasri and Professor Bhattaracharyalu of Usmania University, and all the colleagues for honoring me with this Lifetime Achievement Award. I really appreciate this award that's going to be presented. And as in a few minutes, I can only tell you that I started my statistics journey at the Andhra University in 1957-60 when I was a student of mathematics honors, and statistics was just one subject. Then later on, I moved to ISI and I learned more directly from Professor C.R. Rao. I was a student in the first batch of MStat degree. And then later on, he was my guru most of the time. But I went abroad to do PhD under Professor Herman Rubin. And then I returned again. I spent some time at IIT Kanpur and then went to ISI Delhi when Professor Rao moved to ISI Delhi. And he has been my inspiration for the last several years. In fact, even today, I'm editing a special issue in honor of him for Journal of Quantitative Economics, which will be released sometime at his 102nd birthday. So C.R. Rao has been my advisor throughout, and it's a great honor to receive a Lifetime Achievement Award in honor of him from the ISPS. And I appreciate with all the greetings and help and ideas from all the colleagues for me to achieve and to receive this award. Thank you very much.
Thank you so much, sir. Your commitment reflects the endless hours you have spent in achieving the target. Many congratulations, sir.
Thank you very much. Thank you.
No one will disagree with the fact that excellence is a result of sincere effort, intelligent direction, skillful execution, and vision to see obstacles as opportunities. So coming up next is a fellow of ISPS. This year, ISPS is announcing 4 fellows of ISPS. It is privileged to honor and confer the Fellow of ISPS award to Professor Arup Bose from the Indian Statistical Institute, Kolkata. Sir, many congratulations. Now I request Professor Kirutika from the Department of Statistics, Pondicherry University, to take over the screen and recite the citation for the sir.
Good afternoon to everyone. Dr. Arup Bose is a professor at the Indian Statistical Institute since 1995. He has been holding a J.C. Bose National Fellowship since 2009. He is an elected fellow of the Institute of Mathematical Statistics, USA, Indian National Science Academy, New Delhi, Indian Academy of Sciences, and National Academy of Sciences. He is also a winner of the Prashanta Chandra Mahalobis Medal in CA, Shanti Swarup Bhatnagar Award in Mathematical Sciences, the National Award in Statistics, and the Young Researcher Award of IISA USA. His current primary research interests are in the large dimensional random matrices, free probability, and high dimensional statistics. His earlier research areas include principal agent theory, resampling, non-parametric asymptotics, U statistics, estimates, second order properties of sequential point and interval estimates, and statistical estimation in nonlinear parametric diffusion processes. With more than 65 research collaborators, he has published over 150 articles in leading journals of statistics, probability, and economics and econometrics. He has authored 5 books: Random Matrices and Non-Commutative Probability, Patterned Random Matrices, Large Covariance and Auto-Covariances Matrices with Monica Bhattacharjee, and Random Circulant Matrices with Kaushik Saha, and U Statistics, Estimates, and Resampling with Sigandu Chatterjee. He has been on the editorial board of several journals and is currently an editor-in-chief of Random Matrix Theory and Applications. He has served on the editorial board of Sankhya during 1993 and 2007, the last 6 years of these as an editor. The ISPS is privileged to honor and confer the Fellow of ISPS award to Dr. Arup Bose, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, jointly organized by the Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March, 2022. Very congratulations, sir.
Thank you so much, madam, for reading the citation. Now I would like to invite Professor Arup Bose for his inspiring words.
Thank you very much for this honor, and it's a really great honor. And I thank especially Professor Balakrishna, who approached me saying that I might receive this honor. And it's any honor is always an encouragement to do better. So I'll strive harder to work with my colleagues and with my students and serve the cause of probability and statistics. I also want to recall that because Professor Prakash Rao is here, and he has been a great supporter of me. For example, when he was the director of the institute, that is when I got on the editorial board of Sankhya. My PhD thesis, the first two papers were directly extension of his work in diffusion processes. So I remember that very fondly. And people like him are always supportive of juniors like me. So with those words, thank you very much for this great honor, and I'll strive to be worthy of it. Thanks.
Thank you so much, sir. Your dedication is really inspiring. The higher the sense of accomplishment when you eventually achieve something, the harder you work for it. Our next fellow of ISPS is Professor K. Srinivasa Rao, Principal, Andhra University College of Science and Technology, Visakhapatnam. Many congratulations to you, sir. May I now request Professor Anjita Pandey, Department of Statistics, University of Delhi, to read the citation person.
Thank you, Neha. Citation for Professor K. Srinivasa Rao, sir, Fellow of ISPS. His passion towards statistics and data sciences is unmatchable. Professor Rao has joined Andhra University as Assistant Professor in the year 1985, and he was elevated as Senior Professor. He has 37 years of experience in teaching, research, and consultancy. With strong foundations in mathematics and statistics, he has pioneered several new concepts such as independent communication, network models with dynamic bandwidth allocation, new symmetric distribution, family of bimodal distributions, generalized Laplace distribution, generalized logistic distribution, further generalization of generalized Gaussian distribution, merged distributions and their applications in image segmentation, face recognition systems, skin color segmentation, economic production quantity models with random production, hybrid communication network models with optimal scheduling, optimal control charts with random in-control times, manpower planning, models with heterogeneous bulk recruitment, heterogeneous queuing models. Professor Rao got Distinguished Statistician Award from ISPS in the year 2016. He is a fellow of AP Academy of Sciences, conferred in 2010, fellow of ORSI in 2016. Dr. Rao has guided 55 students for PhD degrees. He has published 237 research papers in various international and national journals of high repute. He has successfully completed 13 research grants funded by Government of Andhra Pradesh UGC, DST, Ministry of Family Welfare. He has conducted more than 28 international conferences, seminars, workshops, training programs. He has delivered 159 endowment, keynote, plenary invited lectures in various conferences and seminars. He has published 3 patents in image segmentation, skin color identification. He has served as lead consultant for TCS Bengaluru, Satyam Engineering Services Hyderabad, ADB Solutions Hyderabad, Bharat Heavy Electricals Limited Hyderabad, Aurobindo Pharma Hyderabad, Dr. Reddy's Laboratories Hyderabad, Sagar Cements Hyderabad, Visakhapatnam Port Trust Visakhapatnam, and Lucas TVS Chennai, and several other corporates. Professor Rao was elected President of Indian Society for Probability and Statistics during the years 2019 and 2020. He was elected Vice President of Operation Research Society of India during the periods 2011-12 and again in 2014-16. He was elected Chief Editor of JISPS during the period 2010 to 2018 and Associate Editor for OpSearch during 2014 to 2018. He also served as Vice President Operations of JBS, an MNC company during 2004-06, while on loan from Andhra University. He has written a book on model-based color image segmentation. Dr. Rao served at Andhra University in various capacities as head of the Department of Statistics for 3 times, Chairman, Board of Studies in the Statistics, ISO Coordinator, and Management Representative during the period 2006 to 8. He is Coordinator of UGC, Dean R&D, Chairman, NAC Steering Committee, and Chairman, Faculty of Sciences, Andhra University, Convener, APRCET for the years 2018 and 19. Presently, Dr. Rao is serving as Member Secretary, APSET, SET during 2015 and Principal, Andhra University College of Science and Technology, Visakhapatnam since 2020. The ISPS is privileged to honor and confer Fellow of ISPS Award to Dr. K. Srinivasa Rao, a renowned scientist and inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March 2022. Congratulations, sir.
Thank you, madam, for reading the citation. May I now request Professor K. Srinivasa Rao to oblige us with few words of encouragement. Sir, please unmute yourself.
At the onset, I thank the President of ISPS, Professor Balakrishna, and the Honorary President, Professor Rajshekar Reddy, and Secretary S.C. Malik, and all other executive members and other members of ISPS, and also the organizing committee members of this conference, Jayashree and her team, for confirming this honor. I feel it is a privilege for me to accept this honor, and it made me to take the responsibility of further strengthening my skills in research and consultancy. And I thank all my students, particularly for who have encouraged me to take the research work, and all my teachers, especially in this endeavor. And I thank all the people who are responsible to confer this to me. My association with ISPS is from 1984. When I was a scholar, I attended the first of my conference in Kerala University of that in 1984. Thereafter, I have been associated with ISPS in several portions. Now I feel this is an honor conferred to me for the works that I have done in the works of statistics as well as propagating the statistics. I thank everyone for the given opportunity. Thank you.
Congratulations, sir. Thank you, sir, for your motivating and thought-provoking words. The cornerstone for one's achievement is hard work, dreams, and determination. Our next fellow of ISPS award is Professor David D. Hanagal, Honorary Professor, the Symbiosis Statistical Institute, Pune. Many congratulations to you, sir. Allow me to request Professor G. Jayashree from the Department of Statistics, Osmania University, Hyderabad, to introduce Professor Hanagal.
It's a privilege for me to read the citation of Professor David Hanagel. Dr. David Hanagel is honorary professor at the Symbiosis Statistical Institute, Symbiosis International University, Pune, India. He is a retired professor and head at the Department of Statistics, Savitribai Phule, Pune University, India. An elected fellow of the Royal Statistical Society, UK. He has authored 5 books, 6 book chapters, and published over 135 research publications in leading journals. He guided 9 PhD students and 1 MPhil student in different areas of statistics, namely reliability, survival analysis, frailty models, repair and replacement models, software reliability, and quality loss index. He has delivered more than 100 invited talks in many national and international platforms of repute worldwide. He also has worked as a visiting professor at several universities in the USA, Germany, and Mexico, and delivered a number of talks at conferences around the globe. He is working as editor-in-chief, associate editor, and editorial board member of several reputed national and international journals. He is chairperson, subject expert, and advisory committee member in several UGC committees. He is a National Assessment and Accreditation Council assessor from UGC. Sir is also a subject expert in Board of Studies committees of several universities. Sir is a governing council member, executive council member, and life member of several statistical societies, organizations, and associations, and was also past vice president of ISPS during 2017 to 2018. His research interests include statistical inference, selection problems, reliability, survival analysis, frailty models, Bayesian inference, stress strength models, Monte Carlo methods, MCMC algorithms, bootstrapping, censoring schemes, distribution theory, multivariate models, characterizations, repair and replacement models, software reliability, quality loss index, and non-parametric inference. With over 35 years of research experience and over 40 years of teaching experience, he is an expert on writing programs using SAS, R, MATLAB, Minitab, SPSS, and SPLU as statistical packages. He was born on 16th April 1957 at Gadag, in Karnataka state, and was educated in Gadag, Harvard, and Pune. After completing his MSc from Karnataka University, Harvard, in 1980, he joined Bharatiya Vidyapith Pune and later Savitribai Phule Pune University, Pune in 1988. The PhD degree was awarded to him in 1992 from Savitribai Phule Pune University under the guidance of Professor B. Kale. Sir, he worked in several positions at Savitribai Phule Pune University and retired in 2017. The ISPS is privileged to honor and confer the Fellow of ISPS Award to Dr. David D. Hanagel, sir, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st annual convention of Indian Society for Probability and Statistics jointly organized by Department of Statistics, University College of Science, Usmania University, Hyderabad, Telangana, India, on Sunday, the 13th March 2022. Congratulations, sir, and thank you for giving me this opportunity.
Thank you, madam, for citing the achievement of Professor Hanagar. Now I would like to request sir for sharing few words.
Good afternoon to all of you. I thank ISPS, especially the Honorary President, Professor Rajshekar Reddy, President of ISPS, N. Balakrishna, Secretary, Professor S.C. Malik, and other committee members, EC members, organizing committee of the ISPS from Usmania University, and those who are involved in the conference for honoring me with a fellow of ISPS. I have been associated with ISPS for a long time, maybe more than 30 years. ISPS has grown a lot and became one of the productive statistic organization in India. First time I attended the ISPS conference in 1991, held in Usat, Cochin. That time there were a lot of participants from Pune. Myself, Balakrishna was there, the present president, R.P. Suresh, Professor Kunte, Mohan Kale, and several other research students were there. And Professor Kunte was leading us all the time during the conference. And that was a very good occasion during that time. That time, I think Professor B.R. Bhatt was the president of ISPS. Then he moved to Botswana, then Professor B.K. Kale became president, and so on. I am attending the ISPS since 1991, and ISPS committees such as I have worked in the ISPS as a committee member, as a vice president, EC member, and convener of A.R. Kamath Award Committee, and so on. I thank all the persons involved in cooperating all these activities during my time when I was working out in these committees. I have been associated with ISPS very long time and also ready to serve ISPS in future also. I once again thank ISPS for honoring me with this fellow of ISPS. Thank you once again. Thank you to all. Thank you.
Thank you so much, sir. I'm sure your experience will help us stay motivated. Many congratulations, sir. The harder you work for something, the greater you feel when you finally achieve it. With deep admiration, I announce the name of Professor K.K. Josh, Honorary Director, Mahatma Gandhi University, Kottayam, who is receiving the Fellow of ISPS Award. Many congratulations, sir. Now I request Dr. Upal Shah, the Department of Statistics, the MS University of Baroda, to read the citation for sir.
Thank you, Dr. Neha. I'm thankful to the ISPS body for giving me this opportunity. It's really a matter of great pleasure and honor for me to read the citation for Dr. K.K. Josh, sir. Dr. K.K. Josh Kanichukattu, born on 3rd July 1957 at Ilanji, a small rural agrarian village in Ernakulam district, Kerala, had his studies at Ilanji, Kuravilangad, Palai, and Trivandrum in Kerala, India. His parents were Kurakutti and Annamma, small-scale farmers. He passed MSc Statistics from University of Kerala in 1980 with University first rank and joined St. Thomas College, Palai as a lecturer in statistics in December 1980. He was awarded PhD in statistics by the University of Kerala under the guidance of eminent professor Dr. R.N. Pillai in 1995. He became associate professor and head of the Department of Statistics at St. Thomas College, Pillai in June 1997. He was instrumental in starting MSc Biostatistics under UGC Innovative Program in 2005. He was appointed as principal on 21st April 2009 and retired from regular services on 31st March 2014. After retirement, he served as professor and head of the Department of Statistics at the Central University of Rajasthan during 2014-15. He was awarded KSCSTE Emeritus Fellowship during 2015-2018. He was honorary president of Kerala Statistical Institute, Thiruvananthapuram during 2015-18 and served as honorary director of the Department of Biostatistics at St. Thomas College, Pillai during 2018-20. He was appointed as an honorary director of the School of Mathematics and Statistics and School of Data Analytics at Mahatma Gandhi University, Kottayam in June 2020. Dr. Jose is an eminent academician who had rendered more than 40 years of meritorious service as a reputed principal, professor, and head of the department, teacher, researcher, and organizer. Dr. Jose has successfully guided 25 research scholars in their PhD work and published more than 150 research papers in reputed national and international journals. He has authored 5 research-level books and successfully completed 6 research projects sponsored by UGC, DST, MOSPI, etc. He had been organizing secretary of international and national conferences and workshops in connection with the annual conferences of ISPS, SSCA, and SSFA, etc. held at Pillai. He had been invited speaker, resource person for more than 150 national, international conferences, seminars, workshops, etc. He had visited various countries. Just a second. Am I audible?
Yes, madam.
Yeah. Please go ahead. Please go ahead.
He has visited various countries as invited speaker in international conferences. He was recipient of World Bank Travel Fund on ISI in 2011 and 2012. He had wide exposure in statistics and biostatistics fields. Dr. Jose served as the General Secretary and President of Kerala Statistical Association during 1994 to 2000 and 2000 to 2006 respectively, and organized over 200 quiz programs and regional seminars for popularizing statistics in Kerala. He was chairman of PG Boards of Studies of MSc Statistics, Biostatistics, and Actuarial Sciences at MG University, Kottayam during 2006 to 2012. He was member chairman of examination boards of MSc, MPhil, PhD of various universities in South India. He was editor of Stars International Journal, executive editor of Journal of Kerala Statistical Association, and reviewer of many international journals. He was joint secretary of ISPS for 2 terms and hosted 24th annual conference of ISPS at Pillai in 2004 and was executive council member of SSCA and ISPS many times. Dr. Jose is an elected member of the International Statistical Institute, Netherlands, and a fellow of Royal Statistical Society, UK. He's a member of various professional societies like IMS, ISPIS, Informs, ISBA, ISMS, Bernoulli Society, ISPS, KSA, and the list is long. He has won the SB Award for Best College Teacher in Kerala in the year 2007. AIACHE Award 2008 for Most Innovative Teacher, and Professor P.V. Sukhatme Award for ISMS in 2012 for his significant contributions in teaching, research, and development in statistics and biostatistics. Many of his students are in IAS, ISS, etc. Ms. Lishamal Tommy, research scholar, under his guidance, won Jen Timbergen Award of International Statistical Institute in 2007. He won the Sam Higginbotham Award of AIACHE for the Best College Principal in India during 2012-13. He was selected as Best Principal under MG University, Kottayam in 2010-11 and 2013-14. He was awarded FSMS Fellowship by the Indian Society for Medical Statistics in 2021 in recognition of his contributions to theory and applications of statistics in the biostatistical field. The ISPS is privileged to honor and confer the Fellow of ISPS Award to Dr. K.K. Jose, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, jointly organized by Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March, 2022. Thank you so much. Over to you, Dr. Neha.
Yeah, thank you so much, madam, for citing the achievements of Professor K.K. Jose. Now I request sir for sharing few inspiring words, sir, please.
Thank you, ma'am. Hello.
Yes, sir.
Yes, sir. Please go ahead.
Okay. So, esteemed President of Indian Society for Probability and Statistics, Professor N. Balakrishna, respected Chairperson of the program and Honorable President of ISPS, Professor Rajshekar Pillai, General Secretary, Professor S.C. Malik, all members of the Executive Committee, then the organizers of the host of the 41st ISPS conference of the Osmania University, Professor Jayasri, and all faculty members, all senior professors, colleagues, and my dear friends of Statistical Fraternity of India. I am extremely grateful to ISPS and its executive committee for presenting this award of ISPS Fellowship to me. I humbly accept this prestigious award as a mark of recognition of my humble contributions to the field of statistics and related areas. My association with ISPS started from 1990 onwards, while I was a research scholar at the University of Kerala under my professor R.N. Pillai, who was president of ISPS at that time. And I participated in the first ISPS conference in Pusat in 1991, then Pune and various other centers in India. I have attended more than 20 annual conferences of ISPS. And I was very fortunate to host the 24th annual conference of ISPS at St. Thomas College, Bali, maybe the first time for India College. And I was also a member of the executive committee of ISPS and the the joint secretary of ISPS for 2 terms. And it was I remember with gratitude my professors, Professor R.N. Pillai, Professor K. Ramaswamy, who instilled my interest in statistics and to pursue research and teaching in statistics. I pay my tributes to the great founders of Indian Society for Probability and Statistics, And I have benefited a lot by attending the annual conferences and interacting with the great statisticians like Professor C.R. Rao and many others during ISPS conferences. Now the world has realized the power of data, and we are living in a data-driven world. All decisions are data-driven, and it has led to the development of new disciplines like data science and data analytics. So statisticians are in demand all over the world. It should be considered as a threat to statistics. The statistics community has to become equipped to meet the challenges of big data, along with theory and applications. Statistical computing and data review are important in the present day situation. We have to change ourselves with advancements in using softwares like R, Python, etc. So with these words, I accept this award and thank all of you. So may I wish you all a glorious future. Thank you. Thank you.
Thank you so much, sir, for your motivational remark. Many congratulations to you again. An award is a powerful mode to endorse the feeling of pride, a sense of accomplishment, and even joy. Now, let me take the pride to announce the ISPS Distinguished Statistician Award for the year 2021, which goes to Professor S.C. Malik, Department of Statistics, MD University, Rohtak. Many congratulations to you, sir. Allow me to invite Dr. D. Lalita Devi from the Department of Applied Statistics, Kasturba Gandhi Degree and PG College for Women, Telangana, to take over the screen and read the citation of the position holder.
Thank you, ma'am. Good afternoon, one and all. It's my privilege to present the citation of Professor S.A. Malik, a distinguished statistician at this wonderful event of 41st Annual Convention of ISPS Conference. Dr. S.A. Malik is presently working as Professor, Department of Statistics, MD University, Rohtak, Haryana. His field of research specializations are reliability theory, sampling, and applied statistics. He has teaching interests in the field of real analysis, measure theory, optimization techniques, complex analysis, probability theory, statistical methods, reliability theory, and stochastic processes. He has published 3 books in the field of real and complex analysis, and 205 research papers are to his credit. He has supervised 45 PhD and 30 MPhil students in the subject of statistics. Dr. Malik has been invited by various academic institutions to deliver talks and to present research papers at conferences, seminars, symposium, workshops held in India and abroad, including USA, UK, Portugal, Singapore, Germany, Hong Kong, France, Spain, Netherlands, Belgium, Austria, Italy, Japan, Switzerland, and Nepal. He is a reviewer of various journals, specifically for all journals in the areas of reliability, operations research, and statistics. Professor Malik has been a life member of various academic and professional bodies. Sir is the founder president of Indian Association for Reliability and Statistics, IARS, and also chief editor of the UGC listed journal IJSRE, being published by IARS. He has worked 3 times as elected member of section of Mathematical Sciences of ISCA. He has been associated with several universities in India as an outside expert in Board of Studies and at the Court and Academic Council. He has also organized various academic activities in the form of workshops, seminars, and conferences of national and international level. Sir has been appointed by the UGC as a member of Advisory Committee for SAP. He has completed successfully a UGC MRP on reliability modeling of computer systems. Recently, the Department of Science and Technology, DST, has awarded the prestigious project matrices to Dr. Malik for a period of 3 years. The ISPS is privileged to honor and confer the Distinguished Statistician Award to Dr. S.C. Malik, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, jointly organized by the Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March 2022. Congratulations, sir. Thank you, Neha ma'am, for giving me this opportunity.
Thank you, madam, for reading the citation. Now, I would like to request Professor S.C. Malik to share a few words with us.
Yes, a very good afternoon, all of you. First, I would like to thank the entire ISPS community to give me a chance to achieve this award. Really, I'm very thankful to the President, Professor Balakrishna, the Honorary President, Professor Rajsekhar Reddy, and the members of jury who took decision to honor me, to recognize my contribution. I salute the entire ISPS community first. Then I dedicate this award to my research scholars who made me to achieve this award. Without the contribution of my research scholar, I was not in a position to get this award. Really, I'm grateful to all my research scholars. I'm also thankful to my university who provided me a platform to carry out the research activities, to do something in teaching in the subject of statistics. When I joined MD University Rohtak, Haryana, it was very poor condition of the subject statistics. No student was ready to opt this subject, statistics. They always offered mathematics at their priority. But now I'm happy to share with you that we are now in a position in Haryana, MD University Rohtak, that we have more than 50 students intake in our department. So all because of the efforts of my research scholars, my teachers, my university, and I tried my best to get this situation at the national and international level. Really, I'm very grateful to the entire statistics community, and really a very enjoyable moment for me. I accept this award, and for this, I'm also thankful to the organizers of this conference for providing this platform to the ISPS to honor one or more persons in order to recognize their contribution. So thanks all of you for giving me this chance. Thank you all of you. Salute to all you. Thank you, madam.
Thank you so much, sir, and many congratulations once again. Nothing can beat the feeling of discovery, something new for the first time, something that may have existed for thousands and thousands of years, but we never discovered before. This year, the ISPS is privileged to honor and confer the Professor K.S. Rao Best Researcher Award to Professor Somesh Kumar from the Indian Institute of Technology, Kharagpur. Many congratulations to you, sir. Now, I would like to request Professor Sada Bhatt from the Department of Statistics, Karnataka University, to read the citation for this, sir.
I am very happy to read the citation of Professor Somesh Kumar, recipient of K.S. Rao Best Researcher Award. Professor Somesh Kumar has research interests in the area of statistical decision theory and inference. He has published more than 100 research papers in the area of statistical decision theory and inference, probability theory, quantum computation and robotics. He has supervised 11 doctoral and more than 200 masters for MTech and MSc dissertations. He is an associate editor of American Journal of Mathematical and Management Sciences, Taylor and Francis. He has been on editorial board and referee for many national and international journals. He is an elected member of the National Academy of Sciences, Allahabad, India. He was an elected member of the Executive Committee of the Indian Society for Probability and Statistics and an elected General Council member of the Forum for Interdisciplinary Mathematics. He has developed 3 video courses on probability and statistics, statistical inference, and statistical methods for scientists and engineers under NPTEL project of the Ministry of Human Resources and Development. These are available through websites of NPTEL and YouTube, etc., and have received millions of views worldwide. He received the Platinum Jubilee Lecture Award of the Indian Science Congress Association in 2016. He is on selection panels of faculty positions at various IITs, NITs, universities, and other academic organizations. He is also a member of admission committees, board of studies of many institutes and universities. He has delivered more than 150 invited lectures and talks in various national and international conferences, symposia, and workshops, and also chaired sessions. He has been a resource person for several short-term refresher courses at IIT Kharagpur and other institutions. He has visited the University of Ulm and the University of Dortmund in Germany as a guest professor. He has also visited Middle East Technical University, Ankara, University of Wollongong, Australia, University of Salzburg, Austria, University of Colombo, Sri Lanka, for delivering invited lectures. He has held administrative positions of President, Students Gymkhana, Dean of Students Affairs, Organizing Chairman for Joint Admission Test for MSc, JAM, etc. He has interest in contributions of ancient Indians to mathematics and regularly teaches the course History of Science and Technology in Ancient India for students in IIT Kharagpur. He regularly delivers expert talks on this topic for various universities and institutes. The ISPS is privileged to honor and confer the K.S. Rao Best Researcher Award to Dr. Somesh Kumar, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by Department of Statistics, University of College of Science, Osmania University, Hyderabad, Telangana, India on Sunday, the 13th March 2022. Indian Society for Probability and Statistics, ISPS, 13th March 2022.
Thank you so much, madam, for reading the citation. Now I would like to invite Professor Somesh Kumar to share his inspiring words. Over to you, sir.
Sir, Professor Somesh Kumar, sir, unmute. Yes.
First of all, I would like to thank all the
Not audible, person.
Somesh Kumar, you are not audible.
Senior functionaries of Indian Society for Honorary President, ISPS, Professor N. Bal. Okay, just a minute. Yeah. Can you hear me now?
Now I can hear you, but earlier.
Now you can hear me? Yeah.
Please continue.
Yeah, please.
Okay,
continue.
sure. Okay, yeah. First of all, I would like to thank all the
Professor Somesh Kumar, again you are not audible. There is some signal problem, I believe.
Can say without camera, you can say that. Probably that will help you.
Okay. Yeah. Professor Malik, General Secretary of ISPS, all the faculty members of the Usman.
Still the problem. Somesh Kumar, still we can't able to hear you.
Who are present today in the conference at the moment. I would like to thank all my teachers at IIT Kanpur who actually generated my interest in statistical research and teaching, and also all my research scholars with whom I could work on so many different problems. And I learned that in order to actually develop yourself, you should really work on different areas. So, and especially it is apt that it is the award is named in the name of Professor K. Srinivas Rao, who has also worked on so many different topics. This also encourages me to work even harder for doing more service to the statistical community in the form of teaching as well as research. At this moment, I would like to thank especially my parents and also my family members for supporting in my work. I would also like to thank my PhD supervisor, Professor Diwakar Sharma, and all other my professors at IIT Kanpur who taught me the fine things about the statistics. I would also like to thank some of my collaborators like Professor P. Vellai Swami of IIT Bombay, Professor Neeraj Mishra of IIT Kanpur, Professor Kishore Sinha, Professor Ashish Sen Gupta, with whom I interacted and learned many new things. Finally, I would like to thank all my research scholars with whom I could work on different areas. Finally, I thank once again Indian Society of Probability and Statistics for bestowing me with this award. Thank you very much to all of you.
Thank you so much, sir, for sharing your thought with us.
I'm sorry that there was some network issue when I'm speaking, so I don't know whether my full thing could be told here or
yes,
not.
We were able to hear you. Thank you so much, sir, for sharing your thought. Many congratulations to you once again. Confidence is born within, but when someone recognizes your work, then it makes lots of difference. This year, Professor C.R. Rao Gold Medal goes to Dr. Sudhis Kumar Kuttumanil from the Indian Statistical Institute, Chennai. Many congratulations to you, sir. Now, I would like to request Dr. Subha R. Nair from NSS College for Women, University of Kerala, to take over the screen and introduce the position holder.
Thank you, Neha ma'am. Good afternoon, respected professors, organizers of the conference, and esteemed participants. I find myself privileged to have gotten this opportunity to read the citation of Dr. Sudhis Kumar Katumanil, Professor C.R. Rao Gold Medal winner of this year. And I express my sincere thanks to the organizers of the conference, the president and executive members of ISPS, and to my guide and mentor, Dr. Satish Kumar sir. Dr. Sudhis Kumar Katumanil is an associate professor in Indian Statistical Institute, Chennai, India since 1st January 2020. He worked as assistant professor in University of Hyderabad from 17th March 2009 to 22 December 2011. He joined Indian Statistical Institute, Chennai as an assistant professor from 23 December 2011 to 31st December 2019. He was a postdoctoral fellow in City University of Hong Kong from 2nd May 2019 to 2nd September 2019, and Indo-US fellow in Michigan State University from 30th December 2013 to 29 December 2014, a postdoctoral fellow in Indian Statistical Institute, New Delhi from 17 March 2008 to 16 March 2009. He completed his BSc in Mathematics in 2000 from University of Calicut, Kozhikode. He was awarded MSc in Statistics in 2003 and PhD in Statistics in January 2009. His thesis was submitted on 31st December 2007 by the Cochin University of Science and Technology, Cochin, India. He has many awards and fellowships in his credit, like the Mathematical Research Impact Centric Support 2018 by SERB DST Government of India, Indo-US Research Fellowship 2013, constituted jointly by Science and Engineering Research Board DST Government of India and Indo-US Science and Technology Forum, Indo-US Research Fellowship 2013, constituted jointly by Science and Engineering Research Board DST, Government of India, and Indo-US Science and Technology Forum, Jan Timbergen Award for the Young Statisticians from Developing Countries 2009, International Statistical Association, Netherlands, NBHM Postdoctoral Fellowship 2008, Department of Atomic Energy, Government of India, U.S. Nair Memorial Young Statistician Award 2006 by the Indian Society of Port Probability and Statistics, and UGC CSIR Junior Research Fellowship 2003. He has published 32 research papers and 1 book. He has supervised 1 PhD and completed 1 major project of budget 13.6 lakhs. His 15 research papers are currently communicated or under revision, and 10 research papers are under development. He is an associate editor in Journal of Indian Statistical Association, JISA. The ISPS is privileged to honor and confer the Professor C.R. Rao Gold Medal Award to Dr. Sudhis Kumar Katumanil, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist, at this 41st Annual Convention of Indian Society for Probability and Statistics, ISPS, jointly organized by the Department of Statistics, University College of Science, Osmania University, Hyderabad, Telangana, India, on Sunday, the 13th March 2022. Congratulations, dear Professor. Thank you.
Thank you so much, Madam, for reading the citation. Now I would like to invite Dr. Sudhis Kumar for sharing his thought.
I am very happy today. I think you can see everything is fine. I could not see, that's why.
Yeah, go ahead.
Yeah, I am very happy today. I would like to thank ISPS and jury for selecting me this award. I thank all the teachers of Department of Statistics for encourage constant support, which I am getting. I did my PhD under the supervision of Dr. N. Nair, who is the former president of ISPS. During my PhD, he always encouraged me to do good research. But after that, I went to Indian Statistical Institute, Delhi, for doing my postdoctoral work. Professor Isha Diwan, the supervisor, always give a good support. Still, she is giving good support to me. I also would like to mention the support I am getting from Professor N. Balakrishna to do good quality of research work. I always talk to him. He always give advice in personal and academic matters. I am very happy to have a lot of good collaborators, so that I could contribute to the statistics. I also would like to acknowledge the love and support I am getting from my mother, wife Ramya, and daughter Veda. Finally, I would like to mention one point. When I message to Professor Isha Diwan that I got this award, then she wrote 2 messages. One is congratulations, Sudhish, and the second one is responsibility to work hard. I promise to this gathering that I will try my best to do good research work in the future. Thank you all for blessing me in this occasion. Thank you.
Thank you so much, sir, for sharing your thought with us. Now, I would like to invite Professor Parameshwar V. Pandit from the Bangalore University to announce the best research papers. Over to you, sir.
Thank you. Am I audible?
Yes, sir.
Yes.
Okay. The President of ISPS, Professor Balakrishna, Honorary President Professor Rajshekhar Reddy, and other executive members of ISPS, Professor Jayashree and Professor Bhattacharyalu of organizing committee and their team. So it is my privilege to announce the best research paper awards. There are 4 awards. I just would like to read those. The first is ISPS Young Statistician for Best Research Paper Award. This goes to Shilpa Subhash of Cochin University of Science and Technology. Congratulations, Shilpa. The second
award is Dr. A.M. Mathai Cash Prize Award. It goes to Aradhya Girish Ramachandra, Central University of Rajasthan. Congratulations, Girish. The third is Dr. M.L. Gopalan Prize Award. It goes to Dilip Kumar Yam from University of Calicut. So congratulations, Dilip Kumar. The next award is Dr. B.K. Kale Prize Award. Goes to A.S. Satinthar, University of Kerala. So congratulations, Satinthar. So I congratulate all the winners personally and on behalf of ISPS. I thank ISPS executive body for giving me this support. Thank you. Thank you.
Thank you so much, sir. And many congratulations to all the researchers who have received the Best Paper Awards. Now, I would like to invite Professor C. Satish Kumar from the University of Kerala to announce the Best MSc project. Over to you, sir.
With great pleasure, and on behalf of the President, Secretary, and EC members, Honorary President, and EC members, and Associate EC members of ISPS, we would like to announce the results of ISPS MSc Project Competition Award 2021. This time we received 7 entries and we shortlisted 3 among them based on the adjudication reports of 3 experts. And on 11th March, the first day of the conference, these 3 teams were allowed to present their project reports. And on the basis of the reports of the 3 judges, we come up with the final ranking as per the consolidated evaluation reports of all the experts. With the permission of the ISPS and EC members and associated EC members, and all those who assembled here in this forum, let me to announce the result. The first rank goes to the team from Department of PG Studies and Research in Statistics, Mangalore University. Vinita Sararo, Sukesh Kayan, and Ankita K. The second rank goes to Department of Statistics, Yenipoya Deemed University team. From there, Sushama, Sanjana S, and Lahiri L are the team members. The third rank goes to the team from Department of Statistics, Madras Christian College, Chennai. The team members are Ashwini Rajendran, Malolan T.A. and Prajesh S. Once again, I utilize this occasion to congratulate each of these team members, and their certificates will be sent to you by email or by post from the ISPS office.
Thank you so much, sir, and many congratulations to who have received the Best MSc Project Report Award. Before concluding this award ceremony, on the behalf of the Executive Committee of ISPS, I would like to express my gratitude to all the jury members of all the committees for their efforts and significant assistance during this process. Thank you so much for being with us today, and we sincerely wish to see you all again in the next convention of ISPS with renewed enthusiasm and energy. Now I hand over the session to the chairperson of this award ceremony. Thank you so much.
Yeah, thank you, Neha. Before going to propose vote of thanks, I would like to congratulate to all the awardees of this program, of this ceremony function, and I'm also grateful to Dr. Neha, the program coordinator, and all the citation speakers. So now I request Dr. Venkateswaran, who is our treasurer, I request you to propose vote of thanks.
Good afternoon to all of you. I'm very much happy to present the vote of thanks for this award ceremony. On behalf of ISPS and on my personal behalf, first I wish to thank ISPS President, Secretary, Honorary President, EC members and AEC members, and award committee members for identifying the deserving personalities to honor them. Then I would like to thank Dr. Neha Garg from IGNO, New Delhi, for coordinating the award ceremony, also in preparing of citation and invitation. Thank you, madam. Then I would like to thank Professor Sharada Bhatt, Bangalore University, Professor Kritika, Pondicherry University, Professor Ranjita Pandey, University of Delhi, Professor G. Jayashri, Usmania University, Hyderabad, Dr. Rupal Shah, MS University, Baroda, Dr. Lalita Devi, Kasturba Gandhi College for Women, Telangana, Dr. Subha R. Nair, NSS College for Women, University of Kerala, for presenting the citation of the awardees in a nice way. Thank you all of you, madam. Then I would like to thank the awardees, Professor BLS Prakash Rao sir from C.R. Rao Institute, Hyderabad, for getting a Professor C.R. Rao Lifetime Achievement Award, Professor Arup Bose from ISA Calcutta for getting Fellow of ISPS, for Professor K. Srinivas Rao, Andhra University, Vishakhapatnam, for getting Fellow of ISPS, Professor David Hanagal, the Symbiosis Statistical Institute, Pune, for getting Fellow of ISPS, Professor K.K. Jose, Mahatma Gandhi University, Kottayam, for getting a Fellow of ISPS. Then Professor S.C. Malik, MD University, Rohtak, for getting the award, Distinguished Statistician Award. Professor Somesh Kumar, IIT Kharagpur, for getting Professor K.S. Rao Best Researcher Award. Dr. Sudhis K. Kotumanil, ISI Chennai, for getting Professor C.R. Rao Gold Medal. I would like to congratulate and thank all the awardees for receiving this award. I also thank all the committee members of Best Research Paper and Best MSc Project teams and the awardees also. Thank you one and all.
Thank you all of you.
I think with that we are done with the award ceremony. I will start, Professor Reddy. Yeah. Okay. So thank you all for making this very grand success. I think it went on very well. Thanks to Neha, in particular, and also Professor Reddy for coordinating all the things. Professor Satish and Professor Pandit for managing the competitions. Also for all the jury members. Thank you. Thank you very much.
Thank you, Bala.
Thank you,
Thank you,
Professor.
Rao. Dr. Srinivas Rao.
Thank you all of you.
Yeah. I think we will meet in the afternoon session.
Okay. Bye.
Okay. Bye.
Right,
Let
sir,
us have some lunch now.
Right, sir. Kodu Srinivas garu. Namaskaram. Okay. Yeah.
Hello, Raghunath sir.
Good afternoon, Vishnuvardhan garu.
Good afternoon, sir. Baanara?
బాగానే ఉన్నాండి.
Okay, good. Okay, ఇదే ఇప్పుడే మీ ప్రొఫైల్ లింక్డ్ఇన్ లో చూశాను. ఎంఎస్సి ఉస్మానియాలో చేశారు కదా, పిహెచ్డి కూడా ఉస్మానియాలో చేశారు.
అవునండి, అవునండి.
నౌ యు ఆర్ డైరెక్టర్ ఫర్ డేటా కైజెన్ సొల్యూషన్ సార్.
అవునండి, అవునండి.
ఓకే, 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 గుడ్.
ఐ థింక్ మీరండి మెయిన్ విష్ణువర్ధన్ గారు.
సార్
మీరు ఎక్కడ ఉన్నారు?
నేను ఇప్పుడు అసోసియేట్ ప్రొఫెసర్ డిపార్ట్మెంట్ ఆఫ్ స్టాటిస్టిక్స్ పాండిచేరి యూనివర్సిటీ సార్.
ఓకే, ఓకే, తెలుగు వాళ్ళేనా అక్కడ ఉన్నారు అయితే?
అవును.
ఓకే,
ఆల్మోస్ట్ 12 years అయిపోయింది ఇక్కడ జాయిన్ అయ్యి.
ఎట్లా ఉంది సార్ పాండిచేరి యూనివర్సిటీ?
సెంట్రల్ యూనివర్సిటీ కదా సార్, వీ హ్యావ్ సమ్ గుడ్ ప్రివిలేజెస్. స్టూడెంట్స్ కూడా మాకు బ్రాడ్ స్పెక్ట్రమ్ లో వస్తారు, వరల్డ్ ఇండియా వైడ్ వస్తారు. ఫ్రమ్ డిఫరెంట్ పార్ట్స్ ఆఫ్ ద కంట్రీ విల్ గెట్ ది స్టూడెంట్స్.
వండర్ఫుల్. ఐ థింక్ మన ఇద్దరమే ఉన్నాం.
మీరు స్పీకర్ అని మీ ఇనిషియల్ లేదు అంటే ఆన్లైన్ లైవ్ ఉంది కదా యూట్యూబ్ లో.
అంటే మనకి పార్టిసిపెంట్స్ ఎవరు కనిపించారు అయితే?
లేదు లేదు, అంతా యూట్యూబ్ లోనే జాయిన్ అవుతారు నాకు తెలిసి. చాలా వరకు స్పీకర్స్ మటుకే జూమ్ లో వస్తున్నారు అనుకుంటున్నాను.
మరి దే హావ్ టు ఆస్క్ క్వశ్చన్స్. క్వశ్చన్ వాళ్ళు ఎట్లా అడుగుతారు మరి?
అది మేబీ ఆర్గనైజర్స్ హ్యావ్ టు రెస్పాండ్ ఫర్ దట్.
అయినా మామూలుగా అయితే యూట్యూబ్ అఫిషియల్ అయినా మన ఫ్రీ అయినా కూడా ఇట్ ఈస్ అకామిడేటింగ్ 40 to 100 members మోర్ దెన్ దట్. మరి యూట్యూబ్ ఎందుకు అవసరం వచ్చిందో వీళ్ళకి?
ఏమో సార్. మీరు ఇప్పుడు కంప్లీట్ గా డేటా మెషిన్ లెర్నింగ్ మీద వర్క్ చేస్తున్నారు సార్?
అవునండి, అవును. అంటే ఈ వర్క్ ఇక్కడ హిందీ మహావిద్యాలయంలో ఒక కాలేజ్ ఉంది, అటు 60 years old కాలేజ్. దానిలో ఎంఎస్సి సెషన్స్ కూడా తీసుకుంటా అండి నేను.
ఓకే, నైస్ నైస్.
మీరు ఎక్కడ వాళ్ళండి విష్ణువర్ధన్ గారు? వెరీ టు డూ యువర్ ఎంఎస్సి ఎక్కడ చేశారు?
ఎంఎస్సి పిహెచ్డి శ్రీ వెంకటేశ్వర యూనివర్సిటీ అండి.
తిరుపతి.
ప్రొఫెసర్ కేవీఎస్ శర్మ గారు పేరు వినే ఉంటారు. ఐ డిడ్ పిహెచ్డి అండ్ విత్ హిమ్.
ఓకే.
ఆ తర్వాత నేను సిఆర్ఆర్ రీసెర్చ్ ఇన్స్టిట్యూట్ లో హైదరాబాద్ ఉంది కదా, అక్కడ రీసెర్చ్ అసోసియేట్ గా 1 year చేశాను.
అప్పుడు బిఎస్ రావు గారు ఉన్నారా?
ఎస్బి రావు.
ఎస్బి
రావు డైరెక్టర్ అప్పుడు, ప్రొఫెసర్ ఎస్బి రావు డైరెక్టర్. ఓకే. ఆ తర్వాత నేను ఇక్కడ పాండిచేరి యూనివర్సిటీ జాయిన్ అయిపోయాను 2010 ఆగస్టులో. మేజర్ గా నేను కూడా క్లాసిఫికేషన్ టెక్నిక్స్ లోనే వర్క్ చేస్తాను.
ఓకే. ఈ హాఫ్ అన్ అవర్ ఏం చెప్పాలి? చాలా
అలాగే అయిపోతుంది సార్ టైం. హాఫ్ అన్ అవర్ మనం అనుకుంటాం కానీ వన్స్ వి స్టార్ట్ 30 minutes.
No, point is it is not excess time, it is insufficient time.
అట్లా
100%. And half an hour అసలు ఏం చెప్తాం హాఫ్ అన్ అవర్ లో? I was just thinking. In fact, my good friend Dr. Bhattacharya, head of the department Usman University, నాకు సీనియర్ అతను 1 year.
అచ్చా,
ఆయన చెప్పారు ఏంటంటే మీరు సెషన్ తీసుకోవాలి అంటే 3 గంటలు ఉంటుంది.
ఓకే, ఓకే. No, that 3 hour session will be generally with workshops or webinar training programs. In conferences, invited talks అనేది 30 minutes ఉంటాయి జనరల్ గా.
అంటే నేను కూడా ఇంతకుముందు కాన్ఫరెన్స్ అటెండ్ చేశాను సార్. నార్మల్గా ఇప్పుడు రెగ్యులర్ జేఎన్టీ ఉస్మానియా వాళ్ళకి అడ్రస్ అదర్ డిపార్ట్మెంట్స్ కూడా చేస్తున్నాం, కానీ మరి హాఫ్ అన్ అవర్ పెట్టలేదు.
సెషన్స్ ఇన్వైటెడ్ టాక్స్ వచ్చి హాఫ్ అన్ అవర్ ఉంటాయి సార్. వీఆర్ యూజ్డ్ టు దట్. హలో,
గుడ్ ఆఫ్టర్నూన్ సార్.
యా, గుడ్ ఆఫ్టర్నూన్ సార్.
విష్ణువర్ధన్ సార్, గుడ్ ఆఫ్టర్నూన్ సార్.
యా, గుడ్ ఆఫ్టర్నూన్.
గుడ్ ఆఫ్టర్నూన్ డాక్టర్ రఘునాథాచార్య.
గుడ్ ఆఫ్టర్నూన్ భట్టాచార్య గారు. ఇప్పుడే అనుకున్నాం మీ గురించి.
Okay.
Now, shall we start, sir?
Yes,
100%.
So, it is my privilege to introduce the chair of the session, Dr. R. Vishnuvardhan from Central University, Pondicherry. Sir is as an assistant professor in associate professor in Department of Statistics, University of Pondicherry, and has delivered many of the invited talks. And his major area of the research is machine learning, multivariate data analytics, and predictive modeling, and also on query-based learning and need-based learning. And I take this floor leaving to Dr. Vishnuvardhan Rao, Dr. R. Vishnuvardhan, to chair the session and I request you to introduce the Dr. M. Raghunatacharya. Sir, are we having the share the?
Sir, I can do that, no problem. So thanks to the Dr. Bhattacharya Garu for giving this opportunity to chair the session. And in this conference only, my name is taken with all permutation and combinations. Okay. So my name is Vishnuvardhan Rudravaram or R. Vishnuvardhan. Since the speaker has the initial M, so to have a matching sample, M. Vishnuvardhan is made. Okay, that's fine. Okay, let us come to the introduction to the today's speaker, Dr. M. Raghunatacharya. He did master's from Usmania University and PhD in statistics from Usmania University in 1999 with a special reference, in the area domain called applied stochastic processes. Thereafter, he did MBA in marketing management from Tamil Nadu National Open University. After that, he worked as a senior business analyst in Denusos, and thereafter he was a visiting professor in ABS, where he taught marketing research, business analytics, and he mentored several students and conducted some surveys as well. Thereafter, he moved in the year 2007. He moved to, he was appointed as a director for decision tree consultancy services, where again he worked on modeling and marketing research firms with a group of professionals. And now currently he is a director for Data Kaizen Solutions. It has been since 3 years he is acting as a director for Data Kaizen Solutions, and he is expert in statistical data mining, operation research, model building, and particularly market research surveys, and training students with a lot of encouragement and motivation. So with this simple brief profile, I welcome Dr. M. Raghunatacharya to deliver his talk for about 30 minutes, and over to you.
Thank you very much, sir, for your kind introduction. Good afternoon, Professor NCH Bhattacharya Garu, Vishnuvardhan, Mahesh, Ranjita. I'm just worried, are we the audience? Anybody else are there? Right. In fact, I had a talk with Vishnuvardhan ji earlier. So it is live on YouTube. So if people were to ask the questions, I will ask was my question. Anybody from video technologies? I think two names are flashing here.
Questions from the participants will post it in the chat box.
Chat box will appear in our Zoom as well?
Yes. It will appear, sir.
Okay, fine. Right. So thank you. I thank Department of Statistics and ISPS for giving me an opportunity to deliver a lecture. So I switch off my video for a while so that it becomes comfortable for our audience to. So this video, can you give me sharing of my screen?
Yes, sir.
Yeah.
So now you can present.
Yeah, I'm able to do it now. Thank you very much. All right. I'm sure you're able to see my whiteboard here.
Yes, yes, sir. We are able to.
All right, perfect. So video technologies, you kindly let me know in case it's not visible on the YouTube. I'm not able to see that. Okay, fine. Now, I'm presenting on a PPT here. Today, lecture being a half an hour, I thought I'll quickly give overview of what's happening. Overview of the contents and if possible, demonstrate some of them. So classification.
We are able to see the whiteboard, not the PPT.
1 second, sir. So in fact, I'll be displaying 3. One is whiteboard, other is PPT, other is R Studio. These 3 I'll be displaying. Let me just share screen, share.
Yeah. Better
now
you
whiteboard is
select the
visible.
screen. Yes, correct.
Now, is the PPT visible, sir, now?
No, sir. No, sir. Sir, while sharing, better you select the screen.
If you want to present multiple and select.
Pardon me, sir?
If you want
Sir,
to present multiple tabs, you can type.
What is it? Multiple? Yes, please. Please tell me.
Okay. Sir, while you once you do the click on share button, no, you select the screen button, okay, screen window, so that every activity that you do, multiple windows can be seen without any issue. Okay, sir.
Oh, I'm using Zoom for past 12 years, sir. In fact, I have professional affiliation as well. My point is here, this is not sharing, not able to do that. Anyway, let me continue.
Okay.
So now, yeah.
Yeah, PPT is visible now.
Right, sir. So basically, classification, we have binary, multiple classification, binary classification where there are 2 categories in the data, multiple, more than 2, as we all know. For instance, we are working with banking data. We talk about defaulting, non-defaulting. If maybe we have mails we need to classify, we're trying to classify mails to be spam or no spam. And multiple classification, for instance, we are looking at credit scoring model, where we try to give high, medium, low, more than 2 categories. In such cases, we go for multiple classification techniques. Just to give overview how we can take up classification. 1 second, I'm sharing my studio here. Yeah. I'm sharing my R Studio in kindly video technologies. Kindly let me know in case I'll be sharing 3. In fact, I gave share option by default. It should display whatever I share here. I'm trying to share here R Studio and PPT and the whiteboard.
So please press on screen. You have to share your total screen so that there is no problem sharing.
No, you have an option here.
PPT or some other tab. Please press on the screen tab so that your total screen will be presenting in the meeting.
No, do you want me to press share option regularly? That's what we do, isn't it?
Yes, sir. Yeah.
That's what I did precisely. If you press on one, it will display only that. I just pressed share option. I think all should be visible, whatever I'm doing. Okay. All right. Is the whiteboard is visible?
Yes, sir.
Right, sir. Thank you. Sorry for disturbing. Now I have a file here, telco file. Now I'm trying to display R Studio. So are you able to see our studio now? Video, you have taken my remote control. Are you able to see?
No, only
sir, I'm trying
whiteboard
to
is
do
seen
it.
to us.
Now.
Sir, you only try to present it, sir. We are not getting access to presentation.
No, my point is, now you are also taken the remote control. No, tell me what that you want to do. Do it.
Yes, sir. Whenever you are presenting models, we have access to your remote control, your keyboard and your mouse, so that we can select your.
Fine. Anyhow, now I'm showing our studio. This is the data I have here.
Yes.
Now, basic segmentation. Then subsequently we go for some of the known machine learning or advanced models. I want to segment customers based on their age. So usually what do we do based on the age? So you take maybe some partitions based on whatever the objectives or whatever you want to predict objectives. Maybe you try to classify the customers to be in different age groups. Maybe 1, 2, 3. All right. Now, similarly, we have income. I'm talking income of the customers here. We're talking with structured data only, not unstructured informal data, structured data. Suppose I'm trying to classify these as 1, 2, 3. So maybe superimposing one on the other, we can further classify and we get 6 different combinations. If you have multiple variables, maybe you have an option. For instance, I take here from this particular data, I take employee. Employee is number of months he has been with the present employer. Suppose I take these 3. Maybe list out 3 combinations. Suppose I make employee also into 3 categories. Then I have 27 different combinations wherein I try to classify the customers. If you want to see on a 2-dimensional plane, maybe you can reduce these 3 into 2, be giving appropriate weights to income, age, or income, employee, or all the 3 give different weights and reduce them to 2. So this is how clustering has been started with, classification has been started with. Usually people started using that in business domains for profiling the customers. Profiling customers helps to cater the customers better, service the customers better. So some of the techniques which we use in statistics most often, logistic regression, decision trees, random forest, Navy-based classifier. Let me attempt few of them for the understanding of the audience. Now I'm using here, I wish to classify the customers based on age and income. And we have a variable here called churning. Churn usually in telecom is branch switching. So I wish to classify a future customers based on the data available to me. Future customers churning, we have an option here, yes, no. So I consider maybe age, income, employee, these 3 I consider. And using the values of these 3, I wish to classify the future customers as churning, yes, no. I try to classify binary classification, making use of logistic regression. We all know logistic regression gives the odds ratio, probability that odds ratio or the probability that a customer likely to leave the service, odds ratio, or it gives the probability. probability of y is equals to 1, given the values of, in case here I'm taking 3 variables, x1, x2, x3. This data has already classification, making use of this data. So I wish to classify the future customers. General procedure, as all we know, we have to, suppose this data has 1,000 records. We take control group and test group. Otherwise, we call it as a train set and test set. So maybe train set or control group, maybe 70% to 80% we consider, and rest of them maybe to test the model which you have built. Okay. So what am I trying to do is making use of these 1,000 records, making use of this available data. We try to classify the customers, future customers, meaning whether the customers whom we have now, other than this 1,000, if you have taken X customer, how likely that, what is the chance that he is going to churn, is going to leave your service? All right. So GLM is generalized linear models. Let me just store it in GL. Store the. So churn basically here in, let me attach my telco file here. All right. So now churn basically is in categorical variable yes, no. I just try to code it. Code using if else or using factor. Anyone you make use of that. Churn and levels. This coding is simple. I'm just trying to code this data which has got this yes, no. Into 1001. Yes should be 1, no should be 0. All right. So now let me fit the generalized linear model now. GLM which we are trying, which I named it as GL, is equals to C churn, because I attach the telco file, so no need of giving dollar symbol, age plus income plus employee. Employee stands for number of years has been with the present service. We need to give a here family. Family binomial, 2 categories here. Now so we have the model here, the equation here. So make use of these to predict whether customer likely to churn or not. Y is equal to 1, given the values of x1, x2, and x3, as we were talking earlier. We can develop simple function or interactive model which predicts. Here you substitute this in our logistic regression equation. I'm sure it is visible to you. A1 x1 plus A2 x2, like that, A3 x3. So you can make use of this equation. Make use of this equation. To predict, classify the customers one by one. Sorry, something is there in chat. Let me check. Yeah. We try to classify individually. If you want to classify, make use of this equation, try to classify. Of course, we all know that here these star symbols are indicating the significance, whether the variables which you have considered are significant or not. Whether age is significant in predicting, classifying. Similarly, income is significant predicting, classifying. This all appears less than 0.05, and we can consider here they're all significant at 5% level of significance. Instead, if you want to classify all of them at a time, classifying here is only, it gives the probabilities. Logistic regression gives the probabilities. So we can try here the option predict. The predict function works with the package caret. So make use of that package for predicting the probabilities that in my 1,000 customers data, actually we make use of the control group, test group concepts. So I'm just trying on the total data set straight away here. Now we need to add here type is equals to this is giving the probabilities of churning, so that we can understand chance of the customers churning, right? So we can compare perhaps with the original data, if at all you calculated the probabilities. Next, let me demonstrate quickly on another classifier model, decision trees. These are all supervised learning methods. Supervised learning meaning the researcher's intervention is required, wherein we try to mention, just to say in a simple terms, we try to mention which of them are dependent and which of them are independent variables. Our intervention is required. So let me quickly explain to you decision trees. Decision trees, as we know, it gives a set of rules identifying. When we started our data mining learning, we have learned with decision trees, as we all know. So identifying novel, previously unknown, hidden patterns in the data. That's where we've learned decision trees first. So constructing decision trees here, there are many ways in R and Python to construct them. There are different packages available. I'll make use of R part, regression partition. R part already I used in the morning. That's why it's giving quick response. So R part, same data, already we have attached telco. So churn, I think it should accept. Earlier we have taken C churn for logistic regression because we need to take yes as 1 and 0 as no. Here I'm just taking as it is, age plus, sorry, I'm rushing because of time. Age, income, employee, data is equal to this. So these are the rules it is throwing, and slightly difficult to understand. Slightly takes time to understand the rules. Let us present this in the form of a graph. So I take here R part dot plot just to check this in the form of a graph. So let me store these. So R part dot plot D3. So we have the, I'm not sure how many are able to see this. Let me increase the font bit. Okay, they're going out. Okay. I do one thing to make the graph simple. Let me just take only 2 variables instead of 3. Let me remove this employee part and quickly do the graph. Maybe it looks easy. We can pick it up fast. So now we have decision tree coming up here. Green is indicating those of churn, and the blue, light blue, they're indicating not churning, no, and yes. So these decision trees, I'm sure when we started data mining, we have learned, you all learned, it gives the rules which we not know much in the data. Let me just quickly work on random forest, and let me just check the balance time. A random forest, as the name suggests, a random forest talks about forest is set of trees, random forest, randomly selected trees. What it does here, from the given data, as we all know, bootstrapping, it selects some trees, for instance, some files. For instance, my telco file has 1,000 records. My telco file has 1,000 records. Of these 1,000 records, it takes samples of 800, each consisting different records, and of course, different variables as well. Different records and different variables as well. Random records and random variables. This process, we call it as bootstrapping. And here in random forest, we call it as bagging. Now, these 800, I'm just saying roughly, this 800 have been once again taken 500, 300. This 800 is not a fixed figure, but this 500 is a default figure. So this 300. Now what it does is it constructs decision trees on each one of these 500 files, meaning we have got 500 decision trees here. We've got 500 decision trees here. Now what happens here, it picks up the best accurate decision trees, assume the top 10, which have given maximum prediction accuracy, then tests on these. And these 300 files are referred to as out of the bag, OOB. As we talk about control group and test group. And we said earlier, usually we call it as train set, test set, control group, test group. Let me demonstrate random forest quickly. We need to download a package here. Once again, different packages are available. I'm installing a package called random forest. Mind you, F is capital. It could do quickly because already installed in the morning. I've just trial run that in the morning. Now my random forest is ready. Let me just give RF is equals to random forest, F capital. Same, I'm just trying to predict churn behavior of the customers. Curl symbol, let me take age plus income plus employee. Data is telco data. Object churn is not found, maybe capital C. Yeah. So my RF has got, my random forest has, I'm ignoring some, it is giving some warnings. I'm ignoring them for the time being. Now, I stored that in RF. Just let me quickly interpret the output here and let us take stock whether we have time for doing anything else or not. So initially it constructed 500 trees. Okay. Now OOB out of the bag, out of 500 trees, as we retained decision tree earlier, it retained best 10 trees and maybe averaging it out and taking the rules and tested them on the OOB. and the error rate found on the out of the bag sets is 4.67. To be precise, of course, false, positive, true, negative, those terminology you must be familiar with. If not, in simple terms, I have Setosa. I'm sorry. 1 second. 1 second. Let me just. We're trying for telco, no? Okay. It's expecting here C churn. I'm sorry. Yeah. Now let me just type RF here. Now, please observe. Sorry, it has gone to something else earlier. Now, so what exactly we're trying to do is trying to predict the churning behavior of the customers, making use of the values of these three: age, income, and years of employment, right? So as I mentioned to you earlier, it constructed 500 samples on which the tree's been constructed, and the error rate appears very high. 31 is the error rate.
Excuse me, sir.
Yes, please.
Sir, please conclude in 5 minutes.
Now, so here, error rate appears quite high. 31 is earlier 70% accuracy. Earlier, I mean, I'm talking somewhere in 2007. In business circle, 70% is good. Now people are expecting much higher levels of accuracy. Now 31 is pretty high error. Now if you just check the confusion matrix, basically this confusion matrix to unconfuse us, right? So it is predicting roughly you have 274 ones, 274 those who have churned, the random forest model is predicting out of 274, this random forest model out of 274, it is predicting 47 as only as 1, and rest of them it is predicting as zeros. Wrong prediction is happening here, whereas rest of the maybe 724 or 726 records, it is predicting where there is no churning, zeros, it is predicting 643 as non-churners. So we notice here in predicting ones as ones, almost error has gone to 82%. Predicting zeros as zeros, it has gone to 11%. And this error, let us not to go by the error percentage, why it is not matching with this. This is in OOB. This is with respect to out of the box, the ones which I'm talking about, which I talked about with you earlier. The file telco has 1000 records. In these 1000 records, it selects randomly, constructs by default 500 trees. And of course, it's your option.
The last 3 minutes.
Stopping. In fact, at 3 o'clock, I have some presentations also. Sure, sir. Now, in case you want to increase number of trees and want to check the accuracy levels here, suppose I want to make it 1000 instead of 500. Now just check what is the prediction accuracy. It has come down a bit. Maybe if I give here prediction accuracy to be, I mean number of trees to be 10,000. It takes a while. Not much time. It should be over in less than a minute. Yeah. It's still at 30.8. So maybe the variables which I have taken for predicting churning, they are not very appropriate for predicting We have taken age, income, and employee. These may not be very suitable for predicting. Maybe something else which are predominantly influencing churning that we need to identify either intuitively or using some kind of maybe at least to start with, at least to begin with factor analysis. I mean principal component analysis mathematically to identify the predominant variables, or the researcher find out with his intuition the predominant variables.
Can mute Mr. Raghavendra Sharma, please. Yeah, thank you. Yes, sir. Dr. Raghunath, are you done?
Yeah, I think more or less I've done with. In fact,
Yeah,
I have
thank
three
you.
more to present because of time. I think I should stop here.
Yeah. Thank you so much for what we say, kind of a detailed explanation. You have touched upon logistic regression and the partitioning and generating the decision trees, and how to understand, and even with respect to how to understand this out-of-box estimate and how it is connected to the selection of variables. And before we introduce a model, so what sort of variables that are to be taken care of. So that and all you have discussed in a very nice way. Thank you so much for your enlightening talk. And thanks organizers for giving this opportunity to chair this wonderful session. Thank you so much.
Thank you very much, Vishnu. Thank you.
Thank you, Vishnuvardhan sir, for chairing the session.
Yeah, thank you.
Good afternoon to all the delegates and speakers present over here. Let me take the privilege to introduce Dr. Raghunath Acharya sir, currently working as a director at Data Kaizen Solutions, Andhra Pradesh. Sir is the chair of this session. And sir, I request you to occupy the chair and conduct the contributory paper session in the stipulated time.
Sure, madam. Thank you. So can we start with the presentations? By the way, I request these video technologies kindly give me permission for sharing. Reasons being, I have, yeah.
Yes, sir.
Maybe you can give sharing possibility for multiple. Yeah, thank you. Today's presenters are Kanchan Saha, Govind Rao, Padma Sahu, Prakash Kumar, Suru Munda, PK Manmohan, and Rajiv Rajan, Ranjan Kumar, Himatri Shekhar, Kaustav Aditya, Preeti Badgi, G. Prabhavati. I welcome all of you. Let us start with the serial number. Do Kanchan Sinha is present? Kanchan Sinha is present. She has to deliver.
Yes, sir. Yes, sir. I'm here, sir.
Oh, okay. Kanchanji, your paper is a comparative study on onion prices, statistical machine. You are trying to compare onion prices using statistically machine learning and deep learning. Am I right?
Yes, sir. Yes.
Fine, you can proceed. There are 11 members. Each person is getting roughly 8.18 minutes. Already it is 3:10. By 4:30, 4:40, I have to stop. Okay. So meaning for presentation, you have 6 minutes and question answer session 2 minutes. You can start with.
So
I shall give you a bell after 6 minutes.
Okay, sir.
Yeah.
So first, let me share my screen. So I hope this screen is visible, sir.
Visible.
Good afternoon, everyone. I am Dr. Kanchan Sinha, and the topic of my presentation is a comparative study of statistical machine and deep learning approaches for prediction of onion prices in India. So I'll start with a very basic introduction of time series. So time series is a sequence of observation on a single phenomena observed over time, and observations are collected in many areas ranging from agriculture, finance, social sciences, and so on. And the basic aim of time series focusing is to develop a model that describes a good description of the main features and to forecast based on the past data given the model. Over the years, there are many approaches utilized for time series forecasting, like linear and nonlinear time series modeling and machine learning approaches. But statistical time series model has some limitations, like they suffer from stationarity, non-linearity, and seasonality. Whether machine learning models aim to automatically learn and recognize patterns in a large amount of data. But these techniques also have some weaknesses, such as they are not suitable for the crucial AI problems and image recognitions, and suffers from curse of dimensionality and feature extraction. So recently, deep learning techniques gaining popularity in the research community, which is inspired by the human brain called artificial neural networks. And when we add more number of layers or recurrent connections in the neural network model, this increases or empowers to provide various levels of data representation and feature extraction, which is called as deep learning. So there are many advantages of using deep learning, such as they are suitable to handle large number of data sets, and this will reduce also human intervention in modeling. So the forecasting issues regarding onion price. So onion is one of the most important vegetable crops, and the forecasting of this onion price is an integral component for trade and policy analysis. And this is one of the most market sensitive agricultural commodities, suffers from having volatility, seasonality, and this volatility is mainly due to the production uncertainty and export policy, unforeseen rainfall, and there are many more factors. So onion price forecasting remain a challenging aspect in the modern era of agricultural commodity price forecasting. And over the years, several authors have been attempted to forecast or to investigate structural breaks, causality, and volatility in different onion market prices. So there are very limited study in the deep learning frameworks available. So motivation of this study that we don't know which deep learning models will perform better for the onion price forecasting. And if we have a sufficient amount of data, then deep learning models will outperform the machine learning models And we can also compare the performance of deep learning models with traditional statistical model. And there are very limited study focused on the onion price forecasting based on deep learning frameworks, and convolutional neural network models can be an alternative choice for deep learning models for onion price forecasting. And the models are, say, the ANN model. It is a class of nonlinear, data-driven, and self-adaptive approach. And the main aim is to map the set of input to the set of output pattern in a nonlinear way. And in case of recurrent neural network, there are some loops which allow information to persist, and it can memorize the parts of the input and use them to make accurate predictions. As in case of traditional neural network model, with the input and output observations are considered as independent of each other, but as the sequential pattern exceeds the time series data, this is not the appropriate assumptions. So there are some disadvantages in the recurrent neural network model, that it is not suitable to learn the long sequences. Therefore, LSTM model has been developed, and it performed the modeling using some getting mechanism and for the flow of information. And one such model here is the convolutional neural network model. It is also a class of neural network model which is basically useful for image recognition problem, and it has mainly three components, such as convolutional layer, pooling layers, and fully connected layers. And it is generally designed to automatically and adaptively learn the spatial characteristics of features following the principle of backpropagation. For the illustration purpose, here we have replaced three onion market price data: Ajadpur, Bangalore, and Mumbai market price data. These market price data are selected based on their arrival, and these data are collected from the EggMarkNet website. And you can see that Bangalore market have the highest amount of variability in the price series. And before conducting the analysis, we have also checked non-linearity, non-stationarity, and heterogeneity in the price series. So these are the three time plots of these market prices, and you can see all the prices have high fluctuations in them. And this is the framework to perform the comparative analysis. So first we have collected the data from the EggMarkNet website. There is a daily data, and there is a missing observation. So first we impute the missing observations using forward imputation techniques, and then we converted those daily observations into weekly. And after that, we take the logarithm transformation, and we divide the data into two parts: training part and testing part. Training part for model building, and testing part for auto-sample focus performance. So we have replaced various architecture of the statistical, machine, and deep learning models, and based on those, we have get the auto-sample focus value, and we can compare this auto-sample focus with training data set based on RMSE, ME, and MAP criteria. So this is the first model, LSTM model. So the main hyperparameters are the hidden layers, the number of flags, and the memory cells. So using grid search method, we have selected the optimum number of input flags, memory cells, and hidden layers. And This is done by varied the number of input layers from 1 to 20 and the number of memory cells from 1 to 10. So in this way, you can select optimized model for the LSTM for 3 markets, as well as for a bidirectional LSTM model for this 3 market. And then we have stacked next layer to the first layer, and in this way we can say the stacked LSTM model, which is also called a deep LSTM model. This is for Jaipur market, Bangalore, and Mumbai markets. We have find the deep LSTM architecture for these 3 markets. After that, we have also utilized deep CNN model architecture. Here, the main hyperparameters are the input layer size, the convolutional layer, number of filters, padding, and stride. So here we have seen that for Jaipur market we have selected two convolution layer, and for Bangalore we have seen 1 convolution layer, and for Mumbai market we have selected 2 convolution also. So you will find optimum model, there is deep CNN model for the 3 markets. Then we have combined the 2 architecture, means CNN model, bidirectional LSTM model. As bidirectional, so we have combined these 2 architecture and find the optimum model in these 3 markets.
Yes, Kanchan Sinhaji, 6 minutes have gone. 6 minutes, almost 6.5 minutes have gone. So I request kindly conclude at the earliest.
Okay, sir. This is the out of signal focus. Okay, sir. Just a second, sir. I'll complete this within a second. So this is the out of signal focus performance comparison. You can see that deep CNN model followed by it's a hybrid architecture from better as compared to the other deep learning architecture, as well as the machine and statistical time series model. So this is the plot of the learning curves of CNN model. You can see that there is no overfitting of this in this case. And this is the focus comparison of different models in case of bar diagram. And here the salient judgment. So we have utilized different architectures of deep learning models as well as statistical and machine learning models. And we can see that deep learning model perform better as compared to the statistical as well as machine learning model. CNN model followed by CNN is a hybrid architecture perform better as compared to the machine and deep learning models. There's some differences. Thank you.
Yeah, thank you. Any questions from the audience? Any questions, audience? Fine. If there are no questions, can I ask one question, Kanchan Sinhaji?
Yes, sir. Yes, sir.
Yeah, you have taken data from 2002 to 2021. Am I right?
For some cases, sir, data from just a second, sir. Yes, sir. As per the availability, sir, for some cases, for Jaipur market, it is from 2005. For Bangalore, it is from 2002. And for Mumbai, it is from 2002.
Assume, for instance, we assume the data you have taken from 2005 onwards, right? So
yes,
I feel that these onion prices or any prices for that matter, much hike from 2005 and comparing 2021. Don't you think these 2021 or 2019, 18 become irrelevant? 2005 data, 6 data.
As because, sir, for deep learning model, we need much huge amount of data.
Fine. No, I understand. No, Kanchanji, I understand deep learning, machine learning, and statisticals. Nothing wrong with your methodology, model, and everything is fine. I just have one question, which I thought I can seek answer from you. We've taken in few instances the data from 2002 and in one instant data from 2005. So point is from 2005 and 2017, 19, 20, these 4 or 5 years high inflation and Corona season, don't you think the data of 2005 absolutely not that relevant for these? Anyhow, fine. Any political, yeah, that's fine. Any Kanchanji, the onion prices, meaning politics will come into picture.
Yes, sir.
In some cases, you know, some parties have lost their elections because of onion. Fine, Andy. If there are no any audience, any questions, feel free. Fine. I congratulate Kanchanji. Wonderful presentation.
Thank you, sir.
Right. Yeah, next, one second. Next.
Okay, sir, I will stop sharing my slides, sir.
Yeah, please. Next person is yes, Govind Rao, statistical modeling on area, production and productivity. Govind Rao, are you there? Are any of the who are the one second? Let me check who are other team members. G. Mohan Naidu, G. Ramesh, B. Rajendra Prasad. Statistical modeling on area, production, and productivity of wheat in India.
No one is present.
None of the team members are present. Okay, fine. Then we'll move on to the one. What I can do is I can put Kanchanji as present, yes, and is not present, no, and Preeti Padma Sahu is present.
Yes, sir.
Yeah, your topic is posterior study cross state domestic model. Are you ready, madam?
Yes, sir.
You can start.
Yes, sir.
Right. You can share your screen. I think that option is available. You can please share your screen.
Sir, is my slide is visible?
No, madam, not yet.
Is light visible now?
Not yet, madam. It's not visible. So video technologies had to be given option for everyone. Multiple presenters option is given.
Yes, sir.
Okay, thank you. Madam, you can try again. Option is given.
Sir?
You can try again. You can start sharing the screen.
Sir, is my slide visible?
No, madam, not yet. Yeah, now, yeah. Photography, yeah, yes, madam. Now it is visible.
Yes, sir. Thank you, sir. Good afternoon, everyone. Respected sir, madam. I am Preeti Padma Sahu, research scholar from School of Statistics, Gangadhar Mehr University, Sambalpur, Odisha. My topic is a posterior study on gross domestic product of Odisha, a statistical analysis. This is my introduction part. First, I have to identify the term gross domestic product. Gross domestic product is or GDP is the most powerful means of measuring the economic life of a state and reflects the total state of production, and as a result contains all procurement of goods and services produced by the state and services used by individuals, firms, immigrants, and regulatory bodies. It is used as a reference by almost all government and economic decision makers in policy planning and formulation. When government officials plan for the future, they look at the contribution of various sectors of the economy to GDP. So in this paper, I have taken the gross state domestic product of Odisha. So the Odisha state economy is characterized by a diverse mix of economic activities related to the agriculture, industry, service, mining and quarrying, construction, manufacturing, transport by other means, communication, trade, hotels and restaurant, banking and insurance, fishery, electricity, transport by other means, real estate, railway, ownership of dwelling, business and legal services, water construction. These are the 17 sectors which contribute to the state domestic product of Odisha. These are the objectives of my study. First objective is to study the sector-wise contribution to the GDP of Odisha. Then to identify the vital few sector VFS and tribal many sector TMS from various sectors contributing to Odisha's GDP at current prices and constant prices using Juran's 80-20 rule. And to study the level of inequality in the Odisha region regarding VFS and to suggest policy outcomes. Then the last objective is to study the level of inequality in the Odisha region in relation to TMS sector and promote policy outcomes. Then these are some literature review of this paper. Then the data and methodology.
The data is based on the sector-wise contribution of the 17 sectors which contribute to the total GDP of Odisha. The relevant data is collected from various sources like Reserve Bank of India, the Handbook of Statistics on Indian Economy 2017 to 18, Central Statistics Office, and the Director of Economics and Statistics, Government of Odisha. Here the methodology used are Pareto curve analysis and the Gini coefficient ratio, and the descriptive statistics also computed. So first, Pareto analysis of Durant's 80-20 rule. This study of decision making is based on the total selection of very few sectors, namely VFS, which have significant effect of 80% to the total GDP of Odisha, and the remaining sector, that is trivially many sector or TMS, which have 20% contribution to GDP, can be automatically benefited by increasing the GDP level. The Pareto curve distinguishes a very few important sectors that contribute to 80% of GDP and are labeled as VFS from non-essential elements that contribute to 20% of total GDP labeled as TMS. Then Gini coefficient. Gini coefficient is used to measure the concentration level. It measures the inequality in the Odisha region regarding VFS and TMS to suggest policy outcome. This is the formula for Gini coefficient. Mod of xi plus 1 into yi minus xi into yi plus 1, where xi and y are the cumulative proportion. And the methodology is used through the SPSS software. This is the table, descriptive statistics of the state domestic product of Odisha. Here I have taken all the 17 sectors which contribute to the state domestic product of Odisha. Then this is the Pareto curve of Durant's 80-20 rule. Here the curve shows that the vital few sector VFS and trivial many sector TMS. Here agriculture, construction, other services, trade and hotel, restaurant, manufacturing, mining and quarrying, real estate of dwelling. These 7 sectors are under the VFS sector or vital few sector, and the trivial many sectors are transport, public administration, banking and insurance, forestry and lodging, electricity, gas and water supply, manufacturing, fishing, railways, communication and storage. So the Pareto curve is Pareto curve divides the whole 17 sector into 2 major sector, that is VFS and TMS sector. Then I have calculated the Gini coefficient among the vital few sectors. This table shows the Gini coefficient of vital few sectors, and that is agriculture, construction, other services, trade, hotel and restaurant, manufacturing, mining and quarrying, and real estate of ownership dwelling. Then here the Gini coefficient is the highest inequality is seen between the sector trade, hotel and restaurant and construction, and the agriculture sector and mining and quarrying sector has shown highest Gini coefficient 0.26, indicating highest degree of inequality between the 2 sectors with regards to their contribution to the state GDP. Whereas the Gini coefficient between trade, hotel and restaurant sector and the construction is 0.037, which is lowest among all VFS sectors. This indicates the lowest degree of inequality between these 2 sectors. Then this is the graph of the Gini coefficient among the
Yes,
VFS.
Madam Preeti Padma Sahu, kindly keep in mind that 6 minutes are over. You may have to stop. Just conclude very quickly.
Yes, sir. So this is the graph of the Gini coefficient among the VFS sector. Then this table shows the Gini coefficient of trivial many sector. The trivial many sector consists of 10 sectors, and this is the Gini coefficient of trivial many sector. Here is the graph of coefficient Gini coefficient among the TMS sector. Then conclusion and policy implication. So Here, the state government has implementing various anti-poverty programs, including NRLM, that is National Rural Livelihood Mission, Manrega, and other programs for generation of wage employment. And the state government has been striving to improve the road connectivity in the state. Road construction improvement works are taken up on a massive scale through different programs. We know that Odisha is rich in minerals and their exploitation level has been increasing over the years with vast mineral resources and abundant raw materials.
Yes, madam, you have to stop now, kindly.
Yes, sir.
Now, yeah, thank you. Any questions from the audience, sir? Any questions from the audience?
No, sir.
Preeti Padma Sahu, are you a research scholar in the university?
Yes, sir.
Wonderful. What is the objective of the study?
Yes, sir.
Objective of the study. Yeah.
Is to study the sector-wise contribution of GDP of Odisha and to identify the vital few sector and trivial many sectors from various sectors contributing to GDP of Odisha at current prices.
No, that is already available. What is specially you worked in your paper?
I have worked the total contribution to GDP of Odisha using Pareto curve analysis and the Gini coefficient ratio.
What is this 80-20 final conclusion with respect to Pareto 80-20? 80-20 you mean by 80% of the wealth is with the 20% of the people. That's what is the basic understanding. So what are your conclusions in direction of this?
Sir, the sector which contribute 80% to the total GDP of Odisha, the sectors should be emphasized to develop so that the other sector which contribute 20%, they are automatically upgraded. So the different measures should be emphasized to develop the BFS sector, that is vital few sector, which contribute 80%, significant contribution. They have significant contribution to the total GDP of Odisha.
Okay, fine. So I congratulate for your good presentation. Congratulations, madam.
Yes, sir. Thank you,
Good
sir.
job. Wish you all the best.
Thank you.
Yeah. Next speaker, next paper is Prakash Kumar. Develop rank-based composite index for assessing high-yield stable crop varieties.
Yes.
Are you ready, sir?
Okay, I am ready, sir.
Right. You can start.
Good afternoon, sir. I am going to share my slide.
Yeah, please.
Audible, sir?
Yeah, you're audible.
Okay, sir. My slide is visual.
Yes, slide is visible to you.
So let's
Yes,
start.
Kanchan Sinha is your colleague, by the way.
Yes, sir. Yes, sir.
Okay, wonderful. Right. Please proceed.
Okay, sir. I am Prakash Kumar from ICSDS New Delhi, and I am going to present my presentation in this conference. So first of all of you, good afternoon, all delegates and dear sir. So this image showing the stability, how stability in different uncircumstances things like environment and soil types and various climatic conditions or changing environmental condition also. So on the basis of these circumstances, I have taken the objectives regarding this, that is developing a rank-based composite index for assessing high-yielding stable crop variety. Because stability is different thing and high-yielding stable crop variety is different things. Sometimes we're getting a stability, we not considering their yielding and the high-yielding terms. Most of the times, less yielded varieties are more stable in comparison to high-yielding varieties. So here I have tried to considering both the terms. So on the basis of starting the small land holding in India, and India is the very marginal, have a country of very marginal farmers or small land holding farmers. The rich mineralization through a stable genotype for a small and marginal farmers, large number of stability measures are available in literature. the problem is which one to use to identify stable genotypes. Main objective of this study is to identify, develop a reliable stability measure for selecting genotype stable to environment variation along with their high yield. So let us we consider the model, the Yij given by this expression. That may be also using the Vij in alpha combination of this interaction effect and E, that is the Vij. So on the basis of this, we are considering the Vij equal to these expressions. So under review of literature, 1962 given the Ricky equivalence by this expression, and Shukla also give the one variations, environmental variations of genotypes, that is given the ith genotypes. So in 1972, Shukla given by these expressions. So sometimes there is some work done by the Nasser and Holmes, and they reported that some non-parametric measure of phenotypic stability based on rank within the environment given by these expressions. Okay, and Kang also give the Kang rank sub method for getting the stable variety. So Raju 2002 also studied the AMI model, that is the additive multiplicative interaction model. And Raju and Bhatia also work on 2003 work on the comparison of various measures of stability with respect to ranking ability under varying situations. They give the Li is just given the robust and reliable method for stability, that is non-normal distribution condition. So under methodology, we are using the rank sum and rank variance of the genotypes were considered to develop the new stability method. That means we use both the terms, that is rank sum and variance also. So linear combination of stability rank realized from the RS and SI is propose a new stability measure and denote the rank-based stability in RSI. So RSI represented by this expression, and under this methodology, so farmers and grower point of view, they have required some stable along with high yielding variety. So we have required some proposed new composite indexes. So on the basis of this requirement, we have proposed the rank-based index that already we have RSI developed earlier, and again importing the rank of the mean yields. So RIPS also developed by expression this. So where you are considering two different weight points, or these weight points are considered as different on their iterative weight. So under this, using these things, we have developed the simultaneous index for a stable genotype with better yield by giving this formula, where beta represent the ratio of weights given in the stability components W2 and yield component W1 with a restriction that W1 plus W2 equal to 1. So these are some iterative value of taking beta. And under starting point of view, so we have first of all done the ANOVA. So getting the overall significance of environment, they are significantly different or equally impact on the different variety. So we'll use ANOVA. On the basis of ANOVA, so just considering these data for taking ANOVA. So in these data, all the data are collected in the Regional Agriculture Research Station, RAS PALM from Hyderabad. So under this condition, replication, 3 replication there, 15 genotype, and 20 environmental conditions have been taken. So on the basis of these data sets, we have prepared their rank-based sum, rank of each environmental condition of each genotypes, and their rank sum and their base also calculated. So on the basis of this calculation, we're getting G7 or G14 have a most stable variety. So by applying the ANOVA, first of all, know the different environment are they are significantly different or all are same. So their significance can be defined as their p-value. If p-value is at the level of 5% level of significance, so your p-value should be less than 0.05. So here p-value or p-value are significant. So on the basis of this, we have further considering these implementation of these different stability measure on the basis of the
please complete in a short time.
Transferred into rank, and on the basis of rank, Just we are taking the rank of RSI, that is indicating by this G2 is rank 1 and G6 and G7 is rank 2. So
Prakashji, we passed 6 minutes. I request you to kindly conclude.
Yes, I'm going to complete.
Yeah.
Here I am calculating also biplots. So in biplots we can see the more those varieties which are stable, that is very near to the center. So in center point we can see the 6 genotypes, 6, 12, 14. These genotypes are in comparison to more stable. So in this we can see the 6, 4, 2. These are very near to this axis. So that indicates these variety and support our development methodology. So here we are considering the evaluation purpose. So just rank experiments rank coefficient, correlation coefficient also considered. So on the basis of our measure is very near to this 0.84. So Ricky equivalence. Okay. So now I am concluding the comparison of different measure of stability based on rank provide a useful alternative to a stability measure currently used. High confidence of proposed stability measure with Ricky equivalence provide, which are mostly used. So rank-based stability measure is a non-parametric stability measure, give the reliable and robust stability measure. So these are some differences. So can I stop my slide?
Yeah. Any questions from the audience? Any questions from the audience?
I have a question.
Yes, yes, Anusha. Yes, please.
Yes.
Sir, actually, you find the method that rank-based method, right?
Yes, madam.
So what is the application of that method?
Actually, this application of that method is this is some time robust type methods. It means there is some outlier present in the data or some another thing present in the data. So just first convert into rank, and on the basis of rank we will analyze further.
So generally we are having normal data, right? So
Yes.
why you are concentrating on rank-based rank?
Yes, sir. So we can considering the both condition if your distribution is normal or non-normal condition also. So it is very much similar to the parametric distribution.
Prakashji, what Anusha's question, perhaps I think you are usually in design of experiments or ANOVA, we make ANOVA Yij to be following normal. Am I right? So why that you have gone for this rank correlation or rank methodology? That was our question.
Yes, sir. Yes, sir. Sometimes our data is not follow the normal distribution. So in those circumstances, we use the rank test.
Okay.
So we check the data.
Okay. Good. Any more questions from the audience? Right, Prakashji, congratulations. Wonderful presentation.
Thank you, sir.
The next speaker, Suru Munda. Are you present, sir? Suru. The topic was an inquiry into garbled agricultural disparity at grassroots level. If not any of the team members presenting, the paper number was 109. No, he is the only author. Suru Munda is not present, then I may have to put absent for that. Okay, let us go for next one. Preeti, yes. Prakash Kumarji, yes. Suru Munda, no. So, PM Manoharan, are you there, sir?
Sir, he is my gate. I am Presley.
Okay, Presley, 1 second. You will be presenting, you are also co-author for the paper?
Yes, sir.
Okay, applications of big data analytics in official statistics in the field of Indian agriculture.
Yes, sir.
Right, madam, we can proceed.
Can I share my screen, sir?
Yes, madam.
Is it visible, sir?
Mahesh, yes, started screening. Yeah, Presley and Manohar. Yes, madam, visible.
My name is Presley, research scholar under the guidance of Professor Dr. M. Manoharan, University of Calicut. And our topic is application of big data analytics in official statistics in the field of Indian agriculture. This is my outline: introduction, agroeconomic statistics, big data and big data analytics, role of big data analytics in agriculture statistics, analysis and interpretation, conclusion and references. Official statistics perform a crucial role in all the fields of human activity. It assists in deciding the current stance of per capita income, population growth, etc. in the economy. It retains a median position in almost all fields. Agriculture statistics is one main category of official statistics, and it is the backbone of Indian economy, employs almost half the population of the country's workforce. India is the second largest producer of fruits and vegetables in the world. Agriculture suffers from many disasters like depleting groundwater levels in rural areas, climate change, unprecedentedly monsoon, droughts, etc. And agriculture in India lacks institutional attention, support for banks in terms of loans and farmer welfare schemes. The time has come for technology to take over change. Big data analytics is here for the rescue. And it is a trending procedure that various fields to create productive data from big data. This paper reviews the applications of big data analytics in agriculture statistics. The Indian climatic conditions like weather and rainfall are specifically analyzed along with the use of fertilizer over the years in India using machine learning. Next, agriculture statistics refers to all statistics related to an agricultural economy. It is divided into 6 sections: land utilization statistics, yield statistics, animal husbandry statistics, fishery statistics, forestry, and miscellaneous agriculture statistics. The Directorate of Economics and Statistics compiles the figures and publishes these statistics in the annual report entitled Agriculture Statistics in India. Big data is a mostly buzzword used to describe a massive volume of both structured and unstructured data, which is very large and complex to process using traditional database and software techniques. The process of extracting meaningful insights from such a raw big data is estimated as big data analytics. There are 2 types of data: human-generated data and computer-generated data. Human-generated data means blogs, reviews, emails, pictures, etc. And computer-generated data, application server logs, sensor data, images, videos, etc. Big data can be defined as 42 V's. The first 7 V's are volume, velocity, variety, veracity, variability, visualization, and value. Various uses for big data in different fields: financial services, retail, manufacturing, healthcare, web, social, or mobile, government. In these fields, we use big data as detecting fraud, behavior analysis, cross-selling, design to value, crowdsourcing, optimal treatment pathways, location-based marketing, segment populations, etc. The applications of big data analytics in agriculture sector: an acute agriculture observing network, digital soil and crop mapping, automated agriculture, weather prediction, yield prediction, disease detection and pest management, fertilizers recommendation, automated irrigation system. Here, we consider the Indian weather and rainfall data 1901 to 2017 and fertilizer data 2002 to 2017. Already we have seen that weather prediction and automated irrigation system and fertilizers recommendations are some applications of big data analytics in agriculture statistics. This analysis provides insights into Indian climatic conditions and fertilizers using machine learning algorithm. After analyzing weather and rainfall data, we got the insights are shown in these figures. First figure shows the yearly average temperature. We can see the issue of global warming is real. The yearly mean temperature was not increasing till 1918. Since 1979, we have seen a gradual increase in the mean temperature yearly. After 2015, the mean temperature has increased drastically. Second figure shows the monthly temperature. We can see a clear positive trend lines in month-wise temperature. Next figure, seasonal mean temperature. We can see a positive trend between temperature and time in season-wise temperature. Also, the trend lines does not have a high positive correlation. It is still significant. This figure represents warmest or coldest monthly temperature. January has the coldest days in a year and May has the hottest days in a year. Also, July and September are the months with the least standard deviation. Therefore, we can expect any day in July or September to be warm. This figure represents the annual mean rainfall by regions. Arunachal Pradesh and coastal Karnataka are the most rainfall region. West Rajasthan is the lowest rainfall region. This figure represents minimum or maximum median monthly rainfall. Looking month by month, January has the lowest rainfall and July has the highest. Rainfall varies the least in March since it has the lowest standard deviation. Next represents the fertilizers data. This figure represents the amount of fertilizer. We can see from the figure that urea holds the most position in India since urea is the most imported fertilizer in India. And the import and export amount of fertilizer, we can see the importing fertilizer rather than exporting. Agriculture accounts for almost 70% of the use of fertilizers. I conclude, in this paper, we discuss one of the most vital topics in official statistics, which is big data analytics in agriculture statistics. Our research provides an overview of big data analytics and its applications in agriculture statistics. Also, we examine the climatic conditions and amount of fertilizers in India using machine learning. This analysis will help understand the suitable period for agriculture and identify the most common fertilizers. Consequently, big data analytics is the best way to analyze big data in the era of big data so that farmers or workers can do agriculture more efficiently. It will help them. Automatically, our GDP growth will increase. So, we conclude that the adoption of big data analytics can make a more efficient statistical system. These are my references. Thank you.
Yeah. Any questions from the audience?
Sir, I have a question. I am Dr. Kostavaditya from ISRI, New Delhi.
Please.
Firstly, thanks for your nice presentation. But the thing is that you haven't connected big data with agricultural statistics in any part of your slide. Whatever analysis you did, you can do that with the simple descriptive analysis from the time series data. You can find out those pie diagrams and the bar diagrams.
Yes, sir. Yes, sir.
Okay, there is no big data in your entire presentation.
No, sir. This is not a big data. I just.
But you have chosen a topic for big data of agricultural statistics, but you haven't put any light on the 6 parts of agricultural statistics like area enumeration, yield estimation, milk yield, egg or meat estimation. Nothing. You told you haven't highlighted anything about those things. Official statistics. You just given something in the introduction and then you went away from that thing, entire topic, and you presented something else.
Yes,
so
sir.
Where is big data here?
Sir, actually, official statistics is different types in agriculture, industrial, labor, trade, transport.
We all know that thing. That is there, big data. We are studying big data, working with big data. But where is the big data in your entire presentation? You have presented the big data in agricultural statistics. Where it is there?
No, sir. I analyzed only not a big data. It's data from Kaggle. But I analyzed the big data too.
You have analyzed the structure small data. It's not a big data. It's a regular data.
Yes, sir.
So, but you have to put the topic like a big data. I thought I'm going to get some idea about how to find out official statistics using big data. Then non-structured random matter that is being generated through softwares.
Yes, sir. Actually, in the regular data I used for the pie diagram and other graphs I used to machine learning tools. That's why I asking it is.
Firstly, we don't need any machine learning techniques to generate pie diagrams. Can be generated easily.
Yes, sir.
We don't need machine learning techniques to generate pie diagrams or bar diagrams. These can be generated very easily.
No, sir,
as you were learning this time, maybe you are a research scholar, but try to make presentation whenever you are, whatever the topic you are presenting. during the presentation.
Yeah, Prishniji, just to add what Sir mentioned, your topic heading is, paper heading is applications of big data analytics in official statistics in the field of Indian agriculture. Okay,
Yes,
kindly take it positively. What Dr. Kaustav Aditya has mentioned, kindly take it positively. We could have analyzed this data using Excel. Am I right?
Yes, sir. Yes, sir.
So big data, you mentioned 42 V's and 7 V's are predominant. Point is, the data itself is not that big, nor any of the advanced techniques, at least deep learning has not been used. That is the question, context of Kaustav Aditya Sir's comment. I suggest you kindly take it positively, and I think maybe title has become slightly inappropriate.
Okay, sir. Okay.
Anyway, good presentation.
Sir, I have one question, sir.
Yeah, one more question. Yeah, please.
Okay.
Madam, in one slide you have mentioned that you have utilized machine learning algorithm, but which machine learning algorithm you have utilized for your analysis purpose?
This is Kanchan Sinha is asking, madam. Yeah.
Yes.
Hello.
Yes. Yes.
Actually, I use the analysis in Python.
Yes, it's
I
okay.
use pandas, matplotlib, etc.
These are library, but it's okay. But I'm asking which machine learning algorithm you have used for your analysis.
Sorry, sir.
No, Python pandas and all. Python just a software. It's as good as Excel. It can handle bigger data. Maybe multiple tools, techniques can handle.
Yes.
But
Yes.
somewhere Kanchan Sinha's Sir's question is, somewhere you mentioned that we have used machine algorithm. Did you use anywhere? Kindly express. That is what Sir is asking.
Yes.
Sorry, sir. I didn't get.
That's fine. This suggestion also, I suggest kindly take it very positively.
Okay,
And maybe advanced techniques can be used. And you are working in the agricultural area. Am I right?
No, sir. Official statistics. Some contributions to official statistics.
Official statistics. Okay,
yeah.
fine. Well then, we wish you all the best.
Thank you,
all
sir.
the best. All the best.
Thank you.
Next speaker is Rajiv Ranjan Kumar. Sir, are you there?
Yes, sir. Yes, sir. I am present.
Extreme learning machine-based hybrid model agricultural price volatility forecasting in the presence of structural breaks. Yes, sir.
Yes, sir. My screen is visible, sir.
Yes.
Okay. A very good afternoon, all of you. And my topic is extreme learning machine-based hybrid model for agriculture price volatility forecasting in the presence of a structural breaks.
Ranjanji, 1 second. Is Prakashji and Kanchan are all colleagues, sir?
Yes, sir. Yes, sir. We are colleagues.
Okay, right. Proceed.
Yeah. Yeah. In time series analysis, factors such as major changes as in technology like introduction of genetically modified crop as well as implementation of new economic policy causes a structural break in the parameter of the forecasting models. We can define a structural break as the permanent change in the parameter vector of the model, and a structural break is being observed in many economic and agricultural time series data. According to Clement and Handy 1998 and 1999, such a structural break poses a formidable challenge to economic forecasting, and it is main source of forecast failure. And a structural break may be single or multiple. For the detection of single structural break, generally we use at most one change point algorithm, and for the detection of multiple change point, generally we use the ICSDS algorithm. And Click et al. 2012 proposed the PELT algorithm for the detection of a structural break. In many economic and financial times, market quantities and prices are regularly varying, which means the quantities and prices are volatile. Volatility is a term that has been extensively used in time series application. It refers to the conditional standard deviation of the underlying asset return. Furthermore, modeling the volatility of the time series can improve the efficiency of parameter estimation and accuracy of the forecast. In time series, the most popular model used to describe conditional variance is autoregressive conditional heteroscedastic model, and its generalized form is the Garch model proposed by Woloslav 1986. The superiority of this model has been found in agricultural data series as well. In the recent years, the modeling of volatile series is mainly done using the different variant of Garch model. And the one of the most important thing is the identification of change point in the variance of the series, and incorporating it accordingly was started by Lamrance and Lestrop 1990. This incorporation gives a better forecast efficiency of the model as well as proper reasoning of the abrupt changes in the series. Therefore, it is desirable to have a model that treat the Garch parameter as a function of time and allow the regime for changes. Accordingly, Che 1994, Hamilton and Sussman 1994 introduced the Markov switching Garch model. So the motivation of my study is the high level of the volatility persistence may be spurious if there is a structural break in the volatility process. This biased persistence of volatility indicates that current information will still impose a significant impact on the conditional variance forecast for all horizons. And the standard Garch model failed to account such biased persistence of volatility. Therefore, to obtain more robust estimate of volatility, it would require a more general class of Gauss type model that allowed for a structural break as a part of data generating process. Accordingly, we proposed a Markov switching Gauss and extreme learning machine based hybrid model for the agriculture price volatility forecasting in the presence of a structural break. We also proposed R package for the proposed model, and we compared the proposed performance of proposed model with the existing models. And to evaluate the performance of proposed model, we used 3 price series. The first one is weekly potato price series of the Delhi market, international monthly groundnut oil price, and third one is the international monthly palm oil price series. This is the plot of the potato price of the Delhi market, and this is the plot of the monthly groundnut oil and palm oil, international monthly groundnut oil and palm oil prices from 1980 to 2019. And this is the descriptive statistics of all 3 series, and all 3 series are leptocharetic as well as the non-normal distributed. This is to test the stationarity of the series, we used augmented Dickey-Fuller test and Philippe-Perron test, and the both tests shows the original series is non-stationary, and when we take the first difference, then the series become the stationary. So we can say here the order of integration of the series is 1. To test the linearity of the series, we use the VDS test, and the test result shows that all the 3 series are non-linear in nature. To test the structural break of the series, we use Pelt algorithm, and we found that at least one change point are present in all the 3 series. And this is the parameter estimate of the ARIMA model of the return series. And to check the residuals, we used L-Jung box text. And this is the plot of the essay plot of the squad residuals, and it shows that at some lag it is significant. So we go for this one is the plot of the PSCF plot of the squad residuals of the and to test the arch effect of in the residuals, we used the Angular language multiplier test, and it shows that at different order up to order 24, it shows that in all the 3 series the arch effect is present. So we go further for the modeling for the Garch model, and this is the parameter estimate of the Garch model. So after that, we fit the Markov switching Garch model, and as we tell earlier, Markov switching Garch models were introduced by Hamilton and Sismal and Chen 1994. So this one is the equation for the Garch type model. So for the fitting of the Markov switching Garch model, we used two-state Markov switching Garch model. We tried all possible combination of the three variance model specification, namely S-Garch, E-Garch, and GJR-Garch, and three distribution
Rajesh, you have to conclude.
Okay, sir. Okay, sir.
Yeah, please. Another one.
So this one is the best variance model and distribution specification of the Markov switching Garch model. So we also fit the artificial neural network model for the comparison purpose. This one is the different neuronal structure, and we used for the hybridization. We used the extreme learning machine, and it have more generalization capacity compared to the artificial neural network. So we construct the 14 ELM model with various number of hidden nodes varying from 2 to 15, and each ELM model trained repeated 50 times. So this one is the neuronal arrangement of the ELM and the artificial neural network model. So the this table shows the in simple forecasting performance of the Garch artificial neural network, extreme learning machine, Markov switching Garch, and the hybrid model. And the result shows that the hybrid model, the performance of the hybrid model is as per or better compared to the all models. And this table shows the out of sample forecasting performance of the proposed hybrid model. So when we go to the conclusion, the study provided an evidence for the superiority of the hybrid model in the forecasting of agricultural price in the presence of structural breaks. For the agriculture price volatility forecasting, the proposed hybrid model, Markov switching Garch ELM model, outperform their counterpart in all cases since it has consistently lower RMSE and KLU value and the highest CDS value. It has been observed that performance of the Markov switching Garch model is better compared to the Garch model. It may be due to the Markov switching Garch model capture the regime shift in the data. So this one is my references. Thank you.
Yeah. Any questions from the audience? Any questions? Fine then. Rajiv Ranjan, you mentioned that you developed a module in R.
Yes, sir. Yes, sir.
Okay. So did you upload in CRAN?
Yes, sir. Yes, sir. This one is published in CRAN also, sir.
Okay, fine. Well, congratulations. Very good presentation.
Okay, thank you, sir.
Let's move on to next presenter. Himadri Shekhar, are you there?
Yes, sir. Yes, sir. I'm here.
A novel statistical approach for identification of EQTLs in plants and animals.
Yes, sir.
Yeah, you can start.
Okay, I'm sharing my slide.
Yeah, we are able to see your PPT.
Okay, sir. My slides are visible?
Yes, visible.
Yeah, yeah. The title of the topic is the novel statistical approach for identification of EQTL in plants and animals. So I am Dr. Himadri Shekhar from ICSDS, New Delhi. So this is the introduction. The main part of the EQTL study is that in EQTL study, we generally main focus is the quantitative trait. The quantitative trait is the phenotype. The phenotype may be body size or body weight for animal species or crop yield, different variety of phenotypic trait in case of crop species. Your disease susceptibility may be a phenotype. So in primarily, whenever we do not have any marker information or anything in the previous study, then we have used the QTL. But whenever our different type of transcriptome data is available, mRNA expression data come in the study, then we are going for the EQTL. So main identification equal is identification of genomic location, which is the expression which is influence the expression of the targeted trait. So the main difference between the QTL and EQTL is that in QTL study, traditional QTL study, we have mainly focused on the 1 or 2 traits. But in EQTL study, thousands of expressions can be analyzed and thousands of EQTL can be detected. So generally, if any genotype of a particular locus is correlated or associated with the gene expression of a certain trait, the region may be potentially containing specific regulator. This regulator may be your microRNA, this regulated DNA motif, or any other functional nucleotide sequences which have influenced our phenotypic trait or your transcript expression data set. So in order to detect a region, one is to identify the genotypically diverse individual. That means we need the marker data set, and from the marker data set, from the same sample, we need the expression data set. So this may be your micro expression, mRNA expression, and there are maybe different deep sequences technology which generated data set. So this identified location of EQTL has divided into different insight on the biology. This is very much important for biological study for identifying the different complex trait. So this genetic variation controlling the transcript level is assumed to be 2 types. After identifying the expression quantity trait loci, that is identifying the targeted location, this location may be 2 types. One is your cis-QTL and another is trans-QTL. The definition of cis-QTL means that when observed location, that is identified location of the target study, coincide with the location of the gene, this is called the cis-QTL. In case of trans-QTL, the location of the targeted trait and the location of the observed location is far apart. That means they are not in coinciding. So what is the another maybe this is the diagramic expression. The diagram A means that the mRNA abundant EQTL and the map position of EQTL is coincide. That means this identification of cis-EQTL. In the figure B, it identifies that the map position of the your gene and the mRNA abundant EQTL is there are different chromosomes. That means two H, the 2 homologous chromosomes, this is 6 homologous chromosomes. That is far distance apart. This may be a trans-EQTL. But in the figure C, there is identification of both cis and trans-EQTL is present. So this may be your cis-EQTL, and both this and this may be a trans-EQTL. So now, after identifying the trans-EQTL, our main focus is to go for the hotspot. So what generally means the hotspot? Hotspot is that when there are different number of trans-EQTL present in your data set, or in our data set, in our study data set, then if the trans-EQTL largely associated with our targeted trait, that is targeted mRNA expression, targeted phenotype, this is the then it is called hotspot. So there may be different number of hotspots present in the data set or may not present. Okay. Now in the material methods, what study we have used is that we have used a modified t-test, and after modified t-test, we have identified the expression data set and expression and differential expression data set. Then we have studied the mixture model. Then after mixture model, we have calculated the FDR. So now this is the just GI is the number of SNP, TJ is the number of transcript. So if the significant GI is associated with the TJ are called as the identified as the EQTL. The significant association can be discovered by the different statistics based on the n number of samples. Suppose you have the n number of samples. Generally, we have used a different type of model used in the study. One is dominant, recessive, and additive. So a transcript TJ associated with the marker GI is if the mean expression of the transcript TJ of the particular genotypic group different from the genotypic group corresponding to that marker. So this is the null hypothesis of the study. Then after the null hypothesis, this is the modified t-test. This is the x1 is the mean of the one marker and x is the mean of the another marker. Sij is the standard deviation, and A0i, this is the added to the minimize the difference between the coefficient of variation of the data is within the classes. This is developed by the Efron et al. 2001. So the main difference between the normal t-test and the this modified t-test is that we are added the A0ij. This for the particular study, this is the algorithmic approach. This is the original data set. Then original data set, this is the marker data, and this is your transcriptome data or your expression data set. After this, using the expression data set, we have actually generally reduced the dimension. Actually, generally there are 2 data sets. From the 2 data set, we have identified the 1 data set. If A0 is a 0, that means one sample t-test, this may be 50%, 90% percentile, these are data set used. But the study finds that A0 is when is 90 percentile, this is the most share the most information and this is the most precise. That is why for A0 we have used a 90 percentile data set. Though in the after identifying the equivalently expressed gene and differentially expressed gene, we have used this mixed distribution. This mixed distribution are after becoming the two component mixture model. In the one component mixture model, there is n1 number of sample, and there is in second component the n2 number of sample. This is the total number of sample is becoming n1 plus n2 is equal to n. So now this study, we have identified the local false discovery rate. This is given by this equation. This after local false discovery, this can be given by this false discovery rate. This is the equation of false discovery rate. Now, how to identify the truncation between the two mixture models. This is the Z0. This is the mu hat plus B into sigma hat. The B is given by this following equation, and mu hat is the median of Zij, and sigma is this. After using this truncation point, this two component mixture model given by this like this. Then from here we have to.
Himadriji, you have to conclude in a minute.
Yeah, sure.
Yeah.
After this, we need to identify this false discovery rate. This is the one model. Here I have used another model. This is the integration mixture model. This is the equation given by this following equation. J is the number of particular gene, and this is the central particular. This is the given by and this is the parameter setup. This parameter setup, here you have identified the Bernoulli distribution, and is given by omega zz. So after main target of the study is to identify this association. So this is the posterior distribution. After we have to identify that how equatorial significance impact on the your targeted rate. So if the PPA value is greater than 8.0, it means the equatorial. So this is the data set. This is the Bernoulli data set. After here 4286 number SNP, this number expression. This is the number of gene, number of SNP. This is the FDR value. So this is the three equatorial identified. From another data set, this is the mouse data set. From the mouse data set, identify the FDR value and local FDR value. So this is the number of CCQTL presented in there. Now from this study, we have also identified the hotspot. There are 1, 2, 3, 4 number of hotspots we have detected from the study. This is the marker chromosome 6, marker chromosome 16, marker chromosome 12, and marker chromosome 8. And this is the number of gene, number of SNP. This is the posterior probability association, gene chromosome, all the information available for the detection of hotspot. So there are 4 type of model we have used. This is the modified t-test, the IBM equatorial, matrix equatorial, and random forest. From all the method, our method discovered that there are common equatorial 2, and for the dataset 1, for the dataset 2, it is identified that 4 to 60 number of equatorial. This all the model developed, and our model is we are performing better for sharing the equatorial. So this is the reference. Thank you.
Yeah, any questions from the audience? Fine then. Excellent presentation. Congratulations. We invite the next speaker. Next speaker is Kaustubh Aditya. Food and nutrition in endogenetic plain region, a disaggregate level model. Sir, are you ready?
Yeah, sir. I'm just sharing my slide. So is it visible? Slide?
Yes, yes, visible.
Okay.
Yes.
Okay, so let's start the presentation. It's food and nutrition in. Hello. It's food and nutrition in endogenetic plain region in disaggregate level analysis. And I am Kaustubh Aditya, working as a scientist in the division of the sample service in ICR, Indian Agricultural Research, Statistics Research Institute, actually. So the base of this study is to know what condition our countries and food security conditions, and also this paper is basically based on the SDG parameters, SDG 2.0. So the thing is that we want to know how other peoples of these nations are secured from food security. Means, that is a major concern for this nation after independence. So from the beginning, that India is presently, as you know, is the fastest developing economies in the world, like South Africa and other countries like there. The country has progressed significantly in reforming its economy, lessening its neediness to enhancing expectations from everyday comforts, and its extensive population has been maintained. Now, India is the second largest area. India has the second largest area of arable land in the world and is a major producer of various agricultural products. It is the Indo-Gangetic Plain, which is the region which consists around 630 million acre of fertile region, including northern areas of the Indian subcontinent and the majority of the northeastern parts of India. Now, Indo-Gangetic Plain region includes states like West Bengal, Bihar, Uttar Pradesh, Punjab, and Haryana. We know all these states are heavily contributing towards our economy by producing a lot amount of agricultural commodities. Due to its vast agricultural importance, Indo-Gangetic Plain is generally termed as the granary of India, and therefore Indo-Gangetic Plain region is agriculturally and economically extremely important in the country. Now, despite the productivity enhancements in Indian agricultural sector over recent decades, there exists a wide variation in the estimates of the undernourished population among the different sources. Like in India in 2019, we got ranked 103 among the 119 nations in the Global Hunger Index, which is a very poor performance from that point of view, as we are producing and we are progressing much faster than other countries, being a developed country. Now, guaranteeing nourishment for food is security has stayed the base needs for advancements and motivation in India since freedom. Patanayak, then Meenakshi, Dayton, and Vasu et al. A few studies which demonstrated that no noteworthy advancements could be accomplished in diminishing the occurrence of hunger and undernourishment in the nation. In India, consumption of calories, protein, fat hold the former basis of characterizing poverty and food insecurity. This become the main inspiration of our analysis. The nutrition intakes across the states of India as coming under the Indo-Gangetic Plain region can help to simulate the discussion about the drivers of hunger in these states. In this analysis, we have used the household consumer expenditure survey data collected from the NSSO 68 round in the year 2011 and 12 household HCS survey. Now, people may think why I am using 2011-12 data, but if you see online, you can find this is the most recent data that is available online in the Government of India CSO website. So this is the most updated data. We are expecting another update since 2021, but still not there, maybe due to Corona situation. This survey includes a total of 7,469 villages, out of which 59,695 rural samples households are in the schedule type 1 and 59,683 rural households in schedule type 2. Both the schedules take data first on the schedule type 1, they used to collect data based on the what variables, what are the thing, what is the living status of the human being, and schedule type 2 generally consumes or accumulates data based on what are the food, what type of foods people are consuming. So in our study region, we used around 6,000 rural households in Uttar Pradesh, 3,310 from Bihar, 3,566 from West Bengal, and 1,552 from Punjab, and 1,423 from Haryana. Now, this survey provides information on quantity and value of more than 142 food items with reference period of 30 days and 7 days for few food items in the state and union territories in the rural and urban region. We use the schedule type 2 here because we are mostly using the data based on what are the food consumption behavior of the human beings over there. Now, we have divided the entire region based on various occupational type, like self-employed in agriculture, self-employed in non-agriculture, regular wage salary, casual labor in agriculture, casual labor in non-agriculture, and others are there. There are land category-wise, marginal, small, and others are there. Also, there are social groups like scheduled tribe, scheduled caste, and other backward class, and others. Those are there like generals and other extinct class. So, to estimate the nutrient intakes suggested by the food items has been transformed into calorie, fat, and protein, mostly 2000, according to Ministry of Health and Family Welfare, Government of India. Average dietary energy intake per persons per day in rural India is 2,400 kilocalorie. Our major purpose is to compute the average calorie, protein, fat intake among the rural households of Indo-Gangetic Plain region. Now, here is the methodology. We use the methodology of proportion estimation. where the proportion is given by PW, WIYI, and this estimator of variance is approximated by these using the expression from the model estate survey sampling book by Sananda et al. 1992. And we are also giving utilize and provide the CV values for both the estimates. Now these are the tables we are having. Table 1 for average value of calorie, protein, and fat intake per person per day for rural areas in Indo-Gangetic plain regions. We can see from the diagram that most of the states like Uttar Pradesh, Bihar, and West Bengal, they are lying in the same situation, whereas the states like Punjab and Haryana, they are much, means you can say much beyond the reach of the average fixed size number of kilocalories that people should consume. So you can see that Punjab and Haryana people are in better state than those in West Bengal, Bihar, and Uttar Pradesh. So it's a good thing to see that some, at least in some states, people are living in a better condition. From the table 2, we can see that this categorization is basically mostly based on the labor types. Okay, just I'm concluding 3 more slides. And this is based on the categorization of the laborers. This is the result for the state of Bihar. This is the result for the state of Uttar Pradesh. And this is the result for the state of Punjab, where we get the best result. So this is the result also for Haryana, where the conditions is also better. Now we are discussing the result that we see that the laborers who are self-employed in agriculture has the highest average calorie intake in Indo-Gangetic plain regions, and the laborers that is casual labor and non-agricultural labor, which are who are not included or not working in the agricultural sectors, are having the worst calorie intake in all the states. Also, the proportion of food insecurity in Indo-Gangetic plain states, it is 0.50, which is the least in Punjab, and 0.70 in West Bengal. The variation is also less in Punjab than in West Bengal. And also, for our conclusion that we can see the analysis from that, we get some idea about the condition, about the food insecurity, and what is the condition of poverty, and also calorie intake in our states. Also the states where mostly the agriculture production is happening, mostly the Indo-Gangetic plain regions, the largest proportion of the country's population we can find as malnourished and anemic. And whatever the conclusion they made at the Global Hunger Index seems to be fair for our country, for this region. So this is the entire conclusion, and these are a few of the references that we've gone through for this study, and thank you.
Yeah. Any questions from the audience? Okay. Kaustavji, what is disaggregation here?
Ma'am, sir, the thing is that we generally thought the disaggregation as the bifurcations, means bifurcation in various groups. Like the groups belonging to that social, social caste, scheduled tribes are there. There is a different type of groups, like different type of employer groups are there. Different type of worker groups are there. These are groups we are considering as the disaggregation over there, because generally whatever estimates we produce about these criteria is generally based on at the level of the district level or something around that level. They doesn't go beyond that part. So we are terming this as disaggregation.
Right. Any, apart from data analysis, any modeling has been done here in this paper?
No, sir. This paper is entirely based on sample surveys and survey results only. We did the estimates only.
Excellent presentation. Congratulations.
Thank
Next
you.
presenter, Preeti. Madam, are you there? Preeti Badgi.
Yes, sir. Yes, sir.
Topic is Bayesian interval estimation for the parameters of Poisson type Rayleigh class model. You can start your presentation, mate.
Yes, sir.
Yep.
Sir, my screen is visible.
Yes, ma'am.
Good evening, everyone. Myself, Preeti Badge. Today I am presenting a research paper entitled as Bayesian interval estimation for the parameters of Poisson type relay class model. My co-authors are Rajesh Singh and Dr. Preeti Singh. Introduction. Software reliability is the quality characteristic of operation system which can measure, predict, and estimate quality of software system. Software reliability means the probability that software will not fail within a specified period under specified condition.
Madam, slides are not moving. Slides are not moving.
In 2012 presented presented Bayes estimator for the parameters of relay.
Yeah, actually, madam, your slides are not moving.
On the basis of
Presentation is not moving now.
Preeti, madam, your slides are not moving. Ideally, if you can slide move, the audience can understand better.
Okay, sir. Okay.
Right, madam.
The presentation and again now start presenting.
Is it more?
No, not yet.
Close the presentation and start presenting again so that it will start moving.
You can stop and again start presentation. That's what is a suggestion.
Okay, sir. Okay.
Yeah. Right. It's visible now. Fine.
Shall I continue from?
Yes, madam. Please continue.
For software reliability growth model, one parameter relay distribution has been established as a software reliability growth model. Considering failure time of software following relay
Yes, madam, you're disconnected, not able to listen to you as well.
Sorry, sir.
Oh, no problem, madam. Reconnect again, start.
Considering failure time of software following relay distribution with parameter theta and failure occurs in Poisson manner, assuming
madam,
that...
one second, madam. Your PPT is not visible. If you can make that visible, that's fine. Share your PPT. Yeah.
If there is any problem, you can also share a PPT with us so we can present it.
Yes.
Sir, now it is visible?
Yes, madam. Visible.
Considering the failure time of software following relay distribution with parameter theta and failure occurs in Poisson manner, assuming that the total, I have formed this model, then I have obtained failure intensity, assuming that the total number of faults remaining in the program at time t equals to 0 in Poisson manner with mean theta naught. Then the failure intensity is given by this equation. I have obtained this equation. Then I have obtained mean time to failure function, that is expected number of failures. The equation is obtained as, then I have considered non-informative prior as no information is available. the mean failure function. Now considering that for a system, ME failures are observed at time ti up to execution time t, and likelihood function can be obtained with the help of failure intensity and mean failure function. I have obtained this joint posterior distribution function. Then I have obtained this marginal posterior distribution by integrating the joint distribution function. This is for parameter, that is parameter total number of failures. And next I have obtained the Bayesian interval estimation. Bayesian interval estimation, it is an interval estimation which an unobserved parameter value lies with a particular probability. I have obtained this Bayesian interval limits for the parameter gamma naught and gamma 1. This is the lower limit and this is upper limit. To study the performance of sample of size ME was generated from the relay distribution, and it is repeated up to 1000 times, and I have obtained this result. I have calculated average length and coverage probability for parameter gamma naught when execution time is TE equals to 5.
The time is up. Can you close it shortly?
From the table, these are the average length value and coverage probability. Coverage probability is given in the parenthesis. Here we can see that as a value of gamma naught is increasing, the average length decreases and coverage probabilities also decreases. Here I have calculated average length for second parameter, that is gamma 1, for the fixed execution time TE equals to 5. Here again we can see that as the value of gamma naught is increases, average length decreases and coverage probability is also decreases. From this I have concluded that these are my conclusion. Bayes interval has shorter average length and Bayes interval maintain coverage probability, and Bayesian interval preferred in case of less number of failures, and the proposed Bayesian interval preferred for sample size. These are some references I have did. Thank you.
Any questions from the audience?
Yes, sir. I'm asking Dr. Himadri from ISRI.
Yes, please.
Yeah, madam, in your slide, you have used non-infirmity prior. So what is the motive behind using non-infirmity prior? You have not
If information is not available, then we can use non-informative prior.
Yeah, I know. But what is the motive behind using this non-informative prior?
Sir, here I have sir, here is information is not available that failure, how many failures are occurs in fixed time. That's why I use this non-informative prior.
Okay. Another question is that any practical example, real life example for particular study?
Sorry, sir.
Madam, Preeti Madam, what Himadri Shekharji is asking is, can you quote any example or applications of this, uses of this Bayesian interval?
Yes, sir. Yes.
Yeah.
Bayesian interval estimation is usually used for small sample size. When sample size is small, we can prefer Bayesian interval.
Okay, madam, take this as a positive suggestion. What actually being asked is from Dr. Himadri Shekhar Roy is, can you give some applications of that? Small samples is okay. Any applications was the question. Anyway, take that suggestion, positive suggestion. Good presentation, madam. We wish you all the best.
Thank you, sir.
Now, one last presenter is there, last but not least, G. Prabhavati. Madam, are you there?
Yes, sir.
A new version of Adya distribution with real life data.
Yes, sir.
You can start present.
I'm only 5 minutes, sir. Doctor.
Sir, it's visible, sir.
Yes, madam.
Good evening to everyone. Prabhavati, Researcher, Department of Statistics, Annamala University. My title is a new version of Adya distribution with real life data. This is the outline of my presentation. Abstract, introduction, length biased Adya distribution, reliability analysis, moments and associated measures, moment generating function and characteristic function, maximum likelihood estimator, data analysis and conclusion. In this paper, a new version of Adya distribution called length biased Adya distribution for modeling lifetime data is introduced. This has been compared with one parameter Adya distribution. The statistical properties of this distribution have been derived and the model parameters are estimated by using the method of maximum likelihood estimation. Finally, a real lifetime data sets are fitted to this new distribution and if it has been found to be good. The concept of weighted distributions was first given by Fisher in 1934. The weighted distributions are applied in various research areas related to biomedicine, reliability, survival analysis, ecology, and other areas. The weighted distribution reduced to length biased distribution as the weight function consider only the length of units. The concept of length biased sampling was first introduced by Cox in 1969 and Zelan in 1974. Different authors have reviewed and studied the various weighted probability models and illustrated their applications in different field. Kahn et al. In 2018 discussed the weighted modified variable distribution. Rather and Subramanian in 2018 discussed the characterization and estimation of length biased weighted generalized distribution. Afak and Subramanian in 2018 discussed a length biased Sushila distribution. Mariam and Kannan in 2020 discussed a generalization of Dewey distribution with applications to real life data. Recently, Kittipong and Stipa in 2021 discussed the length biased power Garima distribution and its application to model lifetime data. Patil and Rao in 1978 expressed some basic distributions and their length biased form, such as the log normal, gamma, Pareto, and beta distribution. In this paper, our motive is to prove that the length biased Adya distribution is more flexible and fits better in real lifetime data set as compared to Adya distribution. Density function, cumulative distribution function is given by respectively. Then different weighted models, we have different choice of weighted function like W of X. In this paper, we have to find length biased version of Adya distribution. So we will take in C is equal to 1 in weight function in order to length biased Adya distribution and probability density function and corresponding cumulative distribution of that baseline distribution. Then this is the PDF plot of my baseline distribution. Then reliability. In this section, we will discuss about survival function, hazard function, reverse hazard function, and Miles ratio of length biased Adya distribution. Reverse hazard function, reverse hazard rate, then Miles ratio, then moments and associated measures. In this section, we will discuss the baseline distribution, that is length biased Abia distributions, mean, variance, then standard deviations is given by, then moments generating function and characteristic function. In moment generating function using Taylor series, then similarly we can get the characteristic function of length biased Abia distribution, then the maximum likelihood estimator. In this section, we will discuss the maximum likelihood of the parameters of length biased Abia distribution. Then this is the likelihood function, and then log likelihood function. The equations are very difficult to solve. Therefore, we use our Wolfram Mathematica for estimating the parameter. Then data analysis part. This section, a real lifetime data set has been analyzed with length biased Adya distribution is compared to Adya distribution. The following data set is reported by Gross and Clark in 1975, which represent the data relating to relief minutes after receiving the analysis for 20 patients in this is the performance of the distribution. In this table, we have to compare the Adya distribution, then length biased Adya distribution. In order to compare length biased Adya distribution with Adya distribution, we consider the AIC, BIC, AICC, and -2 log L, -2 log L. The better distribution according to lesser values of AIC and BIC values. This is the formula for calculating AIC, BIC, and any sample size, and -2 log L is a maximized value of log likelihood function. Then hence we conclude that length by
Go on with the
next coming to the conclusion. In the present study, we have introduced a new version of Adya distribution, namely length their distribution with one parameter. The subject distribution is generated by using the length biased weighted technique, and parameters have been obtained by using maximum likelihood. Some statistical properties along with reliability function, then distribution functions. The new distribution, its application in real life data has been demonstrated. Finally, the results are compared over Adya distribution and have been found that the length biased Adya distribution provides better fit than Adya distribution. These are the my references, and thank you.
Okay. Any questions in the audience?
Ma'am, which data you have utilized for fitting of this length bias at the distribution?
Sir, I have to choose a set in already published research.
You are not audible, Prabhavati madam. Okay.
Sir?
Not audible. Yeah.
Sir.
Okay. Did you get the question what Dr. Kanchan Sinha was asking?
Sir, I have.
Yeah. Can you give one or two applications of your distributions other than what you just try to mention? One or two more applications.
The time is up. In data.
Okay, then fine. Thank you all for wonderful presentations. It was nice being with all of you. All the best.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you, Dr. Raghunath sir, for chairing this session with such patience, and all the presenters for sharing your expertise with all of us and making this session successful.
Yeah. Thank you all.
Thank you, sir.
Right up.
Okay.
Oh, sir, I'm student.
You are a student of IIT.
I'm student of sir, all respected sir. I'm the student, sir. All others are my teacher respected. Professor Sumesh Kumar, all others. Professor Balakrishna, sir.
I am very happy that Dr. Koduri Srinivas watching all the events of our ISPS.
Very kind of you that included me, sir. I think he attended all the sessions.
Yeah, all the sessions, sir. Very nicely.
Dr. Srinivasan is based in Hyderabad now?
Yes, sir. I do have 2 or 3 major assignments. Sometimes I be expected to go out of Hyderabad also. But mostly these are stories of parallel processing. Then you're dealing with the Internet of Things, standards for IEEE. Then again, coming back, we do have certain problems that Professor Pandit sir has left behind. We need to calculate the eigenvalues for them. Eigenvectors we have already solved, but the eigenvalue problem has remained tough. He has got 8 such transforms. Somesh Kumar sir is from IIT Kharagpur. Am I correct, sir? Yes, sir. Yeah. Professor Pandit was with IIT Kharagpur in the early 60s, sir. Who was Good evening to all. Professor Narahari Pandit. Then Professor Bhattacharya. Yes. Professor Bhattacharya was my examiner. Yes.
Professor S.N. Pandit, S.N. Narahari Pandit.
Yes, sir. Shall we start, sir?
Actually, whether all the halls are free now? I mean, other sessions are over?
Yeah.
All are.
What about D? Hall D?
I mean, we need to confirm the session chairs, sir.
Yeah, please ask Professor Krishna Reddy. He was there in section D, Hall D.
It is completed, sir.
Okay, then fine. Yeah. Okay.
Krishna, the brother.
Professor Reddy Garu, good evening.
Good evening. Elangovan, how are you?
Yeah, fine, sir. Tomorrow is NAC accreditation. Tomorrow on 14, 15, 16. Visit our university.
Oh, Annamala University. You are all going to busy.
14, 15, and 16, 3 days.
So Venkatesh has to present.
Yeah, Venkatesh has to present.
Did Krishna Reddy is there or he left? I think he left. Wow. Krishna Reddy, good evening. Krishna Reddy, good.
Oh, he's there.
Namaskar, sir. Srinivas here. Krishna Reddy, sir.
Yeah.
Srinivas.
Hello. How are you?
Fine, sir.
Yeah.
ఏంటి కృష్ణారెడ్డి గారు ఎలా ఉన్నారు?
Yeah, I am fine, and by end of this month I am
planning to.
Yeah, and I may go to join my son in mid of May.
Oh, Austin. Okay. Yeah. Austin, Houston. Both are you are going.
Yeah, at both places, and
so you are not giving a chance to them to come to Hyderabad and stay with you, and so you are planning to go.
No, they came.
I see. Next month,
my son came in December, January.
Okay, next month BLSP is planning to go. BLSP.
Okay.
He told me that today afternoon that
I am going purely on my family.
Yeah, I know that.
Academic.
Flights and other things, schedule, logistics are worked out, sir.
What, Srinivas?
Flight details and logistics are worked out.
I don't understood.
flight. You're going.
Yes, yeah. My from 27th onwards now all flights will be operational.
Okay.
So yeah, he has not booked the ticket. He's about to book the tickets.
Fine, sir.
Yeah.
So from now onwards, I will be 50% months there and 50 months here.
Oh, that's good, sir. Do you get to see other people, sir? Your senior colleagues like SS sir, Surendra Naidu sir, and
Yes. Yeah. Now,
where are they, sir?
recently, Hargopal arranged a meeting with Surendra Naidu and Srinivas.
Okay.
And also most of your contemporaries, Bhanumurthy, Jayanthi, and about 20 people joined in that Zoom meeting.
Okay. Ramna, Rahul, all these people would also have been part of that.
Yeah.
Another also is there.
Yeah.
All sessions are over.
Yeah. Bhattacharya, yes, my session finished by 4:40.
So I think then everything is over, I believe.
Yeah. Sir, I think it can be started.
Shall we start, sir?
Yeah, I think so.
Yes, sir. Very good evening to all the dignitaries and one and all. It is my great privilege to invite all the dignitaries onto the dais. First, I would like to invite Professor N. Balakrishna sir, Senior Professor ISPS President, Department of Statistics, Cochin University of Science and Technology, Cochin, Kerala. Sir, please occupy the chair. Next, I would like to invite Professor S.C. Malik sir, ISPS General Secretary, Department of Statistics, Maharshi Dayanand University, Rohtak, Haryana. Sir, please occupy the chairs. Next, I would like to invite Professor P. Rajshekar Reddy sir, Honorary President, ISPS, Sri Venkateshwara University, Tirupati, AP. Now, I would like to invite Professor G. Jayashree, Madam, Department of Statistics, Usmania University Convener, ICSDS 2021, and Vice Principal, UCS. Ma'am, please take over the seat, ma'am. Next, I would like to invite Dr. N.C.H. Bhattacharyalu, Head Department of Statistics, OU, Organizing Secretary, ICSDS 2021. Sir, please occupy the chair. Now, I am requesting Professor N. Balakrishna sir. Sir, please preside over the function, sir.
Sir, please unmute. Sir, please unmute.
Please unmute yourself. No, yeah, I repeat. So I see a lot of smile on the faces of Professor Jayashree and Dr. Bhattacharyalu. Now, so they have been under stress and tension during the last, I think 3-4 days actually. So now there seems to be a lot of relief on them. Good. So I think my hearty congratulations to both of you and also your colleagues in the Department of Statistics, Usmania University, for your wonderful work, nicely coordinated and well prepared and well planned. And I think I just want to also mention that the technical group you have hired, they are wonderful. They have done very nice. I don't know whether anybody is there now listening to us. They have done wonderful job. There is no hitch anywhere. Everything was very well planned. Good. I think I should congratulate you for choosing such a very nice, organized people. Good. And also take this opportunity to thank the Usmania University for giving all the or sparing all the facilities to conduct this program nicely. And also, I think I thank all the executive committee members and associate executive committee members for their cooperation throughout the program. And especially today's this award function. I take this opportunity to thank Professor Rashekar Reddy, Dr. Neha Garg, and Dr. Venkateshan and other people who have coordinated the program very well in preparing the citations and certificates and all those things. Everything went on very well, just like camera finish kind of things. So I'm really happy that I'm heading an organization where a lot of committed people are there who are always with us for all sorts of help and cooperation. Thank you very much. And I think I invite some of the delegates to share their experience who have attended the proceedings during the last 3 days. Some tips or some comments about the program coordination, which will help the organizers as well as the ISPS in the future coming conferences.
Yeah, shall I say something? I'm Somesh Kumar here.
Yeah, sure.
Yeah, I would like to congratulate ISPS, the entire ISPS organizing body, for really handling it well. And the first thing is that starting from the initial brochure and the announcement of the conference, people are always in touch with us so that we submit the papers and our abstracts and everything very timely. And then the planning of the scheduling of the talks is also excellent, including the endowment lectures and plenary lectures and all. And second thing I would say that the Department of Statistics of the Osmania University, they were really punctual. Like I received phone calls. They have put some volunteers there. Before every session, actually, they are calling and informing that your talk is there. So that, there is no technical difficulty or person is absent due to some reason. So I think this really calls for a big thank you to all, and big, you can say, shout out to all of them for this excellent effort, actually. And over the years, the Indian Society for Probability and Statistics has actually become the biggest organization of statisticians in India. And for that also, I must thank the senior functionaries like Professor Rashekar Reddy. In fact, he has taken the role of a guardian of this society, so that he is actually able to attract the people from all parts of the country. I have seen the participants; they are from all over India. So no institution is left out. Like we have, like IIT Kharagpur, Indian Statistical Institute, which are already there, but they are covering even colleges and various universities in North India, in western part of the country, and all other parts also. So slowly it has grown big, and I must appreciate the efforts of all the organizers. My prediction is that in the next 5 years, this will cover even much bigger. That your membership numbers may become a double of this, and maybe some sort of publicity in the sense of sending the brochures and all, so that the young researchers, and in fact the people who actually participate, each of them, they can request, or they can inspire their own students or other people to become life members of ISPS. I think that will give a big boost to the visibility. Now I'm going to ask all my students to actually, my former students and the present students, to become members. And likewise, I would request all the dignitaries and other people to do the same thing. I think the base will increase much, and it will be really a good thing for statistics in India. Thank you.
So that's where we are planning a pre-convention workshop for life members. Pre-convention workshop for life members. So when it means life members, so before the conference there will be a convention. So that's why it attracts many scholars to become life members. Okay. So much.
Speak, sir.
Anybody else would like to?
Yes, sir.
Briefly,
I am Professor Ilangovan from Annamalai University, sir. First of all, I thank all organizing committee members, especially Professor Jayashree, other members of the Osmania University, for conducting this ISPS 2021. So I want to place on record the link for each session is given well in advance, and also the presentation session for the contributing speakers is accommodate all the speakers, and I really thankful to the effort made by the organizing committee members. And another thing is the first ISPS president, Professor Sankar Narayan, basically from Annamalai. The department jointly with the mathematics statistics. Now it is separated now. So on behalf of the former president also, we are all the scholars in our department and other staff also listening all the important session. So in my conclusion, I thank all the organizing committee members, especially Professor Balakrishna, Professor Digaru, and also the convener of the conference, Professor Jayashree, for giving an opportunity to thank sir. Thank you, sir. Thank you, one and all.
Prakash Rao here.
Okay, sir.
First of all, I would like to again congratulate the Society, Indian Society of Probability and Statistics for an excellent job. This is within a span of 6 months, they did it twice. So this is remarkable, and I congratulate them. And the wide coverage of subjects that are there, that itself is a miracle here. But I think, in fact, I feel that pandemic has helped us in some way, because several people could participate in this through the webinars. Whereas if you say you need funds for travel and so on, not many could have participated.
Right.
In that way, this is a blessing in disguise. So, and of course, it's always nice to come to a convention and a conference, meet other people in person, get to know and talk to them. That's very important. But in the present circumstances, we couldn't do it. But then it still was helpful. And I have seen, in fact, I have been very busy with so many webinars sitting at home. And so this is what is happening. And of course, the society, in fact, I don't know, several of you, I have met Professor Sankar Narayan in 1976. I went to a conference which he conducted, and at that time he didn't start this society, but then he had the ideas. And I was traveling with him for some time over the years, and I did attend, he had a sort of workshop in Annamalai for about 3 weeks on stochastic process and inference. So I went there, and I remember his hospitality, in typical South Indian style. And then over the years, the society has grown so much. At Delhi, probably, and in those days we didn't have many people, but now it has grown from strength to strength, thanks to the efforts of all the people in the committee, and Professor Rajasekhar Reddy, Professor Balakrishna, Professor Malik, and all the colleagues here and there. And I'm happy. And of course, I'm especially happy to be in part of this society, because you have honored me with this award. And that itself is my association with you, establishes our interest in these things. And I again congratulate the colleagues at Osmania University, Professor Jayashree and Professor Bhattacharya of Osmania University, and all the colleagues at ISPS for an excellent program that has been arranged and conducted. Thank you.
Professor Rajasekhar Reddy used to say a few things about the conference proceedings.
Okay. I am very happy to say a few words on this valedictory function occasion. Actually, earlier we used to organize only 3 days conference earlier. Last time, when Professor Jamlamadka Srinivas Rao has arranged, asked her to do it 1 day workshop for the scholars at Bhubaneswar. From that date, we have decided that every time before conference, we will have pre-convention workshop, which we have done it. And this award ceremony also, because of the many awards, I thought of taking much time at the time of the inaugural function. So that we thought of doing separately this one. That also happened. These two. And now the organizers, every day I used to talk with Jayasri in the evening or even night, 11 o'clock. Also she used to make calls and discussing with me. Somebody is not there, so that, okay, I will do it like chairing the session or this dropping session like that. So, and Bhadracharulu is also in touch with me. And well in advance, we have fixed this workshop audio resource persons. So that all the 9 speakers which they have delivered on first day, and the remaining sessions are also now really went on well. So I am really appreciating Jayasri and Bhadracharulu and their team. Hope BLS Prakash Rao Garu has mentioned that within 6 months we have done September and March. This one 2 conferences, that is 40th and 41st. Sir, apart from that also. Last time while organizing that Shankar Narayan endowment lectures, they have donated 5,22,000 rupees, 3 lectures. And now recently last month we got another donor, M.M. Deshpande Memorial Prize, for which we have received 2.5 lakh. And now we are hoping, confident that because of Professor N. Pandit, there may be now people are ready to donate some money in the name of him and instituting a endowment lecture. So the society is now almost 9 endowment lectures are there to strengthen this one and some type of activities. So I am very happy now the life membership has crossed more than 1,650. With this conference, yesterday also I have received some 4 or 5 members. Maybe another 10 days I am going to get some more members. I am very happy that now slowly our ISPS is spreading throughout all over at India and abroad level also. So I am once again, I am grateful to all the speakers, plenary speakers and executive members, associate executive members for their full cooperation in organizing this event in a befitting manner. So I also congratulate Bhadracharulu and Jayasri and their team for the successful organization. So thank you. Thank
you. Okay. I just have one small comment to make, sir. Can I speak?
Sure, sir. Please go ahead. Yeah.
Thank you for granting me an opportunity, sir. First, the organizers have done a fantastic job. I compliment the society organizers, including your good self. Then, of course, from the Osmania University, Professor Jayasri Madam, Professor Bhadracharulu Garu, they have been, a phenomenal, inspiration for everybody here. Professor Hargopal and so many others are also there who actually were instrumental in bringing a lot of people from the SSN and Pandit's students team. But coming to the point, what I thought I would share with you people is, you are now having the required quorum and you are going great guns. In IEEE, what we do is we have a PhD for scholars forum where, before they come to the conference, they have an opportunity to meet once or twice, get it reviewed, and then actually come to the conference better prepared. So such kind of discussions, if they are facilitated, they will be great, sir. Thank you so much, sir, for granting me an opportunity.
Okay, thank you. Thank you for your suggestion. Yes, Srinivas Rao Garu.
Yeah.
Okay, if not, I think invite Professor Malik to say a few remarks.
Yes, now very good evening to all of you, and it is a time to say a few words about the organizers. Really, I am very much impressed with the organizers, particularly Professor Bhadracharulu, Professor Jayasri. They did very hard work to make each and every event successful. And we did not face any problem technically and manually. Whenever we asked them to arrange any session or any program, they were always ready to manage all these things well in manner. And they did it. Really, I appreciate their efforts. from very beginning of this conference, and they are trying to make this event successful since last many months, maybe because of some problems due to COVID-19. Now I can say that really they deserve for the congratulations. So I congratulate the organizers for sparing your valuable time. I congratulate the university for giving an opportunity to conduct this event, this international event with the joint convention of ISPS. So on the other hand, I also thank all the committee members of ISPS, live members of ISPS for contributing in one way or the other. And the credit goes to our leader, Dr. Professor Balakrishna. Professor Bala,
thank you.
Really, you deserve for this. And we, under your noble leadership, we are always ready to work hard as and when you do so. The credit also goes to Professor Reddy, who was untiring. He was always ready to spare time without any hesitation and without any burden or without any. He is always ready to spare time, really. So we salute you, Professor Reddy. We salute you. And what I observed, there is no doubt that we are conducting this conference at Osmania University, Hyderabad, after a 5 or 6 month gap. And the conference was the prior conference was also conducted through the online mode, which was also a remarkable conference. But this time, this conference somehow cannot be considered as less as the previous one. So really, I did not face any type of problems on the part of the organizers. So many speakers, eminent speakers, presented their contribution in terms of good research work, good findings. And I think about 200 research papers have been presented during these 3 days, and it was not very easy to accommodate all these to about 200 research papers, to invite all such speakers, and every time the problem was not in a position to say a few words against the organizers. Really, they did very well work, and I appreciate the steps. I congratulate the organizers, and I hope that the time will come when they will be ready to conduct this conference physically, I hope. And at that time, we will enjoy their food, their hospitality physically. And I invite the organizers, the ISPS members to come Rohtak, Haryana, MDUC Rohtak. They are always welcome with us. They are always welcome. And I am ready to spare my time in the interest of the ISPS. Whenever you feel like so, then you are free to contact me at any time. So thank you all of you, and congratulations, best wishes to the entire ISPS community, and congratulations to the organizers. Thank you, please. Thank you.
Thank you. Anybody else? Satish or Professor Srinivas Rao? Before leaving the dais to Professor Jayasri and Dr. Tajarilu.
Say two words, Balakrishna.
Yeah, sure. Yeah, yes, please.
Yeah. At the onset, I congratulate the President of ISPS, Honorary President Professor Rajshekar Reddy and other executive members, as well as the organizing committee, Professor Jayasri Bhattacharyalu and their team, for conducting a very nice and successful, it is a grand successful conference. And we are very happy to be a part of it. And even in spite of it is online, there was no single flaw we can point out, because every program is in time and all speakers have delivered their goods exactly in time and also done in an excellent manner. So really we are very happy to have this and participate in this conference.
There is some signal problem, I think.
Also, I should congratulate the present executive inaugural and also making a separate session. It is a highly appreciable thing. And not only that, all efforts that was taken in that, and I advise the organizers of this conference, particularly Jayashree and Bhattacharya, to bring a proceedings of this. And ISPS, particularly the good papers, after reviewing, our journal may take off printing some of the good papers in that, particularly the Journal of ISPS. I am very happy that the conference went on very well. And I once again congratulate all the team members of ISPS as well as the organizing committee for conducting this conference. Thank you. Thanks for the given opportunity.
Thank you. Maybe the final response from somebody, and then we will invite the organizers. Anybody else? Satish? Yeah, please.
In fact, last 3 days, we are in the virtual mode. Even though in the virtual mode, we have been given a feast from the side of the Osmania University. And in fact, the Professor Bhattacharya Lu and Professor Jayashree did a very wonderful work during these days. And they are very sincere towards each and every activities of this conference while organizing the conference. They contacted several times, and even in the night and other time also they are preparing and rescheduling, structuring did a very beautiful work. So on behalf of the ISPS and all assembled here in this group, let us give a big clap to both these two personalities for the successful conduct of this conference.
Okay.
And I'm very much proud to say that our ISPS is now in the developing stage with a geometrical growth with the Trimurtis like Professor Reddy, Professor Balakrishna, and Professor Malik, and with the support of all EC and associate EC members, I'm sure, and with all blessings from the great people like our Prakash Rao and others. We are very much happy and very much glad to be in this moment. After the conduct of our professors are waiting to get relief out of these hard works during these days. I know the efforts while conducting a conference. With all best wishes and great success to our organization, our association, let me to once again thanking you all. Thank you, professors. We expect your blessings and support in future also for the ISP. Thank you all. Thank you so much.
I think now I invite Professor Jayashree, leaving Professor Bhattacharya to conclude. So, Madam, please, now it is your turn. I think you have to unmute.
Thank you, sir. Can you hear me, sir?
Yeah. Now you are audible.
Thank you, sir. A good evening to one and all, the dignitaries on the dais, respected Professor Balakrishna sir, Professor Malik sir, Professor Rajshekhar Reddy sir, Dr. NCH Bhattacharya sir, and I would like to just give a small report on the conference, sir. On the conference. Some of the outcomes of this international conference on statistics and data science, theory and practice for progress and prosperity are 3 plenary talks were delivered on the theme of the conference by Professor BLS Prakash Rao sir, Emeritus Professors, C.R. Rao Institute of AIM, SCS, and former director of Indian Statistical Institute, Calcutta, recipient of Shanti Swarup Bhatnagar Award in Science and Technology, and C.R. Rao Lifetime Achievement Award. Professor Arup Bose, Indian Statistical Institute, Calcutta, and recipient of Shanti Swarup Bhatnagar Award in Science and Technology and Fellow of ISPS. Professor A.M. Mathai, Pala, Kerala, University, Kerala, recipient of Founders Award from the Statistical Society of Canada. We are very thankful to you, sir, for delivering these lectures. And on the theme of the conference, talks were delivered by Professor P.G. Sankaran under Professor P.V. Sukhatme Endowment Lecture, Professor K. Srinivasa Rao under Professor R. Ravanan Endowment Lecture, Professor Debasis Kundu under Professor A.M. Mathai Endowment Lecture, Professor Isha Diwan under Professor Y.C. Narsimulu Endowment Lecture, Professor Somesh Kumar under Professor D.D. Hanagal Endowment Lecture, Professor C. Raghavendra Rao under MP Sastry Endowment Lecture, and a series of 3 lectures were given by Professor G. Arivarignan sir, Professor S. Udayabhaskaran, and Professor Tangarajan under Professor G. Sankaranarayanan Symposium Lectures. Professor M. Vishnuvardhan Rao, Professor V.V. Haragopal, Professor Subramanyam, and Mr. Kaundinya Vajha delivered their talks under Professor S.N. Narahari Pandit Memorial Lectures. 34 sessional invited talks on the theme of the conference were delivered by distinguished senior professors and professors. Out of 201 papers received, research papers received, 122 contributory papers were presented in the conference. The sessions were chaired by 65 distinguished senior professors and professors. I am thankful to all the senior professors and professors for readily accepting our invitation and taking time to conduct these sessions out of their busy schedule. And thank you for delivering the lectures whenever we approached them for delivering an invited talk. I take this opportunity to thank Professor N. Balakrishna, Professor S.C. Malik, Professor P. Rajashekar Reddy sir, Professor Satish Kumar, Dr. Venkateshwaran for their suggestions and kind cooperation. Whenever I called, they were always ready to help me and always ready with the suggestions. And I'm very, very thankful to all of you, sir. Without your suggestions, it couldn't be successful. And thank you very much for all that, sir. And I thank our organizing secretary, Dr. N.C.H. Bhattacharyalu, sir, for his work since 3 to 4 months. And without his cooperation, his suggestions, I couldn't have done it. Thank you all. Thank you very much, all of you who have made it a big success. Thank you.
Okay. Thank you, Professor Bhattacharyalu. You may take over now. Maybe you may close with your order of thanks also.
Yes, sir. Good evening to all.
You could keep your camera on. Yeah, you are visible.
Respected Professor N. Balakrishna Garu, President ISPS, and Professor S. Malik Garu, General Secretary, and Honorary President Professor Rajashekar Reddy Garu, and Professor G. Jayasri, convener of this conference, and respected senior professors, research scholars, scientists, and students. Good afternoon to all. It is my privilege to say the vote of thanks to all the members who are involved either directly or indirectly for making this conference as grand success. It is a great pleasure for us hosting of the 41st Annual Conference of Indian Society for Probability and Statistics in Osmania University. We are treating that it is honor for us. We are grateful to Professor Rajsekhar Reddy Garu for giving a chance to us to host this conference in the Osmania University by keeping confidence on us by considering our request. Thank you very much, sir. And on the behalf of the Department of Statistics, Osmania University, first and foremost, we are grateful to Professor N. Balakrishna, President ISPS, and Professor S.C. Malik, General Secretary ISPS, and Professor P. Rajsekhar Reddy, Honorary President ISPS, for their unconditional support and in suggesting the speakers, chairs, and for various talks and sessions. And also I'm very much thankful to Professor Satish Kumar for unconditional support. I'm sorry, sir, we are disturbing many times, even the nights, for identity. So we are disturbing and conducting the meeting and taking the suggestions and scheduling. And because it is a very big schedule, so that what had taken the previous from the Professor Satish Kumar and Professor N. Balakrishna Garu, the related to the same. We are grateful to the speakers, Professor Ashish Chakravarti, Professor Anup Chaturvedi, Professor Somesh Kumar, Professor Ravi Surdi, Professor M. Krishna Reddy Garu, and Professor Kodur Srinivas, Dr. R. Vishnuvardhan, for accepting our invitation and delivering the inspirational talk in the virtual workshop on the innovations on data and statistical sciences. So thank you very much for the delivering the talks, for your kind acceptance. And also we are thankful to Professor Rajsekhar Reddy Garu for guiding and taking consent for the speakers for the workshop. So thank you very much, sir. Without your cooperation, we cannot continue and we cannot find out the distinguished this professors. We are grateful to the speakers, Professor B.L.S. Prakash Rao Garu, Professor Arup Bush, and Professor A.M. Mattai for accepting our request and delivering the thought-provoking and inspirational the plenary talks. So thank you very much, sir. And we are also grateful to all the delivered lectures, Professor Anup Chaturvedi, Professor Somesh Kumar, and Professor Krishna Reddy Garu. And we are also thankful to Professor K. Srinivas Rao Garu, Professor Devashish Kundu, Professor Isha Diwan, Professor Somesh Kumar, Professor Raghavendra Rao, Professor Arvir Vignan, Professor Uday Sankaran Tangarajan, and Professor Vishnuvardhan, and Professor Haragopal, and Dr. Kaundinya and Dr. Y.V. Subramanian for endowment and the symposium talks. Thank you very much for, and so I'm very much thankful to all the speakers for coming and joining in time and as per the schedule, and out of the total, the schedule of the 34, the sessional talks and the 13, the endowment and the other talks, and 3 plenary talks. Only one we missed it, and all the other sessions are conducted as per the schedule that what we have prepared it. So thank you for each and every speaker who have spent more time and also cooperating. Without your cooperation and without your support, it is very difficult for us to make it success. And Professor S.C. Malik, Professor N. Balakrishna, Professor P.R. Vittal, Professor D.S. Uda, Professor K.K. Joshi, Professor T. Ramanathan, Professor Sudhis Kattumane, Professor C. Satish Kumar, Professor Loganathan Sir, Professor Elangovan, Professor Sandamarai Kannan, Professor Tirupati Rao, Dr. Latpate, Dr. Nehagar, Dr. R. Vishnuvardhan, Professor Abdul Sattar, Dr. Manoj Chako, Dr. Isha Patik Das, Dr. B.G. Manjunath, Dr. V. Kaviyarsu, Dr. P.K. Swain, Dr. Bindu Krishnan, Dr. Ananya Lahari, Dr. B.N. Mandal, and Dr. Ramakrishnan, and if any other that we miss, please excuse, and we are very much thankful to each and every speaker. And we are also thankful to all the professors chaired the sessions of the invited talks and contributory talks. So around 65 the chairing sessions, which are with a short span of time, within minutes, they are readily occupied the chair and conducted without any disturbances. And we are also thankful to all my colleagues of the department, Dr. S.A. Jyotirani, Dr. G. Sirisha, Dr. M. Raghavendra Sharma, and Dr. Bishop J.L. Padmasri. And also, I'm thankful to the my post-graduation students and who are continuously monitoring the 4 sessions by allotted to them, and the Himaja, Harshita, Haripriya, and Manasa. And also thankful to the total coordination taken by my research scholars, Dr. C.H. Anusha, Ranjita, and Swarnalata, and who are directly involved or not directly involved in the workshop and conference. For all them, that I'm very much thankful to all the members who have cooperated. And also we are thankful to Madan Murthy, Basiruddin, Kiran, Lakshmi Prabha, and their team from Video Technologies for developing the virtual platform for the delegates or speakers without any interruption in telecasting, and also telecasting through YouTube simultaneously. And we are, as for even today, so more than the 250 plus they're viewing the YouTube on live. And we are apologizing for any inconvenience made, either unwantedly, whatever that is happened. Please don't mind, and we are apologizing. And the speakers or chairs or contributory speakers for the inconvenience, whatever it is made. Thank you to one and all.
Okay, so thank you all for staying till the late evening, and I wish that we will join for the physical conference during the 42nd annual convention to be held at Cochin in January 1st week of 2023.
Yes, we will be there. Best wishes in advance.
Okay, thank you. See you all again. Bye.
Okay, bye.
We will be meeting. Hopefully, we will be meeting there physically.
Yeah.
Okay, sir.
Thank you, sir. Thank you very much.
Thank you, everybody.
Goodbye, everybody, and happy.
Okay, sir. Bye. See you again.
Very memorable event, sir. Thank you very much.
Thank you.
Particular thanks are also due to Rajsekhar Reddy garu for taking all the pains. Namaskar, sir. Prakash Rao garu. We are really grateful that you have been a great mentor here for us.
Yes, sir.
I'm thankful to the donors, Sai Sudhir Degree and PG College for major conducting of this conference, and also Jahanavi Degree and group of institutions. Thank you, sir.
Thank you.
Let us have a big party at our own respective places.
Okay.
In fact, we missed the physical presence at the Osmania University. It was a great missing because this Professor Bhattacharya Lu and the team,
Satish Kumar
sir and Rajsekhar Reddy sir, and S.C. Malik sir, you have helped in great in arranging the
programs, right? Yeah, programs. program scheduling committee.
It may not be success.
Webmaster also must be thanked, sir. Webmaster must be thanked.
We shall try our best to visit your university.
Satish, Satish, you may
Yes, sir.
free in September. May not plan
Okay.
any programs in September because
I think Professor Satish and Professor Reddy are competing for conferences.
So that's why well in advance I am putting a request not to organize that time.
to avoid any collision.
Okay.
Surely, Professor,
Bye.
surely.
Okay, sir, let us take rest for some time.
Come on.
Yeah. Now I am
Bye
sitting
bye.
with
Bye.
The session will be ended with Janagana Mana, sir.
Thank you, madam. Thank you.
Yeah, if you
Oh,
wish.
Neha came.
Yeah.
Okay.
Thank you.
There is a Janagana Mana.
Okay.
National anthem.
All right.
Yes.
No.
That's fine.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल वंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
மேல இருக்கு 4 PhD 40 மார்க் சாலிடா அந்த தேர்ட் காலம் வந்துரும் 100 மார்க் கண்டிப்பா.
Yeah, I mean, this was not planned actually. It's good.
Good. Ending is good. Very good. So closing also very good.
Yeah.